Hello everyone, I am Balaji Rao. Welcome to BR Maths class. I am very happy to inform you that we started a new batch. Batch name is JE Mathematics 2026. Till now, we completed 5 chapters in basic mathematics. These are the topics till now we completed in this basic mathematics chapter. In case if you not watched those videos, please find the playlist of basic mathematics. Now we are going to start our first chapter in this JE Mathematics 2026 batch. That first chapter is sets. Actually, I thought of doing sets chapter directly objective. But those who are doing this sets chapter first time, you must have knowledge of sets chapter NCERT level. That's why this video is completely, it's like a one-shot video on complete NCERT set. This video is around 7 hours time length is there. Do not worry. For every exercise, for every problem, I'll give timestamps so you can directly go to that particular problem or particular definition wherever you want. I recommend you to watch this video with a speed of 1.5 to get a good experience. In this 7 hours video, I covered all the exercises, all the definitions, all the properties, including miscellaneous exercise problems. So this is the schedule of coming chapters. You can check the schedule also, whatever the coming days, whatever the chapters we are going to do in this month of February. How to learn this sets chapter? What are the key points? Understand the definition of set clearly. More importantly, you try to understand the examples for not a set, right? So we discussed all those things in this types of sets. Different types of sets: null set, subset, power set, superset, universal set. Learn all the types of sets, right? You can divide this into total 3 parts. That first part is learning what is set and all the types of sets. Second part is operations on sets. How we will do union of sets, intersection of sets, difference of sets, complements of a set. And this is important: properties, union of sets properties, intersection of sets properties, difference of sets properties, complements of set properties, all those things we discussed here. This part is important. And when it comes to JE, most of the time the questions they are asking from the formulas related to N of A union B, N of A union B union C, Venn diagrams related to it, and problems related to these formulas. This chapter is easy. Before going to do objective problems, it is important you must be good in NCERT level. That's why this complete one-shot video on sets chapter NCERT. I hope you like the efforts. Please share this video with your friends. Drop a like for this video. If you have any doubts, comment below. Hello everyone, I am Balaji Rao. Welcome to BR Maths class. This is first class on sets chapter. Is this sets chapter is important? Actually, sets chapter is very important. We use this chapter almost everywhere in class 11 as well as class 12. More frequently, sets, relations, functions is a combo. Like if you understand sets very well, then you can understand relations as well as functions. If you have grip on sets chapter, we use this sets concepts very frequently in relations as well as functions. So understanding sets chapter is very important. In this theory, what things you will learn? You will learn what is set and few examples to understand the definition of a set, and we will discuss examples for sets and we will discuss examples for not a set also. And very important, we will learn how we represent a set. In representation of a set, total 2 methods are there. One is set builder method, another one is roster method. Once if you are good in these 2 things like definition of set and representation of a set, then you are ready to do first exercise problem. Without much delay, let's begin the class. So the first point is, what is set? A well-defined collection of objects is called a set. Here you need to observe 2 words. First one is well-defined and second one is objects. What are known as objects? In mathematical language, all the things which is either living or non-living are known as objects. A well-defined collection of objects is called a set. Well-defined. We'll try to understand What is this well-defined collection of objects? Objects means what? Object means things which are either living or non-living. Well-defined collection of objects. We'll try to understand what is this well-defined with few examples. Collection of vowels in English alphabet is a set or not? Collection of vowels in English alphabet. Vowels in English alphabet are well-defined or not? What are the vowels in English alphabet? What are the vowels in English alphabet? Everybody knows that A, E, I, O, U are the vowels in English alphabet. So, collection of vowels in English alphabet. What the point is, vowels in English alphabet is well defined or not? Yes, vowels in English alphabet is well defined. So, collection of vowels in English alphabet is a set. It is a set. Now, we will try to understand this with one more example. Collection of all natural numbers. Natural numbers. Natural numbers are well defined or not? What are the natural numbers? 1, 2, 3, 4 like that. All those are natural numbers. So, natural numbers are well defined or not? Yes, natural numbers are well defined. So, collection of all natural numbers is a set or not? Yes, it is a set. We will try to understand this with one more example. You observe this collection of all beautiful girls in a class. You observe this beautiful girls in a class. Collection of beautiful girls in a class. Here the point is this beautiful girl is well defined or not. If we consider a particular girl, that girl may be beautiful to you. The same girl may not be beautiful to your friend. So, beautiful girl is not well defined. This word beautiful girl, good girls, those things are not well defined. So, collection of beautiful girls in a class is not a set. Now, we will try to understand this with one more example. You observe here collection of good teachers in a college. Good teacher. Suppose a particular teacher, you may feel that that teacher is good. The other person may not feel that the same teacher is a good teacher. So, good teacher, the word itself, it is a vague term. It is not well defined. Good teacher is not well defined. So, collection of all good teachers in a college is not a set. Why it is not a set? Because good teacher is not well defined. A particular teacher may be your favorite teacher. The same teacher may not be favorite to your friend. So, good teacher is not well defined. I hope you understand the definition of set. Now, we will learn important note related to this definition. See, here objects in a set are called elements. Objects in a set are called elements. For example, you see this collection of all natural numbers is a set. So here what are the objects? Natural numbers are the objects. 1, 2, 3, 4 like that. So all those objects are objects in a set are called elements. So 1 is element in this set, 2 is element in this set, like that. Objects in a set are called elements. And second point is, in general, sets are denoted by capital letters A, B, C, and elements are denoted by small letter A, B, C. Now, the second synopsis is representation of a set. How we represent a set. First method is roster method. Roster method is also known as tabular method. Second method is set builder method, which is also known as rule method. First, we will try to understand what is roster method. In roster method, all the elements of a set are listed and they are separated by commas within curve brackets. What is roster method? In roster method, all the elements of a set are listed and separated by commas within curved brackets. We will try to understand this with two examples. First example, we know that collection of vowels in English alphabet is a set because vowels in English alphabet are well defined. How we represent this set in roster method? How we represent this set in roster method? What is roster method? In roster method, all the elements of a set are listed. And here what I will do now, I will list all the elements of this set. What are the elements of this set? Vowels in English alphabet. You list A, E, I, O, U. All the elements of a set are listed and separated by commas. Okay, you separate them commas within brackets. So You observe here, all the elements of this set are listed and separated by commas within the brackets. So this is known as roster method, roster representation of a set. We know that generally sets are represented by capital letters. So I can write this set like this. This type of representation is known as roster method. Roster method is also known as tabular method. We'll try to understand this with one more example. Collection of prime numbers less than 5. We know that prime numbers are well defined and they are clearly saying that less than 5. So this is a set or not? Collection of prime numbers less than 5 is a set or not? Yes, it is a set. So how we represent this set in roster method? What is roster method? In roster method, all the elements of a set are listed and separated by commas within the brackets. So you list all the prime numbers which are less than 5. What are the prime numbers which are less than 5? 2, 3. Prime numbers less than 5 are listed and separated by commas within brackets. So this is representation of this set in which method? Roster method. Generally sets are denoted by capital letters, so this set I can represent like this. So this type of representation of a set is known as roster method, which is also known as tabular method. Now we will try to understand what is set builder method. Set builder method. In this method, all the elements of a set are represented by with its single common property. All the elements of a set are represented by with its single common property. We will try to understand how we represent a set in set builder method by using an example. I'll consider the same example what is there here. You observe collection of vowels in English alphabet. Here, this type of representation is known as roster method. Now, how we represent same set in set builder method? See, I'll take this set as A. How we represent? We represent like that. X says that what is the common property? X is a vowel in English alphabet. You observe here, all the elements of this set are like X. What is X? X is a vowel in English alphabet. So this is the representation of this set in set builder method. You observe here, I consider the example collection of prime numbers less than 5. You see here same example I taken. Here this is the representation of this set in roster method. How we represent the same set in set builder method? We represent all the elements with its common property. It is an element like X. What is X? X is a prime number. X is prime number. And what you will say about X? X is less than 5. What happened? Here all the elements of this set is represented with its common property. So in this way we represent a set in both the methods. I hope you understand what is roster method and what is set builder method. Now we will do exercise number 1.1 solutions. You observe the question what they are asking. Which of the following are sets? You need to observe the following questions and you need to identify are they sets or not. Justify your answer. You need to write why you are saying it is a set, why you are saying it is not a set. You observe this one. The collection of all months of a year begin with letter J. Collection of all months of a year begin with letter J. This collection is well defined or not? Let me try. Collection of months of a year begin with letter J. For example, January is a month which begin with letter J. Next, June is a month which begin with letter J. Next, July. That's it. These three are the months which begin with letter J. So, collection of months of a year which begin with letter J well defined. So, what I'll write here, this collection is well defined. This collection is well defined. It doesn't varies from person to person. So, what I can say, therefore, this collection is a set. So I'll write here, it is a set. I hope you understand this. Only the thing you need to observe from the question is, whatever the collection they are doing, is it is well defined or not. Okay, now you observe this second bit. The collection of 10 most talented writers of India. Most talented writers. Most talented writer means in what sense? Some writers write stories very well. Some writers write poet very well. Some writers write crime stories very well. In what sense they are asking most talented writer? If someone asks me to write most talented writers, I'll write some names. If I ask some other person to write most talented writers, that names may vary. Here, this collection is not well defined. This collection is not well defined. So, I can conclude that this collection is not a set. You observe this third bit. A team of 11 best cricket batsmen of the world. Best cricket batsmen of the world. This collection also varies from person to person. If someone asks me to write best cricket batsmen of the world, I may write some names like Sachin, Viv Richards, like that. If I ask same thing to some other person, they may write different names. Here, best cricket batsman, this varies from person to person. Sachin Tendulkar is best cricket batsman for me, but it may not be for other, right? So this collection is not well defined. So what I can say that it is not a set. This collection is not a set. So what is the answer for this? This collection is not well defined. See, very simple here. Most talented writers, best cricket batsman, intelligent boy in a class, these are vague terms actually. So these things are not a set. Okay, a team of 11 best cricket batsmen of the world is not a set. Now you observe the fourth bit. The collection of all boys in your class. Collection of all boys in your class. In a class, can we identify easily who is boy, who is girl? Yes, gender is well defined. So this collection is well defined. So we can say that it is a set. The collection of boys in your class is well defined. So I can say that this collection is a set. Now you observe this fifth bit. The collection of all natural numbers less than 100. What are natural numbers less than 100? Those who completed 10th standard or 7th standard, they can easily identify what are natural numbers. Here, this collection is collection of natural numbers less than 100. If I ask you to write collection of natural numbers less than 100, you will write like this: 1, 2, 3 up to 99. This doesn't varies from person to person, right? So natural numbers less than 100 are well defined. This collection is well defined. So I can say that this collection is a set. So this collection is well defined. Therefore, it is a set. Observe this bit. A collection of novels written by the writer Munshi Premchand. Here you can observe they are not asking most talented or something like that. They are asking the collection of novels written by the writer Munshi Premchand. A particular novelist novels. We can collect the novels published by Munshi Premchand. So here this collection is well defined. So I can say that it is a set. I hope you are understanding. Here only the thing you need to identify, whatever the collection they are asking, is it well defined or not. If it is well defined, then we say that it is a set. If it is not well defined, then we say that it is not a set. Okay, the collection of all even integers. What are even integers? 0. I hope you know that 0 is a even integer. Okay, 0 is even integer. 0 plus or minus 2 plus or minus 4 plus or minus 6. All these are even integers. So even integers are well defined. So what I can say, when the collection is well defined, I can say that it is a set. This collection is well defined. Therefore, it is a set. Okay, the next bit you see. This is 8th bit. The collection of questions in this chapter. The collection of questions in this chapter. We can collect whatever the questions given in this chapter. It's not a big thing to identify. Yes, collection of questions in this chapter is well defined. So I can say that this collection is a set. Okay. See this one. A collection of most dangerous animals of the world. Most dangerous animal, most talented writer, most best cricket batsman. These are not well defined. See, most dangerous animal. This may vary from person to person. See, for me, tiger is most dangerous. But nowadays we can see on televisions so many people are playing with tigers, especially in Arab countries. Some of them are tigers as a pets, right? So for them, tiger is not most dangerous, right? Some people may feel that dog is most dangerous animal, but so many people are having dogs as pets. So here, this collection varies from person to person. So what I can say, this collection is not well defined, so that I can say that it is not a set. You observe, this collection is not well defined, so we can say that it is not a set. I hope you understand the first question of exercise number 1.1. Now we will move to second question in exercise number 1.1. You observe what they are asked. They given a set 1, 2, 3, 4, 5, 6. Now what they are asking, insert the appropriate symbol. See, this symbol is known as belongs. This symbol is known as does not belongs. Okay, in the blank spaces. Okay, they given here some bits. By seeing that, you need to say that we know that these are the objects in a set are called elements. These are the elements. We need to say that this particular element belongs to this set or not. Here you observe this first bit, they given like this. You need to fill with appropriate symbol belongs or does not belong. 5 belongs to set A or not. You observe 5 is the element present in set A. You can see here 5 is present in set A. So what I can say, 5 is element in set A. So I can say that 5 belongs to set A. 5 is element in set A. Okay. Now you observe here second bit. Second bit you observe 8 is there in set A. You see set A, in set A 8 is not present. So what I can say, as 8 is not in set A, I can easily say that 8 does not belongs to set A. It's a very simple thing. If element is there in set A, then that element belongs to set A. If element is not in set A, then that element does not belongs to set A. You see third bit, 0 belongs or does not belongs. You look in the set A. 0 is there in this set A? No. So what I can say that 0 does not belongs to set A. Now come to this. 4 is there in set A? 4 is there in set A? Yes, 4 is there in set A. So what symbol I need to write? Answer. 4 belongs to set A. Now 2 belongs to set A. You observe 2 is there in set A? Yes, 2 is there in set A. So I can say that 2 belongs to set A. Now 10 belongs to set A or not. You observe in this set 10 is there? No, in this set 10 is not there. So what I can say that 10 does not belongs to set A. I hope you understand second question. Actually, it is very easy. You observe this third question, what they are asking. Write the following sets in roster form. You know what is roster form. In roster method, all the elements of a set are listed and separated by commas within the brackets. You observe all these sets, they are all in set builder form. In theory part related to first exercise, we know what is roster method, what is set builder method. If you observe, all these are in set builder method. They are asking us to write the sets in roster form. Okay, let's see what is first bit. A equal to X. X is an element in set A such that X is an integer. They are saying that X is an integer. We know what are integers. What are integers? 0, plus or minus 1, plus or minus 2, plus or minus 3. These are all integers. And that integer must be in between minus 3 and 7. If they given like this, minus 3 less than x less than 7, it means that x value must lies in between minus 3 and 7. Okay, we need to write this set in roster form. To understand you it more clearly, I'll write the number line first. You see, I marked a number line. On the number line, I written order of integers. You can observe here number line is there. I written these numbers as per their order. Okay, what they are asking, we need to write an integer. Okay, we need to list an integer. Roster method means what? We need to list the elements. What elements? Which is an integer, and that integer must lies in between -3 and 7. So you observe here, I'll start like this. Set A. I need to list all these elements. It is an integer and which is in between -3 and 7. What are there which are in between -3 and 7? You can observe here, these are the integers. You can observe here, these are the integers which are in between -3 and 7. Here, if they given less than or equal to, then -3 also included. But they're not given like that. They're given strictly less than. So we cannot include -3. So what are integers in between -3 and 7? -2, -1, 0, 1, 2, 3, 4, 5, 6. So you can observe these are the integers which are in between -3 and 7. I hope you understand. What they are asking in the question, which of the following sets? Write the following sets in roster form. You observe here, I listed all the elements and separated by commas within the brackets. That means I written given set in roster form. Okay. Now we'll move to second bit. What they are asking, x such that, you observe the second bit, x such that x is a natural number less than 6. Actually, this set is in set builder method. Elements of a set are represented with its property. Now we need to write this set in roster form. In roster method, all the elements of a set are listed and separated by commas within the bracket. It is very easy bit only. We can easily say what are the natural numbers which are less than 6. Yes, what are the natural numbers which are less than 6? 1, 2, 3, 4, 5. The main thing you need to observe, as they are asking us to write this in roster form, you can observe all the elements of a set are listed and separated by commas within the bracket. So given set I written in roster form. I hope you understand this. Now let's move to third bit. What they are asking in the third bit, you see this set is in set builder form. Elements are represented with its property. Okay. X says that x is a 2-digit natural number. Clear. It is a 2-digit natural number such that the sum of its digits is 8. So we need to list all 2-digit natural numbers whose sum is 8 so that we can write this into roster form. Okay. 2-digit natural number 08. If I write 08, sum of these digits is 8. But is a 2-digit natural number? Actually, 8 is a single digit natural number. So you cannot write 8. So if I move to 2-digit natural number 17, clearly it is a 2-digit natural number and sum of digits 1 plus 7 is 8. Okay, 17 listed. Now in 20th series, 26, clearly it is a 2-digit natural number. Sum of digits 2 plus 6 is 8. Now 30th series, 35, it is a 2-digit natural number and sum of digits is 8. Next 44, next 53, correct, it is a 2-digit natural number, sum of digits is 8. Next 62, next 71, next 80. Is 80 is a 2-digit natural number? Yes, 100%. 80 is a 2-digit natural number. Is sum of digits is 8? Yes, 8 plus 0 is 8. So we can easily say that 80 is a 2-digit natural number. Sum of digits is 8. So what happened in this question? All the elements are represented with its property. But what I did here, all the elements of a set are listed and separated by commas within the brackets. That means the set is represented in roster form. Okay, you see this one, x says that x is a prime number which is a divisor of 60. This is also in set builder form. We need to write it into roster form. Okay, what they are saying, x is a prime number. Okay, which is the divisor of 60. So that means you need to identify the prime numbers which are divisors of 60. For example, you take 2. 2 is a prime number. Yes, 2 is a prime number. 2 is a divisor of 60. Yes, 2 divides 60. Yes, we know that 30 times, right? 2 is a divisor. 2 is a divisor of 60. 2 is a prime number. So 2 is prime number as well as it is divisor of 60. Now next prime number I will take 3. 3 is a prime number. It's very clear. And 3 is a divisor of 60. 3 is a divisor of 60. Yes, it is divisor. It is divisor. Yes. So 3 is a prime number. It is a divisor of 60. Next prime number is 5. 5 is a prime number and is a divisor of 60? Yes, 5 12s are 60. So next after 5, if I write 6, first of all, it is not a prime number. So you cannot write 6. And even though it is a divisor of 60, we know that 6 into 10. Even though 6 is a divisor of 60, as 6 is not a prime number, you cannot write 6 here. Like that, you check for the prime numbers which are the divisors of 60. You won't find any other prime number which divides 60. So 2, 3, 5. These are the prime numbers and as well as these are the divisors of 60. So in the question they given all the elements in set builder method. All the elements are represented with its property. Now all the elements are listed and separated by commas within the bracket. So I written given set in roster form. Okay. Now you see this fifth bit. What they are asking? The set of all letters in the word trigonometry. Set of all letters in the word trigonometry. This is in the definition form actually, right? We need to write this collection in roster form. In roster form, what we'll do? We'll list all the elements and separated by commas. Okay. Look here. In this, you need to identify what letters are there. T is there. Okay. T I'll write. Next comma. R is there. Right. Okay. Next I is there. Okay. Next G is there. Okay. Next O is there. Okay. Till here, no problem. Okay. Next, after O, N is there. This is also okay. After N, O is there. You observe here O, but actually O is already listed. No need to list again. In roster method, we list the element. Once listed, no need to list again. Here O is there 2 times. So you no need to write 2 times in roster form. This is important point. While what is roster method? In roster method, all the elements of a set are listed. Here O is element of this collection. O is already listed. No need to list it again. I hope you understand. Now this no need to write. Next M. Yes, we need to list it. M. Next E. E is not yet listed. Okay. E. T. After E, T is there. You can observe T is already listed. R. R is also already listed. Now Y. 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 Very good. So what happened here? I listed all the elements, all the letters of the word trigonometry. So they given the question in the definition form. I written in set representation. That representation is roster form. In case the same question, if they ask you to write in set builder form, we'll write like this. E equal to X such that X is a letter in the word trigonometry. Okay, right. Now you see this sixth bit. What they are asking in the sixth bit, the set of all letters of the word better. This is also similar to above problem. Okay, the set of all letters of the word better. So B is there. Okay, E is there. Okay, T is there. Here T is there again. T came 2 times. T is already listed. No need to list it again. Okay, E. E is already listed. No need to list it again. R. R. Okay. B. E. T. R. Better. So here the question is given in definition form. I written all the elements. I listed all the elements separated by commas within the brackets. You know what is roster form. In roster method, all the elements of a set are listed and separated by commas within the brackets. Okay, please observe this question number 4. What they are asking, write the following sets in set builder form. You can observe all these questions are given in roster form. All the elements are listed separated by commas within the bracket. We need to represent these sets in set builder form. What is set builder form? In set builder form, all the elements are represented with its property. Here, in set builder form, all the elements of a set are represented with its property. You observe this is the first bit. Actually, this is in which form? This is in roster form. All the elements are listed and separated by commas within the bracket. Here, important thing you need to know is while writing the roster form into set builder form, answer looks little different from person to person. In first bit only, I'll try to explain how it may vary. Okay, you observe the elements 3, this is 6, 9, 12. Actually, 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. This is like all these are multiples of 3. So if I want to write this set in set builder form, I'll write like this. X says that what is X? X is a multiple of 3, which I'll specify like this. X equal to 3n. And what about n? N is a natural number which is less than 4, like 1, 2, 3, 4. See, this is the method. I felt that this is the one. I felt that it is very easy. You observe X is what? X is, it is like 3n. What is n? In place of n, you can write 1, 2, 3, 4. Suppose in place of n, if I put 1, 3 into 1, I'll get the first element. Okay, 3 into 1 is 3. In place of n, if I write 2, 3 into 2, 6. In place of n, if I write 3, 3 into 3, 9. In place of n, if I write 4, 3 into 4 is 12. The same set you can write like this also. How? X says that X equal to 3n and X and n is a natural number. N is a natural number less than 5. So, you see here, actually both gives the same meaning. This set also gives this set only. If I write like this, this also gives the same meaning of this set. So here important thing is which one we feel easier, that we'll write. So I felt that first one is easy, so I'll keep that one only. But you keep this in your mind, from person to person, answer may vary. What I am writing here, that answer and what answer is there in textbook, that may different. But the point is, we need to make the things simpler. I don't want to make the things complicated. Okay, now you see the second bit. 2, 4, 8, 16, 32. If you observe them, are they are multiples of 2? 2 ones are, 2 twos are, 2 threes are 6. But 6 is not in this. So this is not in the form of a multiple of 2. If you observe more clearly, this is like 2 power 1, 2 power 2, 2 power 3. 2 power 3 is 8. 2 power 4, 2 power 5. So we can observe that these elements are of the form 2 power n. So in what way I can write this set? This set can be written like this. X says that X is in the form of 2 power n. What about when n? I'll write here, where n equal to 1, 2, 3, 4, 5. As this set is very smaller set, writing like this is very easy. Suppose this pattern is continued up to 2 power 99 or something like that. In that case, I'll write that X is a natural number less than 100. Okay. So this is the easy way of representing the set in set builder form for the given set. I hope you are understanding. They are asking us to write given sets in set builder form. In set builder form, elements are represented with its property. So here, these elements I represented with its property. Now, you observe the third bit. This is like 5 power 1, 5 power 2, 5 power 3, 5 power 4. Again, this is of the form 5 power n. So the above bit and this bit are very similar, right? So I'll try to write like this. X says that X is what? X is 5 power n. What about n, where n is 1, 1, 2, 3, 4. In place of n, if I write 1, 5 power 1 is 5. In place of n, if I write 2, 5 square is 25. In place of n, if I write 3, 5 cube is 125. In place of n, if I write 4, 5 power 4 is 625. Very easy way of writing this. I felt that this is very easy way of writing given set in set builder form. I hope you are understanding. Now you come to this fourth bit. What they given here? 2, 4, 6 and so on. So how to write this set in set builder form? X says that what I want to write like this: x equal to 2n and what is n here? N is a natural number because it's an infinite set. You can observe here what are natural numbers: 1, 2, 3, 4, 5, 6 and so on like that. In place of n, if I put 1, 2 into 1, 2 I'll get. In place of n, if I write 2, 2 into 2, 4 I'll get. In place of n, if I write 3, 2 into 3, 6 I'll get. In place of n, if I write 4, 2 into 4, 8 I'll get. This is the one way of writing here. Here you observe I not written where n equal to 1, 2, 3, 4 and so on. I just simply written that n is a natural number, or else the same thing you can write like this. This set you can write like this. X says that x is even natural number. Even natural number. This is also 100% correct. Actually, both the things gives the same meaning. So that's what I am saying. While writing given set into set builder form, person to person answer may vary. You need not to confuse. The only thing you need to identify that if both gives the same meaning or not. So here I felt that this is okay for me. So I'll keep this answer. If you felt that this is more suitable answer, then you can keep it. Okay. I hope you understand how to write given sets when given sets are in roster form, how to write into set builder form. You observe this last question: 1, 4, 3 like that 100. What form it is actually? Like n square form, I think. In place of n, if I write 1, 1 square is 1. In place of n, if I write 2, 2 square is 4. In place of n, if I write 3, 3 square is 9. In place of n, if I write 10, what I'll get? 10 square is 100. So it is of the form n square. So how to write this? I'll write like this. X says that x is of the form of n square, where what I can write, where n equal to, this is also smaller set. I just want to keep the things are simple so that everyone can understand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just stop, right? Or else you can write, instead of writing all these things, you can write that where n is a natural number less than 11, or else n is a natural number. I can write like this also. N is a natural number and n is less than or equal to 10. I can write like this also. X says that x equal to n square, n is a natural number and n less than or equal to 10. I felt that writing like this is very easy so that everyone can understand easily, as it is a smaller set. I hope you understand how to write if the given question is in roster form, how to write it into set builder form. Now observe this question number 5. List all the elements of the following sets. List all the elements of the following sets means what? In which method we list all the elements? In roster method we list all the elements. Right? So you can observe these are the sets given in set builder form. We need to write them into roster form. Okay, you observe the first bit. What they are asking, x says that x is odd natural number. Okay, you look here, x says that x is odd natural number. X is odd natural number. Alright, here this set is given in set builder form. We need to write this in roster form. We know in roster form all the elements of a set are listed. What are odd natural numbers? Odd natural numbers. What are odd natural numbers? 1, 3, 5, 7, 9. Like that, it's an infinite set. It's an infinite set. Okay. So set of odd natural numbers. Here the elements are represented with its property. I listed all the elements. So this is the solution for first bit. It can be understood very easily. Now you come to the second bit. What they are asking, x says that x is an integer. You know what are integers? 0, plus or minus 1, plus or minus 2, plus or minus 3. These are all integers. Okay, and they are asking what are the integers lies in between minus 1 by 2 and 9 by 2. To understand this more clearly, I drawn a number line here. You see, I written the numbers as per increasing order, right? We know that in number line, when we go from left to right, numbers increases. Now first I'll mark this minus 1 by 2. We know that 1 by 2 means 0.5. This is minus 0.5. You can observe minus 0.5 will be here. Okay. And 9 by 2. Half of 9 is 4.5. 4.5 will be here. Now you need to identify the integer which are in between these two numbers. Right? What are the integers in between minus 1 by 2 and 9 by 2? You can easily observe these are the integers which are in between minus 1 by 2 and 9 by 2. So as they are asking in the question to list all those elements, I list here 0, 1, 2, 3, 4. These are the integers which are in between minus 1 by 2 and 9 by 2. In earlier also we discussed, whenever we see this type of symbol, suppose something like a less than x less than b, that means you need to write all x values in between a and b. Here in the same way, you need to write all integer values, because they are specifying all integer values which are in between minus 1 by 2 and 9 by 2. By seeing the number line, we can easily say that these are the integers which are in between minus 1 by 2 and 9 by 2. Okay, come to this one. X says that x is an integer and x square is less than or equal to 4. Actually, this is the point you learn in inequalities chapter. In linear inequalities, we have a chapter called linear inequalities. There you learn this point. When x square is less than or equal to 4, then x value lies in between minus 2 and plus 2. Suppose x square is less than or equal to 9, then x value lies in between minus 3 and plus 3. However, for time being, you consider this as a formula. If x square is less than or equal to 4, minus 2 less than or equal to x less than or equal to 2. As it is the first chapter we are doing, you consider it as a formula. When x square is less than or equal to 4, it can be understood also easily. X value lies in between minus 2 and plus 2. Here you can see in the question less than or equal to given. Less than or equal to given. Okay. So here, right, x is an integer and x square is less than or equal to 4. To understood this, I drawn number line here. We know that in number line, when we go from left to right, numbers increases. Okay, so you need to write all the numbers. X less than or equal to 4 means x value lies in between minus 2 and plus 2. As the inequality sign is given, we need to consider minus 2 as well as 2. You see, in this problem, they given strictly less than. So at that time, no need to consider this. Okay, however, this is not an integer. Right, you come to this problem. Here, what are the integers which are in between minus 2 and plus 2? Actually, these are the integers which are in between minus 2 and plus 2. But as they given less than or equal to, that means we can include minus 2. As they given less than or equal to 2, we can include 2 also. So what I'll write here? I'll write here minus 2. You see, minus 2 as an integer that satisfies this condition or not? Minus 2 whole square. Minus 2 whole square is what? Minus 2 whole square is 4. Okay. Next. Minus 2 is over. Next. Minus 1. Minus 1 is an integer. Minus 1 whole square is what? Minus 1 whole square is 1. 1 is less than 4. Satisfying. So, right. Minus 1 also comes here. Similarly, 0. Next. 1. Next 2. Very simple thing I want to say here. When x square is less than or equal to 4, x values lies in this interval. As less than or equal to is there, minus 2 to both are included. If you want, you can check. You take an element. All these are integers or not? Yes, all these are integers. When whatever the element you take one element, substitute in this, definitely it satisfies. For example, you take 1, substitute in this, 1 square is 1. 1 is less than or equal to 4. Here less than is then that satisfying. 1 is less than 4. I hope you understand. Now you see this bit. X says that X is a letter in the word loyal. We already done this. Actually what they are asking in the question they are asking to write list all the elements. L okay, O okay, Y okay, A okay. L is there here, but that is already listed, so no need to write it again. So I listed all the elements. Actually the set is in which form? The set is in set builder form. I listed all the elements. I written in roster form. I hope you understand this. Now you see here, X says that X is a month of a year not having 31 days. X is a month of a year not having 31 days. Look here, not. Which months are not having 31 days? We all know that January month is having 31 days. February, it is very clear, very easy to say. February is a month which is not having 31 days. Okay. March 31 days are there. April not having 31 days. June, May is having 31 days here, right? June, right? June is a month which is not having 31 days. September is a month which is not having 31 days. November is a month which are not having 31 days. You may confuse here. June is there. No? After June, what you will get? July. June, July, August. These 2 months are consecutive months now. Actually, July, August. Actually, these 2 months are having 31 days. If you want, you check the calendar. In the month of July, 31 days will be there. In the month of August, also 31 days will be there. So, what are the months which are not having 31 days? These are the months which are not having 31 days. Actually, what they are asking in the question, list all the elements. Now you can observe, I listed all the elements of this set. So, I hope you understand this. Now, you see here, X says that X is a consonant in English alphabet which precedes K. That means, before the letter K, whatever the consonants are there, that you need to write. A you cannot write. Even though it precedes K, A is not a consonant. A is a vowel. B is a consonant which comes before K. C is a consonant which comes before K. D is a consonant which comes before K. Here E is vowel. E is not consonant. Even though E comes before K, E is a vowel. So they are asking consonants and before K. So E doesn't comes here, like F, G, H, I. I is a vowel. So we won't write J. So these are the letters which are consonants and which precedes K. I hope you understand this. Now let's see last question of this exercise. This is very easy. What they are asking, match each of the set on the left in the roster form with the same set on the right described in set builder form. You can observe all these sets are in roster form. All the elements are listed. And you can observe right side, all the elements are represented with its property. So this is set builder form. This is in roster form. What to do? Match the following. Match the following is always easy things, because left hand side bits given like this. Now 1, 2, 3, 4. And here A, B, C, D. Okay. You observe here mathematics. Mathematics. By seeing this, we can easily say that it is all the letters of the word mathematics. So here you observe X is a letter in the word mathematics. So here the third one, this third one is there. Na? This third one matches with D. Okay. See here this third one. This both are same sets. One is represented in set builder form. Another one is represented in roster form. Okay. Right. Now you see this one. What these things are? These are like odd natural numbers less than 10. Anything is there like that? Yes. X is odd natural number less than 10. So here for the fourth one, it's a B. For fourth one, it's a B. Okay. Right. Now you observe this one, 2, 3. What these? These are the prime numbers, right? You see anything given here, it's a prime number and divisor of 6. Yes, these are the prime numbers and they are the divisors of 6 also. So for the second, it's A. For the second, this is A. Okay, what about this first one? First one is 1, 2, 3, 6. Actually, what is remaining? A is over, B is over, D is over. C is remaining. See, you see what are these? These are the natural numbers and divisors of 6. Observe, yes, first point, these are the natural numbers, and these are the divisors of 6? Yes. So here first bit goes to this C. That's all. I hope you understand this first exercise. In this class, we will learn what is empty set, what is finite set, what is infinite set, what is subset. Subset definition is very important. Please spend some time to understand subset concept. After that, we will learn what is the definition of equal set. With this knowledge, we can easily do exercise number 1.2 problems. Now we will learn types of sets. In types of sets, first we will learn about empty set. Empty set is also known as null set, and it is also known as void set. What is empty set? A set which has no element is called empty set. A set which has no element is called empty set. Empty set is also known as null set, and this null set is denoted by like this: phi, phi, or we'll write just simple empty brackets and we won't write anything here. So we will learn about empty set. What is empty set? A set which has no element is called empty set. Null set is denoted by phi, or simply we'll write only brackets, we won't write anything in between them. And we'll try to understand this null set with an example. You observe this example: collection of months in a year which are having 32 days. We know that in a year 12 months are there. You please tell the months which are having 32 days. You please tell the month which are having 32 days. We know that we don't have any month which is having 32 days. So collection of months in a year which are having 32 days is a null set because we won't find any element in this set. Now fourth synopsis in this sets, that is singleton set. What is singleton set? A set having only one element. A set which is having only one element is called singleton set. For example, you see this is the set having only one element. We say that this set is a singleton set because it is having only one element. Now fifth synopsis in this sets is finite set. What is finite set? A set which consists finite number of elements is called finite. A set which consists finite number of elements is called finite set. We'll try to understand this with an example. You consider a set A like this: 1, 2, 3, 4. How many elements present in this set? Finite number of elements or infinite number of elements? Finite number of elements are present. So this set is known as finite set. And we'll take one more example: collection of all vowels in English alphabet. What you will say about this set? This set is a finite set or infinite set? We say that this set is finite set because it is having finite number of elements. How many elements are present in set B? 5 elements are present. So what is finite set? A set which consists finite number of elements is called finite set. Important note related to finite set: empty set is treated as finite set. So you need to remember this. Empty set is finite set or infinite set. If someone asks, we need to say that it is a finite set because it consists no element, right? So empty set is treated as finite set. Infinite set. What is infinite set? A set which consists infinite number of elements is called infinite set. A set which consists infinite number of elements is called infinite set. We can understand easily this with an example. I'll consider collection of all natural numbers: 1, 2, 3, 4, like that, all the natural numbers. How many elements present in set A? Infinite number of elements present in set A. That's why this set is known as infinite set. Similarly, if I consider collection of all prime numbers: 2, 3, 5, 7, like this, collection of all prime numbers is a finite set or infinite set? You observe here how many number of elements are present in set B. Finite number of elements or infinite number of elements? Infinite number of elements present in set B. So these are the examples for infinite set. We will learn what is subset. We will learn the definition of subset, few examples to understand subset, and 5 important points related to subset. First, we will try to understand what is the definition of a subset. Let A comma B are any two sets. You consider two sets A and B. If all the elements present in set A, that means every element present in set A are present in set B. All the elements present in set A are present in set B. Then A is called subset of, which is denoted by A is subset of B. We'll try to understand this with example. You observe here, I consider a set A is equal to 1, 2, 3. Now, I'll try to write all the subsets of A. I'll consider a set like this. You observe all the elements present in this set are present in A. Yes, this set contains one element, that is 1. That element is there in this set? Yes. So, this A1 is subset of A. Similarly, you observe this set A2. All the elements present in this set are present in A. Yes. So this is subset of A. All the elements present in A3 are present in A. Yes. So this is subset of A. I'll write few more subsets of A. You observe the set A4. This set contains two elements. 1, 2. All the elements present in this set are present in A. Yes. So A4 is a subset of A. Yes. A4 is subset of A. Here few important points you need to observe. Empty set is treated as subset of every set. You observe here this set, this is the empty set. Is empty set is subset of A? Yes. We say that empty set is subset of every set. You need to remember this point. Empty set is subset of every set. Now I'll write one more, that is a 8th set. You observe this set, is it is a subset of A? Yes, of course, all the elements present in set A8 is present in set A. So, every set is subset to itself. You observe here, whatever the sets I written here, all are subsets of A. Now we will learn important note related to subset. First point, you see, whenever A is subset of B, then B is called superset of A. You observe, this A1 is subset of A? Yes. The set A1 is subset of A. Here we say that A is superset of the set A1. I hope you understand. If set A has m elements, then number of subsets of A. How many subsets we will get for set A? We will get 2 power m subsets for set A. You observe here how many elements present in this set? 3 elements present. How many subsets we will get? 2 power m. Here m is 3. 2 cube is what? 2 cube is 8. So here how many subsets we got for set A? We got 8 subsets for set A. So what is the second point related to subset? If set A has m elements, then number of subsets of A equal to 2 power m. This is the important point you need to remember. And it is important point. Empty set is subset of every set. Please keep this point in your mind. Empty set is subset of every set. Next point. Every set is subset to itself. Every set is subset to itself. These 2 points you need to remember. Empty set is subset of every set and every set is subset to itself. Last note related to subset. If A is subset of B and B is subset of C, then which is written as, we can write it as A is subset of B. All the elements present in A are present in B, all the elements present in B are present in C, then directly we can write A is subset of C. This can be understood very easily. 8th synopsis is proper subset. What is proper subset? If A is subset of B and A is not equal to B, then A is called proper subset of, which is denoted like this. You observe here, I am not writing like this. Generally subset means we will denote like this. But I am strictly subset. A is just the subset of B, but A is not equal to B. Then A is called proper subset of B. We will try to understand this with an example. You observe the set S. The set S is 1, 2. Now, how many subsets we can write for set S? This we learn in subset. How many subsets we can write for set S? As set S is having 2 elements, number of subsets of set S is 2 square. So here I written all the subsets of set S. You observe, is A1 is subset of this set? We know that empty set is subset of every set. Is A1 is proper subset of S or not? Of course, it is a subset of S and A1 is not equal to S. So what we say here, this is a proper subset. Okay. You see this A2. A2 is subset of S or not? Yes. A2 is a subset of S. Is A2 is same as yes? No. So it is satisfying proper subset condition or not? It is a proper subset. It is a proper subset. Proper subset of what? Proper subset of yes. It is a proper subset of yes. Yes, it is a proper subset of yes. And you see similarly, this is also proper subset of yes. And what about this A4? You observe this set. Is A4 is subset of S? We know that every set is subset to itself. So here A4 is subset of S because all the elements present in A4 are present in S. Is A4 is same as yes? Yes, A4 is same as S. But actually what is the definition of proper subset? If A is a subset of B and A is not equal to B, then A is called proper subset of B. Here the point is it is a subset of S, but here the point, these two are equal. So is not a proper subset. It is not a proper subset. Now we will learn important note related to this proper subset. You observe here, if set A has M elements, set A has M elements, then number of proper subsets of A. How many proper subsets will be there for set A? The formula is 2 power m minus 1. You observe here, this is the set S. For this, how many proper subsets we got? 1, 2, 3. 3 proper subsets. See here, 2 square, total number of subsets minus 1. 2 square is 4. 4 minus 1 is 3. So if set A has m elements, how many proper subsets we will get for set A? 2 power m minus 1. Cardinal number of a set. What is meant by cardinal number of a set? See here, the number of distinct elements. Distinct elements means different elements present in the finite set, present in the given finite set A is called cardinal number of set A, which is denoted by n of A. We'll try to understand this with an example. You observe here, I consider two finite sets. What is the cardinal number of set A? Cardinal number of set A is denoted by n of A, the number of distinct elements present in a finite set. How many elements present in this set? In this set, 3 elements are present. So n of A, cardinal number of this set is 3. What is the cardinal number of set B? How many elements present in this set B? 1, 2, 3, 4, 5. Total 5 elements are present. So cardinal number of set B is 5. Now 10th synopsis is equivalent sets. You observe here, it is equivalent sets. Equal sets is different, equivalent sets are different. What is meant by equivalent sets? See here, two finite sets A comma B are said to be equivalent if cardinal number of set A is same as cardinal number of set B. We will try to understand this with an example. You observe the sets here A and B. What is cardinal number of set A? Cardinal number of set A is 4 because 4 elements present in set A. What is cardinal number of set B? Set B cardinal number is 4 because 4 elements are present in set B. As cardinal number of set A is same as cardinal number of set B. If cardinal number of set A is same as cardinal number of set B, then we say that the sets A comma B are equivalent sets. Power set. What is power set? The set of all subsets of a given set A is called power set of A. You observe here, all subsets of a given set A. All subsets of a given set A is called power set of A. Power set of A is denoted by P of A. We'll try to understand this with an example. You observe here, I considered a set which consists 2 elements 1, 2. First, I'll write all the subsets of A. What are all the subsets of A? We know that empty set is subset of every set and every set is subset to itself. These two are the subsets of A. And you can observe that this set is subset of A and this is subset of A. I written all the subsets of A. What is the definition of power set? The set of the set. You observe here, I'll write set. Try to understand. This is the set of all subsets of A is called power set of A, which is denoted by P of A. I hope you understand. You observe here, if set A contains 2 elements, its power set contains 4 elements. So if set A contains m elements, then number of elements in P of A equal to 2 power m. Suppose if set A is having 3 elements, then power set of A contains 2 power 3. That means 8 elements. I hope you understand power set.
Now, 12th synopsis is universal set. What is universal set? Universal set, a set which consists all sets or elements. Please try to understand. A set which consists all sets or elements under consideration is called universal set. Universal set is denoted by U. We'll try to understand this with an example. You observe here 4 sets are there. Set A contains elements from 1 to 9. Set B 3, 4, 6, 7. Set C 1, 9, 7, 6, 3, 2. Set D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You observe here we consider 4 sets. Under this consideration, a set which consists all the elements or all the sets under consideration is known as universal set. Which set is known as universal set for given sets ABCD? Which set we treat it as universal set for these 4 sets? You can observe the set T. This is the set which consists all the elements under the consideration. You observe the set D. All the elements present in A are present in D. All the elements present in B are present in D. All the elements present in C are present in D. So what you identified? The set D consists all the elements under consideration. Therefore, D is the universal set in this consideration. What are the definitions you need to know to do the exercise number 1.2? First one, you need to note the definition of null set, which is also known as empty set. And you must know what is finite set, infinite set. These definitions we already learned in theory part. And you observe here they are asking which of the following is finite or infinite. You need to know what is finite set, what is infinite set. And finally, you need to know the definition of equal sets. When we say 2 sets are equal. This theory we already learned in theory part related to exercise number 1.2. If you know the definition of null set, finite set, infinite set, equal sets, then you can do this exercise very easily. Let's see first problem. What they are asking in this problem. Which of the following are examples of a null set? In this, total 4 bits are given. Let's see solution of each and every one. Okay, you observe this first question. What they are asking? Which of the following are examples of null set? Okay, you see this first bit. What they are asking? Set of odd natural numbers divisible by 2. They are asking set of odd natural numbers. Actually, odd natural numbers means they are not divisible by 2. But in this what they are asking? Set of odd natural numbers which are divisible by 2. You cannot find any odd natural number which is divisible by 2. What is meant by odd number? A number which is not divisible by 2. So, odd natural numbers divisible by 2 means we cannot find any such number, any such odd number which is divisible by 2. So, what I can say here? I can say that it is a null set. Which is a null set? Set of, it is a null set. Which is null set? Set of odd natural numbers which are divisible by 2, because odd natural numbers are not divisible by 2. You cannot find any odd natural number which is divisible by 2. That's why this is a null set. Now, see the second example. Set of even prime numbers. Even prime numbers. Even prime numbers. In prime numbers, the only even prime number is 2. 2 is prime and it is even. This is the only prime number which is even. So, if anyone asks to write this set, I'll write like this. You observe like this. Actually, this set contains one element. This is not a null set. What is the definition of null set? Null set means a set which consists no element. Here, we are getting one element. Here, like 2. So, set of even prime numbers is a null set or not? That is the question. Which of the following are null set? That is the question. This is not a null set because this contains an element 2. So, what I'll write here? I'll write that it is not a null set. It is not a null set. Why it is not a null set? Because in this set, one element is present. Even prime numbers means like this. This is actually singleton set. A set which consists of only one element is called singleton set. So this is singleton set. This is not a null set. Okay. In third example, students will confuse very easily. You see here, x is a natural number. Okay. X is less than 5 and x is greater than 7. Here and is there. X is less than 5
and x is greater than 7. Generally what students think, 6 is there. 6 is the natural number. But if I take in place of x, if I take 6, 6 satisfies this condition. You see here, 6 is less than 5. Is it correct? Actually, 6 is greater than 5. This is wrong. 6 is greater than 7. Is it correct? Actually, 6 is less than 7. So, 6 doesn't satisfy this condition. Then you think, what are the natural numbers which satisfies both the conditions? You think which natural number satisfies both the conditions? Think, suppose 8 you take. 8 is less than 5. This condition fails. 8 is less than 5. No, actually 8 is greater than 5. You take here. 8 is greater than 7. 8 is greater than 7 is correct. But what they are saying here, x must satisfy both the conditions. The natural number which must be less than 5 as well as greater than 7. So if we think there is no natural number which is less than 5 and greater than 7. So what I can say here, yes, it is a null set. Yes, it is a null set. I hope you understand this. Now see the next bit. What they are asking in this bit, y says that y is a point common to any two parallel lines. Suppose if we take two lines like this, here this is the point which is common in both the lines. Okay, here what they are saying, y is a point common to any two parallel lines. You know that parallel lines, they never intersect. You look here, if the parallel lines are like this, where they'll intersect? If they are parallel, they never intersect. When they never intersect, you don't get any common point in both. Suppose the lines are like this, intersecting lines, then there will be a common point. But if the lines are parallel, where you will get the common point? What they are asking? Point which is common to two parallel lines. So we cannot find any common point in parallel lines. So what I can say? I can say that it is a null set. That's it. First problem is completed. Now we'll move to second problem. You observe which of the following sets are finite or infinite. After reading the question, you need to decide the set is finite set or infinite set. Okay. Look here, the set of months of a year. In a month, how many years are there? It is very clear that in a year, 12 months are there. In a year, 12 months are there. Clearly, it is a finite set. If I write roster form of this set, what you will get? January, February, March, like that, up to December. Total 12 elements will be there in this. Number of elements in this set are finite. So what I can say? I can say that it is a finite set. It is clear. It is a finite set. It is a finite set because number of months in a year are finite. It is a finite set. Okay, you see this one, 1, 2, 3 and so on. By seeing this set itself, we can easily say that this set and so on is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So clearly we can say that it is infinite set. Okay. You observe this third bit, 1, 2, 3 and so on, 99, 100 is there. Can we say it is an infinite set because of and so on is there? No. In this set, clearly we can say that 100 elements are there. Finite number of elements are there. So what is this? It's a finite set or infinite set? Clearly it is a finite set because we can say how many number of elements are there in this set. So it is a finite set. You observe this set. In this set, how many number of elements are there? So we cannot say here how many number of elements are present because it's an infinite set. Clearly, this set is finite set. So I written here, it is a finite set. Okay. Next, fourth bit you see. What they are asking, the set of positive integers greater than 100. The set of positive integers greater than 100. So what are the positive integers greater than 100? 101, 102, 103, 104. If we keep on writing like this, so many numbers you will get. All these are positive integers greater than 100. So if I write in set form, it is a finite set or infinite set. We can clearly say that it is a infinite set, right? So set of all positive integers greater than 100 is a infinite set. Okay. Now you see this one. Set of prime numbers less than 99. Prime numbers less than 99 they are asking. Less than 99. Clearly it is a finite set. If they ask set of prime numbers greater than 99, it's different case, right? Set of prime numbers less than 99. We can easily identify that set of prime numbers less than 99 is a finite set. I hope you understand first question and second question. In first question, they are asking which of the following are null set. What is the definition of null set? A set which consists no element is called null set. In second question, they are asking which of the following are finite set. A set which consists finite number of elements, it is called finite set. A set which consists infinite number of elements is called infinite set. Now you see question number 3. What they are asking in the question, state whether each of the following sets is finite or infinite. So whatever the given sets are there, you need to decide are they finite or infinite. In this total 5 bits are there. Let's see the first bit. What they are asking, the set of lines which are parallel to x-axis. Suppose if I take the coordinate system like this, x-axis, y-axis, how many lines you can draw which are parallel to x-axis? You can observe here, we can draw infinitely many lines which are parallel to x-axis. Not only here, here also. You can see infinitely many lines we can draw which are parallel to x-axis. It can be understood very easily that the set of lines which are parallel to x-axis is an infinite set. It is an infinite set. It is an infinite set. I hope you understand. We can draw infinitely many lines which are parallel to x-axis. Okay. Now see the second bit. The set of letters in the English alphabet. They are asking the set of letters in the English alphabet. What letters are there in English alphabet? A, B, C, D, E, F, like that up to X, Y, Z. How many letters are there? 26 letters are there in English alphabet. Now what you will say, if I write in this roster form, you will get like this, A, B, C and so on, X, Y, Z. Total 26 letters are there. It is a finite set or infinite set. We can easily say that it is a finite set because the set contains finite number of elements. So what we will say here? Yes, it is a finite set. This set is a finite set. Clearly it is a finite set. Okay, now come to this one. The set of numbers which are multiple of 5. The set of numbers which are multiple of 5 is just like a 5 table. You see 5, 10, 15, 20, 25. All these are what? All these are multiples of 5. Right? So the set is finite set or infinite set. We can easily say that it is an infinite set. Set of numbers which are multiple of 5 is an infinite set. So it is an infinite set. Okay. So many students confuse like anything in this. Set of animals living on planet Earth. In classroom, whenever I try to discuss here, students will confuse. And here, animals living on planet Earth. What you are thinking? As per my experience, many students will say that set of animals on planet Earth. Planet Earth is very big, so that number of animals living on the planet Earth is also very big. So that you will say that it's an infinite set. But answer is not infinite set. Here, set of animals living on Earth is finite set. Why? Here planet Earth is a finite set or infinite set? This Earth is finite or infinite? This Earth is finite. Planet Earth is finite. When planet Earth is finite, obviously number of animals living on the planet Earth also finite. Even though the number is very big. How many animals are there means that number may be very, very big. As planet Earth is finite, definitely number of animals living on the planet Earth also finite. I hope you are understanding. Suppose you take one glass of water. Okay, you take one glass of water. In that glass of water, how many particles will be there? Particles. How many particles will be there? Infinitely many particles will be there. But when it comes to this glass, as this glass is finite, number of particles in that glass of water also finite. I hope you are understanding. With the same reason, when planet Earth is finite, number of animals living on the planet Earth also finite. I hope you got clarity in this. So here, number of set of animals living on planet Earth is a finite set. Okay, now see the next bit. The set of circles
passing through origin. The set of circles passing through origin. How many circles we can draw passing through origin? Let's try one diagram here. Suppose this is the circle. In this circle, here origin is there. So I'll try to draw how many circles are possible through this origin. This is the one circle I drawn passing through origin. Okay, I'll draw one more circle passing through origin. Okay, check it. It is the one more circle passing through origin. I'll draw one more circle passing through origin, right? Okay, I'll draw one more circle passing through origin, okay. You can see I'll draw one more circle passing through origin. Okay, I'm like okay, we'll delete this or something like this. This also you can see there are infinitely many like this we can draw. We can draw infinitely many circles passing through origin. Here you can easily say that it is a infinite set. I hope you all understanding. These are not very difficult things. These are simple things only. So the set of circles passing through origin, it is an infinite set. Okay. Now you observe this fourth question. What they are asking. In the following, state whether A equal to B or not. That means they are asking the sets are equal sets or not. When we say two sets are equal, suppose A comma B are two sets are there. When we say the set A equal to the set B, first point, A must be subset of B and B is also subset of A. When both holds good, A is subset of B as well as B is also subset of A, then only we say that the sets are equal sets. What is subset? In the beginning of theory we learned. Okay, however we will discuss here. Here you see first bit. The set A is given like this, A, B, C, D. And the set B is given like this, D, C, B, A. Now my question is A is subset of B? Is A is subset of B? When we say A is subset of B, all the elements present in A are present in B. Here A is there. A is there in B? Yes. Okay. In set A, B is there. In here also B is there? Yes, it is there. Here in this set C is there. In this set B also C is there? Yes, it is there. Here D is there. In this also D is there? Yes. Clearly what happened here? Here A is subset of B. We know that this is the symbol of subset. All the elements present in A are present in B. Here A is subset of B. Now you check that is B is subset of A or not. D is present in B. D is present in A? Yes. C is present in B. C is present in A? Yes. What I am checking, all the elements present in B are present in A or not. That is what I am checking. B is in set B. B is there in set A? Yes. A is there in set B. A is there in set A? Yes. All the elements present in B are present in A. Then what I can say here? I can say that B is subset of A. Here A is subset of B and B is also subset of A. So I can say that the sets A and B are equal sets. Okay. Now we will move to second bit. You observe what these 4, 8, 12, 16, 4 elements given here. Now you see 4, 8, 16, 18. In this also 4 elements are there. Here we need to discuss about equivalent sets. Equivalent sets means these two sets are equivalent sets because number of elements in both the sets are same. Equivalent sets. Equivalent sets different. Equal sets different. Equivalent sets means number of elements are same. Then we can say that they are equivalent. In this set 4 elements are there. In this set also 4 elements are there. We can say equivalent sets. But equal sets means what? Equal sets means A is subset of B and B also must be subset of A. Here you check that A is subset of B. 4 is there in set A. Yes, 4 is there in set B. 8 is there in set A. 8 is there in set B. Till here it is okay. 12 is there in set A, but 12 is not in set B. So what I can say here? Clearly A is not a subset of B. Here it is important. A must be subset of B. B is also subset of A. Both the condition must holds good. Then only we say that the sets are equal. Otherwise we say that the sets are not equal. Here first condition only fail. A is not subset of B. As A is not a subset of B, From this we can say that the sets are not equal sets. Here by visibility also clearly we can say they are not equal set because the elements are different. Clearly we can say. Oh, now come to this third one. Set A contains 2, 4, 6, 8, 10. Okay. When we observe the set B, this is given in set builder form. Set builder form. What I'll do to identify the things easily, I'll write this B set in roster form. Roster form means what? All the elements are listed separated by commas within the bracket. I'll try to write set B in roster form. What is set B? X is positive even integer. What are positive even integers? Positive even integers. 2, 4, 6, 8, 10, 12, 14. They are all positive even integers. And they are saying that x is less than or equal to 10. That means less than or equal to given. That means 10 is also included. So what you will get here? 2, 4, 6, 8, 10. These are all positive integers which are less than or equal to 10. Less than or equal to 10. So if I write set B in roster form, you will get like this. Now set A is there, set B is also there. Now we need to say these two sets are equal sets or not. So what you need to check? A is subset of B first of all. All the elements present in A are present in B. 2, yes, it is there in set B. 4, it is there in set B. 6, it is there in set B. 8, it is there in set B. 10, it is there in set B. All the elements present in set A are present in set B. So what we can say here? We can say that A is a subset of B. A is a subset of B. And you check that is B is a subset of A. First I'll write here. A is subset of, and I'll check that B is subset of A or not. All the elements present in B are present in A. Yes. All the elements present in B are present in A. So clearly here B is also subset of A. As A is subset of B and B is subset of A, then I can easily say that the sets A and B are equal sets. I hope you are understanding. Now you see this fourth bit. The set A is like this. X says that X is a multiple of 10. And the set B is like this. 10, 15, 20, 25, 30. Now you observe, are they equal sets? You see here in this set B 15 is there. 15 is there in set A. 15 is there in set A. Set A is what? It's a multiple of 10. 15 is not a multiple of 10. So here clearly B is not a subset of A. Is it clear to you or not? Yes, for me it is clear. For you it is clear or not? Clearly B is not a subset of A. You observe, as B is not a subset of A, here the sets A and B are not equal. You observe this question, are the following pair of sets equal? Give reasons. When we say two sets are equal, very simple. When A is subset of B and B is also subset of A, then we say the sets are equal. Both the conditions must hold good. Then only we say that the sets are equal. Okay. You observe this first bit. In this, one set is given in roster form and one set is given in set builder form. We need to say the sets are equal sets or not. Okay. Set A is very clear what elements are there. 2, 3. In set B, what elements are there? Here, X says that X is a solution of this quadratic equation. To find the, I want to write this set in roster form so that I can easily decide they are equal sets or not. For that, what I'll do, I'll simplify this quadratic equation. I'll find the factors of this quadratic equation. I'll find the roots of this quadratic equation. X square plus 5x plus 6 equal to 0. You just split the middle term, what you will get? X square plus 5x can be written as 2x plus 3x plus 6 equal to 0. Now in these two we can take x common. Yes, you take x common, what you will get if you take x common? X into x plus 2 plus, in these two you take 3 common, what you will get if you take 3 common? 3 into x plus 2 equal to 0. Okay. Now here x plus 2 is there, here also x plus 2 is there. So you take x plus 2 common, what you will get? X plus 2 into x plus 3 equal to 0. Product of two terms is 0. Product of two terms is 0 means either this is 0 or this is 0. So here what I can write? I can write x plus 2 equal to 0 or x plus 3 equal to 0. So here x equal to minus 2 or x equal to minus 3. So what x is a solution of this equation. Na? What are those x values? X value is minus 2, x value is minus 3. Minus 2, minus 3 both satisfies this equation. So what I can say here, I can write like this: set B is minus 2 comma minus 3. Okay, so here set A is what? Set A is 2 comma 3. Now you declare now, or these two sets are equal sets. Here A is subset of B. You check it. In this set 2 is there. In this set the element 2 is there. The element 2 is there in set B? No. Clearly A is not a subset of B. If any one condition fails, then we can say that the sets are not equal. Here now you see this one. X says that X is a letter in the word follow, and Y says that Y is a letter in the word wolf. Here both the sets are given in set builder form. I'll write both the sets in roster form so that we can easily decide are they equal sets or not. Okay, follow is there na? I'll write all the letters of the word follow. F, comma, O, comma, L, comma. Here look here, L is repeated. We already listed the element L. In last class also we learned that repeated elements we won't list again and again, right? Roster method is what? In roster method all the elements are listed, separated by commas. L is already listed here, no need to list it again. Okay, O, look here, O is there. O is already listed here. Okay, next W. Okay, so this is letters of the word follow. I written set A in roster form. Now I'll write set B. What is set B? The letters of the word wolf, right? You list all the letters of the word wolf. W, O, L, F. Okay. Now you observe that is A is subset of B. Is A is subset of B? F, O, L, W. Right. All the elements present in set A are present in set B. F is present in set A. Yes, F is present in set B. O is present in set A. O is present in set B. L is present in set A. L is present in set B. W is present in set A. W is present in set B. In the same way, you can observe that all the elements present in set B are present in set A. So here clearly, what I can say clearly A is subset of B and B is also subset of A. From this I can say that these two sets are equal sets, A equal to B. Now we'll move to next question. This is last question of this exercise. You observe here, from the sets given below, select the equal sets. They are asking us to select the equal sets. Okay, you see here A, B, C, D 4 sets. A, B, C, D 4 sets. These sets are having 4 elements. Okay, and you observe these sets E, F, G, H. These are having 2 elements. So obviously AE are not equal, AF are not equal, AG are not equal, AH are not equal. Because you need to identify from the given sets below, select the equal sets. Okay, in the same way, B is not equal to A, B is not equal to F, B is not equal to G, B is not equal to H, because in first 4 sets 4 elements are there, next 4 sets 2 elements are there. So best thing is we will find equal sets in A, B, C, D, and we will find equal sets in E, F, G, H. I hope you are understanding what I am trying to say. Okay, first point is set A is same as set B. Look here, A and B are equal sets. Actually, in set A, 8 is there, 8 is not there in set B. A and B are not equal. Now you look that A and C are equal sets or not. A and C are equal sets or not. You observe 14 is there in set C, but 14 is not there in set A. So clearly A and C are not equal sets. Okay, you observe that A and D are equal sets. A and D are equal sets. Here 1 is there in set D, but 1 is not there in set A. A and D are also not equal set. What happened? I taken set A, I compared with B, C, D. I didn't find any equal sets. Now what I'll do, I'll take set B and I'll check with all other sets. Like A comma B we already checked, right? Now set B, set C, are they equal sets? In this set C, 8 is there, that is not there in set B. So B comma C are not equal sets. Now you check for B comma D. You look here, 1, 2, 3, 4. You see here 1, 2, 3, 4. Clearly we can say that the set B is equal to the set D. B is subset of D and D is also subset of B. That's why we can say that the sets B and D are equal. I hope you are understanding. Now you take set C and A and C are clearly not equal. B and C are also not equal. You check for C and D. C and D, are they equal sets? No. In this set 14 is there, 14 is not in D. They are asking to select equal sets. Okay, so now you come to this second, in this all 4 elements are there. Na? First set is there. Na? I didn't compare A is equal to E or not, because I know that A is not equal to E, because number of elements are different. They cannot be same. They cannot be equal. Okay, right. Now you see E, F are equal. No. E, G are equal. Yes, you observe here, in this set -1 is there, here also -1 is there, in this set 1 is there, here also 1 is there. Clearly E is subset of G and G is subset of F. So here we can say E equal to G. Okay, these two sets are equal. Now you come to F. Is F is equal to Z? No. Is F is equal to H? No. With observation we can see this. Now G is equal to H? No. So that's all. So I verified for every pair. I taken A, I taken F. I checked they are equal or not. I taken A, I taken G. Like that I taken every pair and I checked are they equal or not. At the end I got that B equal to D and E equal to G. With this exercise is completed. I hope you understand this very easily. Till now, we completed 2 exercises in sets chapter. First, we will learn theory part related to third exercise. In this, main points are subset definition. You already learned this definition in second exercise, but most of the problems based on subset are there in third exercise. So, in the beginning, we will learn what is the definition of subset. After that, we will learn what is power set and we will learn universal set definition. Many students confused to understand the definition of universal set. Please spend some time to understand what is universal set. After that, we will learn about intervals. Intervals are the things which we use very frequently in functions chapter. Please spend time to understand intervals. So after that, we will complete all exercise number 1.3 problems in this video. Without much delay, let's begin the class. We will learn the definition of subset, few examples to understand subset and 5 important points related to subset. First, we will try to understand what is the definition of a subset. Let A comma B are any 2 sets. You consider 2 sets A and B. If all the elements present in set A, that means every element present in set A are present in set B, all the elements present in set A are present in set B, then A is called subset of, which is denoted by A is subset of B. We will try to understand this with example. You observe here, I consider a set A is equal to 1, 2, 3. Now, I'll try to write all the subsets of A. I'll consider a set like this. You observe all the elements present in this set are present in A. Yes, this set contains one element, that is 1. That element is there in this set? Yes. So, this A1 is subset of A. Similarly, you observe this set A2. All the elements present in this set are present in A. Yes. So this is subset of A. All the elements present in A3 are present in A? Yes. So this is subset of A. I'll write few more subsets of A. You observe the set A4. This set contains two elements, 1, 2. All the elements present in this set are present in A? Yes. So A4 is a subset of A? Yes. A4 is subset of A. Here, few important points you need to observe. Empty set is treated as subset of every set. You observe here this set, this is the empty set. Is empty set is subset of A? Yes. We say that empty set is subset of every set. You need to remember this point. Empty set is subset of every set. Now, I'll write one more, that is a 8th set. You observe this set, is it is a subset of A? Yes, of course, all the elements present in set A8 is present in set A. So, every set is subset to itself. You observe here, whatever the sets I written here, all are subsets of A. Now we will learn important note related to subset. First point, you see, whenever A is subset of B, then B is called superset of A. You observe, this A1 is subset of A? Yes, the set A1 is subset of A. Here we say that A is superset of the set A1. I hope you understand. If set A has m elements, then number of subsets of A. How many subsets we will get for set A? We will get 2 power m subsets for set A. You observe here, how many elements present in this set? 3 elements present. How many subsets we will get? 2 power m. Here m is 3. 2 cube is what? 2 cube is 8. So here how many subsets we got for set A? We got 8 subsets for set A. So what is the second point related to subset? If set A has m elements, then number of subsets of A equal to 2 power m. This is the important point you need to remember. And it is important point. Empty set is subset of every set. Please keep this point in your mind. Empty set is subset of every set. Next point. Every set is subset to itself. Every set is subset to itself. These 2 points you need to remember. Empty set is subset of every set and every set is subset to itself. Last note related to subset. If A is subset of B and B is subset of C, then which is written as, we can write it as A is subset of B. All the elements present in A are present in B, all the elements present in B are present in C, then directly we can write A is subset of C. This can be understood very easily. 8th synopsis is proper subset. What is proper subset? If A is subset of B and A is not equal to B, then A is called proper subset of, which is denoted like this. You observe here, I am not writing like this. Generally subset means we will denote like this. But I am strictly subset. A is just the subset of B, but A is not equal to B. Then A is called proper subset of B. We will try to understand this with an example. You observe the set S. The set S is 1, 2. Now, how many subsets we can write for set S? This we learn in subset. How many subsets we can write for set S? As set S is having 2 elements, number of subsets of set S is 2 square. So here I written all the subsets of set S. You observe, is A1 is subset of this set? We know that empty set is subset of every set. Is A1 is proper subset of S or not? Of course, it is a subset of S and A1 is not equal to S. So what we say here, this is a proper subset. Okay. You see this A2. A2 is subset of S or not? Yes. A2 is a subset of S. Is A2 is same as S? No. So it is satisfying proper subset condition or not? It is a proper subset. It is a proper subset. Proper subset of what? Proper subset of yes. It is a proper subset of yes. Yes, it is a proper subset of yes. And you see similarly, this is also proper subset of yes. And what about this A4? You observe this set. Is A4 is subset of S? We know that every set is subset to itself. So here A4 is subset of S because all the elements present in A4 are present in S. Is A4 is same as S? Yes, A4 is same as S. But actually what is the definition of proper subset? If A is a subset of B and A is not equal to B, then A is called proper subset of B. Here the point is it is a subset of S, but here the point, these two are equal. So is not a proper subset. It is not a proper subset. Now we will learn important note related to this proper subset. You observe here, if set A has m elements, then number of proper subsets of A. How many proper subsets will be there for set A? The formula is 2 power m minus 1. You observe here, this is the set S. For this, how many proper subsets we got? 1, 2, 3. 3 proper subsets. See here, 2 square, total number of subsets minus 1. 2 square is 4. 4 minus 1 is 3. So if set A has m elements, how many proper subsets we will get for set A? 2 power m minus 1. Cardinal number of a set. What is meant by cardinal number of a set? See here, the number of distinct elements. Distinct elements means different elements present in the finite set, present in the given finite set A is called cardinal number of set A, which is denoted by n of A. We'll try to understand this with an example. You observe here, I consider two finite sets. What is the cardinal number of set A? Cardinal number of set A is denoted by n of A, the number of distinct elements present in a finite set. How many elements present in this set? In this set, 3 elements are present. So n of A, cardinal number of this set is 3. What is the cardinal number of set B? How many elements present in this set B? 1, 2, 3, 4, 5. Total 5 elements are present. So cardinal number of set B is 5. Now 10th synopsis is equivalent sets. You observe here, it is equivalent sets. Equal sets is different. Equivalent sets are different. What is meant by equivalent sets? See here, two finite sets A comma B are said to be equivalent if cardinal number of set A is same as cardinal number of set B. We will try to understand this with an example. You observe the sets here A and B. What is cardinal number of set A? Cardinal number of set A is 4 because 4 elements present in set A. What is cardinal number of set B? Set B cardinal number is 4 because 4 elements are present in set B. As cardinal number of set A is same as cardinal number of set B. If cardinal number of set A is same as cardinal number of set B, then we say that the sets A comma B are equivalent sets. Power set. What is power set? The set of all subsets of a given set A is called power set of A. You observe here, all subsets of a given set A. All subsets of a given set A is called power set of A. Power set of A is denoted by P of A. We'll try to understand this with an example. You observe here, I considered a set which consists 2 elements 1, 2. First, I'll write all the subsets of A. What are all the subsets of A? We know that empty set is subset of every set and every set is subset to itself. These two are the subsets of A. And you can observe that this set is subset of A and this is subset of A. I written all the subsets of A. What is the definition of power set? The set of the set. You observe here, I'll write set. Try to understand. This is the set of all subsets of A is called power set of A, which is denoted by P of A. I hope you understand. You observe here, if set A contains 2 elements, its power set contains 4 elements. So if set A contains m elements, then number of elements in P of A equal to 2 power m. Suppose if set A is having 3 elements, then power set of A contains 2 power 3. That means 8 elements. I hope you understand power set. Now 12th synopsis is universal set. What is universal set? Universal set, a set which consists all sets or elements. Please try to understand. A set which consists all sets or elements under consideration is called universal set. Universal set is denoted by U. We'll try to understand this with an example. You observe here 4 sets are there. Set A contains elements from 1 to 9. Set B 3, 4, 6, 7. Set C 1, 9, 7, 6, 3, 2. Set D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You observe here we consider 4 sets. Under this consideration, a set which consists all the elements or all the sets under consideration is known as universal set. Which set is known as universal set for given sets ABCD? We'll which set we treat it as universal set for these 4 sets? You can observe the set T. This is the set which consists all the elements under the consideration. You observe the set D. All the elements present in A are present in D. All the elements present in B are present in D. All the elements present in C are present in D. So what you identified? The set D consists all the elements under consideration. Therefore, D is the universal set in this consideration. Intervals plays important role in functions chapter. It is important you need to know about intervals. Intervals means it's not like something while watching movie you will get interval. It is not like that. These are the intervals on the number line. When it comes to intervals, total 4 types of intervals are there. You see, this is the first one. You observe this one. How to read this? We read it as closed interval a comma b. We read it as closed interval a comma b. How we will come to know that it is closed interval? By seeing the bracket. If the bracket is like this, then by seeing this we'll say that it is a closed interval. If the bracket is like this, then we say that it is open interval. This is open interval, this is closed interval. Okay. What is this? How we read it as? We read it as closed interval a comma b. What it mean? Closed interval a comma b means what? Closed interval a comma b on the number line. What it mean? It means that closed interval a comma b contains all real numbers between a and b. Closed interval a comma b contains all real numbers between a and b, including both a and b. Here, as closed interval is there, that's why including both a and b. This is the definition. Closed interval a comma b means what? It means that it contains all real numbers between a and b, including both a and b. What I written here, same thing we can write in set builder form. You observe here, this is closed interval a comma b. Closed interval a comma b means it contains all real numbers. X says that X is a real number. This contains all real numbers. And you observe here, a less than or equal to X less than or equal to b. What it mean? It means that X values are in between a and b, as equality symbol is there here. Both a and b is included. However, we can understand this more clearly with an example. Somewhere you saw like this, closed interval 1 comma 4. It means what? It means that it contains all real numbers between 1 and 4. As it is a closed interval, both 1, 4 are included. You observe this interval on the number line. You see here 1 to 4. Look here 1 to 4. This closed interval 1 comma 4 contains all the numbers in between 1 and 4. As it is a closed interval, 1 is included, 4 is also included. Now my question is, closed interval 1 comma 4. In this interval, 3.4 is there? Yes or no? Yes. Closed interval 1 comma 4 contains 3.4 because 3.4 is somewhere here. All real numbers between 1 and 4 will be there in this interval. As it is a closed interval, 1 is also included, 4 is also included. I hope you are understanding. Now, in this interval, 1.234 is there. The number 1.234 is there in this interval, closed interval 1 comma 4. Yes, 1.234 is in between 1 and 4. Now my question is, in this interval 0.9 is there. In this interval 0.9 is there. Look here, 0.9 means somewhere around here you will get. No, 0.9 does not belongs to this interval. So from now onwards, wherever we see this type of intervals like closed interval 1 comma 4, it means that it contains all real numbers between 1 comma 4. As it is a closed interval, both 1 and 4 is included. I'll try to explain this with one more example. Here, I'll take a closed interval. Closed interval 0 comma 5 is there. Something given like this. Closed interval 0 comma 4. How to represent this on the number line? Closed interval 0 comma 4. I am discussing about closed interval only. I said na total 4 types are there. So all the things we will discuss one after another. Okay. Now you observe closed interval 0 comma 5. It means what? It contains all real numbers between 0 and 5. Okay, between 0 and 5. Right, between 0 and 5. I'll mark all these things. Between 0 and 5. You see, whatever this color is there, that color part, all real numbers are there in this interval. Now you observe, as it is a closed interval, 0 is included, 5 is also included. So what I'll write here, 0 is included. Now here I'll write a dark circle. This dark circle indicates that 0 is a part of this interval, and here 5 is also for here for 5 also closed bracket is there. So 5 is also included. I hope you understand what it meant by closed interval 0, 5. Closed interval 0, 5 means it contains all real numbers between 0 and 5, including both 0 as well as 5. Like that, you can we can discuss n number of intervals, like closed interval -1, 100. What it mean? It means that how to read this? By seeing the brackets, we'll read it as closed interval -1, 100. It contains all real numbers between -1, 100. And as it is a closed interval, -1 is also included, 100 is also included. So in intervals, total 4 types are there. You learn first type. What is that? Closed interval a, b. Now you know what is meant by closed interval a, b. Now we'll move to second type. See this. This is the second interval. What is this? By seeing the brackets, we can say that this is open interval a, b. Open interval a, b means what? Open interval a, b contains all real numbers between a and b. As it is an open interval, excluding both a and b, this is defined like that. This interval is defined like that. Open interval a, b contains all real numbers between a and b, excluding both a and b. Now, by seeing the question, you can easily say, you look here, this is what interval? This is closed interval a, b. How you can say that? By seeing the brackets. This is closed interval a, b. Now, what about this one? By seeing the brackets, we can say that this is open interval a, b. Open interval a, b means what? It contains all real numbers between a and b, excluding both a and b. The same thing in interval form, set builder form. You see here, this is open interval a, b. Na? The same thing in set builder form, we can write like this. This contains a number x. What is that x? X is a real number and it is in between a and b. In between a and b. You can observe here, less than or equal to symbol is not given. That means a and b are not included. X values lies in between a and b. You observe, open interval a, b means both a and b are excluded, excluding both a and b. You can understand this more clearly with an example. You see here, this is open interval 1, 4. Na? Look here, open interval 1, 4 contains all real numbers. Open interval 1, 4 contains all real numbers between 1 and 4. What about 1, 4? You see here, at 1 I written open circle. This is not dark circle like this. If I write dark circle like this, 1 is included. But you can see here, it's an open circle, space is there. Open circle means that 1 is not included. You can look here, open circle 4 is there. That means 4 is not included. I hope you understand. Open interval 1, 4 means it contains all real numbers between 1 and 4. But 1 is not included, 4 is not included. For example, if I ask in this interval 2.3 is there or not? In this interval 2.3 is there or not? Yes, it is there. In this interval 1 is there or not? 1 is a part of this interval? No, 1 is not included. So because it is open interval. Okay. 0.999 is there? It is there in this interval? No, it is also not there in this interval. Now 3.99999 is number is there in this interval? Yes, this number is there in this interval, right? Except 4. It contains open interval 1, 4 contains all real numbers in between 1 and 4. So this number is there in this interval means yes. Now 4 is there in this interval? No, 4 is not in this interval. I hope you understand this second one. Now we'll move to third one. You see this, how to read this. You see here, how to read this. One side closed bracket is there, one side open bracket is there, right? See, look here, this side closed bracket is there, this side open bracket is there. How to read this? We read it as the interval closed A, open B. Listen carefully. How we read it as? We read it as the interval closed A, open B. What it means? It contains all real numbers between A and B, including A and excluding B. Including A and excluding B. you please observe here, including A. Why we are including A? Because for A side, closed interval is there. When closed bracket is there, then A is included. Excluding B, when open bracket is there, that B is included. By this time, you can easily understand. Point number 1, how to read this. The interval closed A, open B. What it contains? It contains all real numbers between A and B, including A and excluding B. Okay. Now, the same thing, if I want to write in set builder form, I can write like this. This interval contains numbers x. What is x? X is a real number such that x value lies in between A and B. You can observe as it is the closed A is included. A is included. That's why here equality symbol is there. B is excluded. That's why we not written any equality symbol here. B is excluded. You come to this example. How you read it as? The interval closed 1, open 4. The interval closed 1, open 4. Okay, what it means? It contains all real numbers between 1, 4. 1 is included, 4 is excluded. You observe how to mark this on the number line. You mark all the numbers in between 1 and 4. You look here, all this part is present in this interval. All this part is present in this interval. As it is closed 1 is included, right? Here, look here, for 4 side, this is open bracket is there. No? That means that 4 is excluded. That's why I written open circle here. I hope you are understanding. In this interval, 1 is present or not? As closed 1 is there, yes, 1 is present in this interval. In this interval, 4 is there or not? No, 4 is not in this interval because 4 is excluded. In this interval, 1.999 is there? Yes, clearly this 1.999 is present in this interval. I hope you understand this interval. How to read this interval? This is the interval closed A, open B. Now last interval. You observe this. How to read this? We read it as the interval open A, closed B. What it means? It contains all real numbers between A and B. As for A, open bracket is there, so excluding A and including B. I hope you are understanding. The interval open A, closed B contains all real numbers between A and B, excluding A and including B. Okay, you observe what is this? The interval open A, closed B. What it contains? It contains an element x. What is x? X is a real number. What about that x? X is in between A and B. As it is open A is excluded. As it is closed B is included. You can understand this more clearly with this an example. How to read this interval? You make a habit of reading this interval. How to read this interval? We read it as the interval open 1, closed 4. Okay, the interval open 1, closed 4 contains all real numbers between 1, 4 and 1 is excluded and 4 is included. In case you need to mark this on the number line, you need to mark like this. Open interval 1, the interval open 1, closed 4 will be like this. In case if you want to mark the interval on the number line, you will mark. First, you will mark all the numbers in between 1 and 4. As for 1, open bracket is there. We will write open circle. It indicates that 1 is not included, 1 is excluded. Okay. And here closed 4 is there. That means 4 is included. I hope you understand this interval. For example, in this interval 1 is there? No, 1 is not there. In this interval 4 is there? Yes, 4 is present in this interval. In this interval 4.1 is there? In this interval 4.1 is there? No, 4.1 is not in this interval. In this interval 10 is there? 100% the 10 is not in this interval, right? In this interval 0.9999 is there in this interval? No, 0.999 is not in this interval. I hope you learned about intervals very easily. We use these intervals in sets chapter as well as in functions chapter as well as in inequalities chapter. I hope you understand about these intervals.
You observe this exercise number 1.3. In this exercise, total you can see 9 problems are there. So let's see what is first problem. What they are asking, make the correct statement by filling the symbol subset not a subset in the blank spaces. Okay, so let's move to the first question. You see here in this question Total 7 bits are given. Okay. You observe this first bit. What we need to do? You need to fill the suitable symbol in the blank spaces here with a subset or not subset. You need to fill with a suitable symbol. Okay. You see here in this set the element 2 is there. Is it present in this set? Yes. The element 3 is present in this set. Is it present in this set? Yes, it is there. 4 is present in this set. 4 is there in this set? Yes, it is there. What happened here? All the elements present in this set are present in this set. So, what is the suitable symbol here? Subset is the suitable symbol. We know the definition of subset. If all the elements present in this set are present in this set, then we say that this set is subset of this. So, here suitable symbol is subset. Now, you see the second bit. All the elements present in this set are present in this set or not. You just check here. A is the element present in this set. That element A is there in this set? Yes or no? A is not in this set. So what I can say? I can say that not a subset. Not a subset. When we say subset, all the elements present in this set must present in this set. Then only we say that this set is subset of this set. Here not a subset is the suitable symbol. Why? Because A is present in first set but A is not in second set. I hope you understand this. Now come to the third bit. This set is given in set builder form. It's okay, no problem. X is a student of class 11 of your school. In your school, one section is there with class 11. Okay, class 11 section is there. Here in this set, whoever the student will pick, that student is from class 11. In this set, whoever the student will pick, that student is from class 11. Okay, you look here. X is a student of your school. Here, whoever the students are there, they are from your school. This person may be from class 11, this person may be class 12, this person may be class 10, right? Here, whoever present in this are present in this set or not. If in this set who are present, a student of class 11 is present. That student definitely belongs to your school only, na? So, whoever are there in class 11, definitely he is a student of your school. So clearly we can say that here subset is the suitable symbol. I hope you understand this. So here suitable symbol is subset. Okay. Now come to this bit. X is a circle in the plane. X is a circle in the plane. When it comes to circle, different radii will be there. This is the circle of radius 1 unit. This is the circle of radius 2 units. This is the circle of radius 3 units. Like that, circles with a different radii will present in first set. This is the circle in a plane. It may be of any radius. So, you try to understand. In this set, circle of radius 4 is there. Yes, it is there. It is a circle in a plane. If it is a circle in a plane, that presents to first set. Circle of radius 10 units present in this first set. Yes, present in this set. So, this set contains all the circles in that plane. Now, you observe the second set. X is a circle in the same plane with radius 1 unit. X is a circle in the same plane with radius 1 unit. Here, this is the circle which this is the set which contains circles with radius 1 unit only. See here, in this circle, radius 1 unit. This is the circle of radius 1 unit. In this, only the circles with radius 1 unit is present. For example, if you take this set, in this set, circle of radius 2 units is there. In this set, circle of radius 2 units is there. Yes, it is present in this first set. In this set, circle of radius 2 units is present? No, it doesn't present because this set contains circles of radius 1 unit only. So what I can say here? I can say that not a subset. This set is not a subset of this set. I hope you understand. Best example is, in this you consider circle of radius 2 units. It is present. In this circle, radius of 2 units circle is present, but same circle not present in this set. That's why it is not a subset. You observe this fifth bit. X is a triangle in a plane. This set contains all the triangles, equilateral triangles, scalene triangle, different triangles are present in this first set. Okay. Now, this set contains rectangles. This set contains rectangles. It is very clear that if I take one triangle from this, if that triangle is present in this set, this set is only contains rectangles. This set contains only rectangles. So here clearly we can say that not a subset is the suitable symbol. You see here, X is an equilateral triangle in a plane. X is a equilateral triangle in a plane. That means this set contains triangles which are equilateral. All three sides are equal. You see here, X is a triangle in the same plane. So here, this contains only equilateral triangles, right? What about this set? This contains all triangles. Equilateral triangle, scalene triangle, all different triangles are present in this. Now the point is, whatever the element present in this set are present in this set or not. That is the question. Here very simple thing here. If I take one element in this set, that is present in this or not. Okay, here one equilateral triangle is there. That equilateral triangle present in this? Yes, this contains all the triangle. This contains equilateral triangles, this contains right angle triangle, this contains isosceles triangles. All the triangles are present in this. Clearly we can say that subset is the suitable symbol for this. Now you come to this one. X is a even natural number. Can you say what are even natural numbers? 2, 4, 6, 8, 10, like that. These are all the even natural numbers. And you observe these are integers. What are integers? 0, plus or minus 1, plus or minus 2, plus or minus 3, like that. The point is, all the elements present in first set are present in second set or not? Yes. In this 2 is there. 2 is present here? Yes. In this 4 is there. 4 is present here? Obviously. 6 is present in the second set? Yes. Clearly we can say that this first set is subset of second set. So suitable symbol is subset. I hope you understand this first question.
You observe the second question, what they are asking. Examine whether the following statements are true or false. You can observe here also subset, not a subset symbols are there. And here belong symbol. We need to check whether the given statement is true or false. You see this first bit. This is the first bit. What they given in this first bit? Not a subset symbol is given here. We need to check whether it is true or false. When we say this set is subset of this set, if all the elements present in this set are present in this set, then subset will say. For example, A is present in this set. Is A is there here? Yes, A is present here. B is present in this set. Is B is present in this set? Yes. So this set is subset of this set. But what they given here? Not a subset they given. But the suitable symbol is subset. Here, if they give subset, then it is true. Actually, they given not a subset, na? So that's why this statement is false. When they give it is subset, when they give here only subset, then this is true, right? Okay. Now you come to second bit. This set contains two elements, A comma E, and second set is given in set builder form. Second set is given in set builder form. Okay. X is a vowel in English alphabet. If I write the second set in roster form, what are the vowels in English alphabet? A, E, I, O, U. Okay. So this set gives this meaning. Okay. Now you observe all the elements present in this set are present in this set. In this A, E are there. In this also A, E are there. That means that this set is a subset of this set. Here what symbol given? Subset is given. So what we can say here? Yes, this statement is true. I hope you understand. In this set, two elements are there, A comma E. Those two elements present in this set also. All the elements present in this set are present in this set. That's why subset symbol is suitable. That's why this statement is true. Now again subset symbol is there. Now you just check that all the elements present in this set are present in this set. You just check. Here 2 is the element present in this set. 2 is present in this set? No. So what is the suitable symbol? Not a subset is the suitable symbol actually, because all the elements present in this set are not present in this set. I am saying all the elements. Okay. Here 2 is present in this set, but 2 is not in this set. Because of that reason, not a subset is the suitable symbol, but they given subset. So this statement is false. Actually, not a subset is the suitable symbol. Okay, come to this fourth bit. This is the singleton set which contains only one element A. Okay, you observe this set contains three elements. All the elements present in this set
are present in this set? Yes or no? All the elements present in this set are present in this set? Yes or no? Here in this set A is there. A is present in this set? Yes, A is present in this set. So here subset is the suitable symbol. So here subset given. So what I can write? I can write here this statement is true. I hope you are understanding. Now come to this one. This is singleton set. It contains one element. Here belong symbol given. When belong symbol given, many students confuses here. Here A is there, here also A is there, that's why this is true. No, not like that. Suppose if this set is given like this, A, B, C, A. If they give like this, now in this 4 elements are there, A, B, C, singleton set A. If this set is given like this, then this statement is true. Actually, what is the correct symbol? Subset is the correct symbol. You see above one. Subset is the correct symbol and we written true. Belongs is the wrong here. Belongs is wrong. Actually this statement is false. This statement is false. When this statement is correct, this statement is correct when this is given like this. A, B, C. If they give like this, then we can say that this is as an element present in this. Then this is correct. But this set is not like that. So I hope you understand. For this, what is the suitable symbol? Suitable symbol is subset. But they given belongs. That's why this is false. Okay. Now come to this last one. X is even natural number less than 6. X is even natural number less than 6. I'll write this set in roster form so that we can easily understand. What are even natural numbers less than 6? 2 is the even natural number less than 6. 2 is natural number less than 6. 4 is even natural number less than 6. Any other? Less than 6 they are saying 6 we cannot write. Now you need to check all the elements present in this set are present in this set or not. Second set contains what? X is a natural number which divides 36. You clearly check 2 is there in this second set or not. 2 is a natural number, clear. 2 divides 36 or not? Yes, 2 divides 36. 2 into 18. Okay. 4 is a natural number or not? Yes, 4 is a natural number. 4 divides 36 or not? 4 9s are 36. Clearly, the elements 2, 4 present in second set. No need to write full roster form for this set. No need to write full roster form for this set. You just check that in this set 2, 4 are there. In this set also 2, 4 present or not. You just check that one. I hope you are understanding. So here clearly subset is a suitable symbol. So here this statement is true. Why? Because first set contains 2, 4. These 2 elements definitely present in the second set. That's why this statement is true. Now we'll move to next question. This is very important. Observe this. First, set A. What is set A? Set A is like this. 1, 2, 3, 4, 5 like this. I'll write here. Set A. What set A? First we need to discuss a few things. Later only we'll start the solution. Okay. Here set A is like this. First point. In this set A, how many elements are there? Think and answer. In this set A, how many elements are there? Many students says that 1, 2, 3, 4, 5 elements are there. That is wrong actually. In this set, 5 elements are not there. What elements are there in this set? 1 is present in set A. Listen this carefully please. 1 is there in set A. 2 is there in set A. 3 is there in this set A. 3 does not belongs to set A. 3 is not in set A. 4 is there in this set A. 4 is also not in set A. Please try to understand. 4 is not in set A. Okay. 5 is present in set A. Yes. 5 is present in set A. And the set 3, 4 belongs to set A. Here, if I write what are the things present in set A, 1 is there in set A, 2 is there in set A, the set 3, 4, this present in set A and 5 present in set A. Now, you tell me that how many elements present in this set? How many elements? Total 4 elements present in this set. First element, second element, third element, fourth element. First thing, it must be clear that what elements present in set A, what elements does not present in set A. Now my question is, 3 is there in set A? Answer, 3 is there in set A? No, 3 does not belong to set A. I'll write here. 3 does not belongs to set A. It is very clear. First of all, you must clear this point. 3 belongs to set A means it will be like this. 1, 2, 3, comma, set 3. It will be like this. But 3 is not in set A. At the same time, 4 is also not in set A. You need to know this information first to proceed further. Okay, set A contains what elements? Set A does not contain what elements? Many students confuses that 3 is there in set A, but actually 3 is not in set A, 4 is also not in set A. But actually what is present here? The set 3, 4 present in set A. So first thing you understand that what are present in set A. Now what they are asking, which of the following statements are incorrect? They are asking which of the following statements are incorrect and why. Okay, you see this one. This is incorrect or correct. You just observe. What they are saying here, they are saying that the set 3, 4 is subset of A. The set 3, 4 is subset of A. Please do not confuse. Listen carefully. When we say subset symbol, all the elements present in this set are present in A, then this set is called subset of this set. All the elements present in first set are present in A, then first set is a subset of second set. Okay. In this set element 3 is there? Yes. In this set element 3 is there. That 3 is present in set A or not? Look here. 3 is not in set A. I hope you are understanding. So subset symbol given means all the elements present in this set must present in A, right? Here 3 is present in this set but 3 is not in set A. So what I can write here, this statement is incorrect. This statement is incorrect. Okay. Why they are asking here? You look here, they are asking why incorrect. Why means because 3 belongs to this set 3, 4 implies 3 does not belongs to set A. That is the reason. Because of this reason we can say. Okay. Now come to this second bit. What is the second bit? Here belong symbol is given. Please observe carefully. Belong symbol is given. This is the set 3, 4. Set 3, 4. Set 3, 4 is present in set A. You look here, I already written what are present in set A. Set 3, 4 belongs to set A. Look here. Set 3, 4 belongs to set A. As an element it present in set A. So belongs is the suitable symbol here. So what I will say, the statement is correct or incorrect? This statement is correct. Okay. Now we move on to next bit. You please do not confuse. Just go back and revise the things what I am saying for every bit. Okay. Now see this one. Here what they given. Here subset they given. First point. In this set, you observe the first bracket. In this set, how many elements are there? Only one element is there. That is set 3, 4. In this set, only one element is there. That is set 3, 4. Okay. Now the set 3, 4 belongs to A or not? Yes, the set 3, 4 belongs to A. So what I can say, all the elements present in this set are present in A. So subset is the suitable symbol. I hope you are understanding. This contains only one element, that is set 3, 4. That set 3, 4 present in A or not? Yes, set 3, 4 present in A. So this statement is correct or incorrect? This statement is correct. So this statement is correct. Okay. Now come to this one. 1 belongs to A. They are saying that the element 1 belongs to set A or not? You look here. 1 is present in set A. Na? I have also written here. Yes, 1 is present in set A. So this statement is correct. 1 is there in set A. Okay. Now observe this one. 1 is subset of A. Actually, subset symbol we use between two sets. Suppose A is one set, B is one set. We can write subset symbol. A, all the elements present in A are present in B. Then we can say that A is subset of B. Subset symbol is used between two sets. Here, 1 belongs to A is correct. But 1 subset of A is wrong. Because first thing, this is not a set to use the subset symbol. Subset symbol will be used between two sets only. So what I can write here, this is incorrect. I hope you are understanding. This is incorrect. One belongs to A is correct. One subset of A is incorrect. Okay. Now see this bit. 1 to 5. Set 1 to 5. Subset of A. First, I'll bring this data. What is present in set A, what is not present in set A, so that we can easily discuss. Here subset symbol is there between two sets. Okay, now the point is 1 is present in this. 1 is present in A? Yes, 1 is present in A. 2 is present in this set. 2 is present in A? Yes, 2 is present in A. 5 is present in this set. Is 5 is there in set A? Yes, 5 is there in set A. All the elements present in this set are present in A or not? Yes, 1 is present in A, 2 is present in A, 5 is present in A. All the elements present in this set are present in A. So what I can say? I can say that this statement is correct, right? Subset is suitable symbol here. Now look here. Same, just to confuse you, they given like this. This is correct. What they given here? Belongs they given. Belongs. This is correct or incorrect? 100% this is incorrect. When this will be correct? If the set A is like this. 1, 2, 3, 4, 5. If they given like this, look here, last element. If they given like this, if they given like this, if they given like this, set A is like this, then it is correct, right? You understand here? You see this one, set 3, 4 belongs to look here. When they give like this, it is correct, because here the set 3, 4 present in set A, right? So here we can easily say that this is incorrect. This is incorrect. Subset is the suitable symbol. Belongs is not suitable symbol. When belongs is suitable symbol, when the set A contains an element like this, 1, 2, 5. If the set A contains an element like this, further 1, 2 something they given like this. If they given like this, then it is correct. This element is not in set A. So this is incorrect. This is incorrect. I think they are asking why. Why this is incorrect? Because this is incorrect because 1, 2, 5. The element set 1, 2, 5 does not belongs to set A. That is the reason. Okay. Now you observe this one. This is one set. This is another set. Subset symbol is there. Subset means what? All the elements present in this set are present in A. Then we say that this set is subset of A. Here you see the element 3. 3 is present in this set. 3 is present in A. 3 is present in this set. Is 3 is there in set A? Look here, I written here 3 does not belongs to set A. In the beginning only we discussed 3 does not belongs to this set. All the elements present in this set are present in A or not? No. 3 is present in this set. 3 is not in A. So what is the correct symbol here? Not a subset is the correct symbol. They given subset, so that means here this is incorrect statement. 3 belongs to this set 1, 2, 3, but 3 does not belongs to A. This is the reason. I hope you are understanding. Right. Now you observe here empty set belongs to A. Empty set belongs to A. Actually we know that empty set is subset of every set. Here empty set belongs they given. Here this is set A na. Please observe, this is set A na. In this empty set is there. In this empty set is there. In case if the question is like this. In case if the set A, if set A is like this. 1, 2, set 3, 4, 5 like this. If set A is given like this, then this is correct. But set A is not like that na. So what you can say? This is incorrect. This is incorrect. Why this is incorrect? Because the set 5 is not in A. What are there in set A? What are not there in set A? We already written here. 5 belongs to A. They written here. 5 because 5 does not belongs to set A. That is the reason. Okay. Look here. So many students confuse here. Please you try to. I given clear explanation. You just revise it and just check it. Go back and check the video. What points I am trying to say. Okay, now look here, 5 and A. We know that in subset, we learn important point. In subset, we learn that empty set is a subset of every set. We know that empty set is subset of every set. So here subset symbol is there. So this is correct or incorrect? Clearly, this is correct statement. Okay, now you observe this one. Now, here you see this one. This is singleton set. This is singleton set. It contains only one element. What is that element? That element is 5. Now here subset symbol is given. When this will be correct, whatever the elements present in this set are present in A, then it is correct. This contains only one element, 5. 5 is there in set A. We already discussed here. 5 is not in set A. So what we can say, I can say that this is incorrect. When we use subset symbol, all the elements present in this set are present in A, then we say that subset is the suitable symbol. In this 5 is there, but 5 is not in set A. That's why this is incorrect. I hope you understand this second question. Many students, I observe that they feel difficult to understand this. I request you to listen this video once, twice, thrice, and then you will get an idea. If any doubts are there, you can chat with me in chat box, right? I hope you understand this third problem. Okay. Now we'll move to fourth problem. Observe this fourth problem. What they are asking, write down all the subsets of the following sets. What they are asking, write down all the subsets of the following sets. We know one definition. If set A has m elements, then number of subsets of set A is what? Number of subsets of set A is 2 power m. If set A contains m elements, number of subsets of set A is 2 power m. Okay. So here the point is, you observe, write down all the subsets. They are saying this set contains only one element. Solution. This set contains only one element. Okay. How many subsets are possible for this set? This set contains only one element. Number of subsets is 2 power 1. 2 power 1 means 2. So how many subsets you will get for this? You will get 2 subsets for this. So I'll write here. This is the bit they given. So I'll write the number of what they're asking, write down all the subsets. I'll name this as A so that it is easy for us to write. So I'll name this as A. Okay. Let this as A. Let this set as A. A equal to like this. Now what I'll write, number of subsets of A. Okay. All the subsets of A. Oh, okay. One thing, I'll write number of subsets of A also. Number of subsets. They are not asking this, but I am writing number of subsets of A. Set A contains how many elements? 1 element. How many subsets will be there? 2 power 1. If set A contains m elements, number of subsets is 2 power m. Here set A contains 1 element. Number of subsets of A is 2 power 1. That equal to 2. So I'll write here. All subsets of A, they are asking to write now. I'll write now. All subsets of A equal to, see, we know that for a set, empty set is subset of every set. In subset definition, we learn this. Empty set is subset of every set, and every set is subset to itself. Every set is subset to itself. You please try to understand. Empty set is subset of every set, and every set is subset to itself. Is this is a subset of this set means? Yes, it is a subset of that set, because every set is subset to itself. In the theory part, you check this once. So for this 2 subsets are there, I written all 2 subsets. You please observe the second bit. I'll name it as B. Let B equal to like this, A comma B. In set B, how many elements are there? Total 2 elements are there. So number of subsets I'll write first. Okay. Number of subsets of B. Number of subsets of B. Number of subsets of B. Set B contains how many elements? Set B contains 2 elements. Number of subsets of B is 2 power m. That means 2 power 2. 2 power 2 is what? 4. So all subsets of B I need to write now. How many subsets are there for set B? 4 subsets are there. You need to write all the subsets of B. Now I need to write all the subsets of B. Okay, I need to write all the subsets of, okay, total how many subsets are there? 4 subsets are there. 2 subsets you can easily write. In that, first one is empty set is a subset of every set. So obviously empty set is a subset of B, and we know that every set is subset to itself. That means what set they given, we can write that set. This is subset to itself. Okay, and one more thing, here I can write single element sets. You please observe, this is the set which contains only one element, A. That A is present in this set? Yes, A is present in this set. So this is a subset of this set, no doubt in that. In the same way, singleton set B, you observe this contains only one element. This element present in this set, yes, all the elements present in this set are present in this set. So this is a subset of this set. So total how many subsets we got? 1, 2, 3, 4. Total 4 subsets are there. All 4 subsets are written. I hope you understand this. Now we'll move to third bit. What is the third bit? In third bit, they given set 1, 2, 3. I'll name that set as C. Given set, I'll take it as C. 1, 2, 3. First point, number of subsets of C. Number of subsets of C. Okay. Set C contains how many elements? You observe. Set C contains how many elements? Set C contains 3 elements. Number of subsets of C. Formula 2 power 3. I am saying again and again, if set C contains m elements, number of subsets of C formula 2 power m. Okay, 2 cube. 2 cube is what? 2 cube is 8, right? So for this, how many subsets you will get? You will get 8 subsets. Now you need to write all the subsets of C. Okay, I need to write all the subsets of C. Total how many subsets I will get? Total 8 subsets I will get. Okay, first set. Empty set is subset of every set. So empty set is subset of this set also. Now every set is subset to itself. Instead of writing 1, 2, 3, I can write C also. Look here, I hope you are understanding. The set C, this set C itself is a subset, okay? Or else you can write like this also. Every set is subset to itself. Now 2 subsets I already written. I need to write another 6 subsets. Okay. You can observe single element subsets. This set contains only one element, that is 1. 1 is present in C or not? Yes. So this set is a subset of this set. Next, I'll write like this 2. 2 is present in this set. Is 2 is present in C? Yes. 2 is present in this set. 2 is present in this. So it is a subset. Next, 3. 3 is present in this set. Okay. 3 is present in this set. That 3 is present in set C? Yes. 3 is present in set C. Similarly, total how many subsets you got here? 1, 2. Total 5 we written. Another 3 subsets we need to write. Now 2 element subsets also we can write. I'll write here. Set 1, 2. You see, this set contains 2 elements, 1, 2. 1, 2 present in this set or not? Yes. 1, 2 is over. Next, 2, 3. Next, 1, 3. You can observe this is a subset of this because 2, 3 present in this. 1, 3 present in this. 1, 3 present in this set. So this is subset of this set. I hope you are understanding. So total how many subsets you got? 1, 2, 3, 4, 5, 6, 7, 8. Okay. You don't write like this. 3, 1 is a subset. These two are same. Any one is enough. 1, 3 is a subset. 3, 1 is another subset. Like that you don't count. Right? 1, 3, 3, 1 both are equal. So any one is enough. Okay. I hope you understand this. Now see the fourth bit. What is the fourth bit? They given empty set. We need to write subsets of it. Okay. Fourth bit. Fourth bit. I'll take it as D. Let given set as D. Okay. First point. Number of subsets of D. Okay. Number of subsets of D. The set D contains how many elements? Answer. Set D contains how many elements? Here empty set na, this set contains no element. This set contains 0 element. Okay. Number of subsets of D. This is 2 power 0 because this set contains 0 elements. So right. 2 power 0 is what? 2 power 0 is 1. We know that 2 power 0 value is 1. So what we need to write now? We need to write all the subsets of D, right? Okay. We need to write all the subsets of D. How many subsets we'll get? We'll get total 1 subset. What is that set? That set itself. We know that every set is subset to itself and empty set is also subset to itself. Here luckily that empty set is the every set. That means empty set is the given set. I hope you understand. For this set, how many subsets are there? Only one subset is there. What is that subset? That subset is empty set. I hope you understand this question number 4. You observe this question. How many elements has P of A? P of A means power set. Power set. In that theory part we learned that if number of
if set A has m elements, number of elements in P of A is 2 power m. Number of subsets is same as number of elements in P of A, that we discussed in theory part. Okay. If set A has m elements, number of elements in P of A is 2 power m. Okay. Here, what is the solution for this? Set A. What is set A? Set A is given as 5. 5 means empty set. That means which consists no element. 5 can be written like this in roster form. Now in this, how many elements are there? In this, 0 elements are there. So what they are asking, how many elements P of A has? So this implies number of elements in P of A. They are asking how many elements are there in set P of A. 2 power 0. 2 power 0 is 1. So in case if you want me to write what is P of A, P of A is what? Set of all subsets of A. Set of all subsets of A. Like this you will get. For this set, we discussed in last bit also. Only one subset will be there for this set. That is the set itself. Okay. So this is P of A. You can see here in P of A how many elements are there? Only one element is there. However, in this they are not asking this. What they are asking, how many elements has P of A? P of A has only one element. In case if you have doubt, you just write P of A. What is P of A? All the subsets of A. So this set contains only one subset, that we discussed in last bit also. You look here, this is the set. All the subsets of this set is only one subset will be there in this. Okay. I hope you understand fifth question. Now we will move to sixth question. Intervals. We discussed intervals now. Please go back and check what we learned in that intervals. Okay. Here write the following as intervals. You can see the interval given in set builder form. The interval is given in set builder form. We need to write it as interval form. Very simple. Here what they are saying, x says that x is a real number and minus 4 less than, we read it as strictly less than. Okay, strictly less than x less than or equal to 6. Here if you want to write this in interval form, very simple. Here strictly less than is there. When strictly less than is there, you write minus 4. When open interval, when strictly less than is there, you write open interval, and when less than or equal to is there, at the time you write closed interval, like this. What is this? This contains all the real numbers between minus 4 comma 6. Minus 4 is excluded, 6 is included. Very simple man. When to write open bracket, when to write closed bracket. When strictly less than is there, open bracket. When less than or equal to, greater than or equal to is there, at that time closed bracket. Okay, I hope you understand. You look here, both sides strictly less than is there. So what I can write this as open interval minus 12 comma minus 10. Both are open intervals because here also strictly less than is there, here also strictly less than is there. We discussed this in intervals. Please check that intervals form, right? Intervals definitions and all. Okay, you see here x says that x is a real number and they given that 0 less than or equal to x less than 7. So here simple thing, 0 less than or equal to 0 we will write. Okay, 0 we will write 0 less than or equal to x, x less than 7, x less than 7. Here for 7 strictly less than symbol they given. That's why this is open bracket. I hope you understand this. Now come to the fourth bit. Here less than or equal to, look here. Look in the question, here less than or equal to is there, here also less than or equal to is there. Yes, can you answer this? Yes, what is this? Closed interval 3 comma 4. Closed interval 3 comma 4. In intervals we discussed these things more clearly, right? Now we will move to next problem. What is that? Write the following intervals in set builder form. Set builder form, they given intervals. Look here, they given intervals. What they are asking? They are asking us to write in set builder form. Very simple. See, this is the first bit, open interval minus 3 comma 4. How to write this into set builder form? You write like this. X says that x is a real number. X says that x is a real number and x is a real number, and you can look here, both sides open interval is there. So what I'll write? Minus 3 strictly less than x less than 0. That's it. This is over.
This interval we written in set builder form. If they given in set builder form, if they ask us to write in interval form, we'll write like this. In last question we did the same thing only. You can look here, they given questions in set builder form. They given questions in set builder form, we written in interval form. If they give in interval form, we'll write in set builder form like this. It's very easy. Okay, come to the second bit. Closed interval 6 comma 12. Closed interval 6 comma 12 is there. How to write this? Very simple. First, as usual procedure, I'll copy paste here. Okay. First, as usual procedure, x says that x is a real number and x is a real number. You look here, this is closed interval. Closed interval means we'll write less than or equal to. Here 6 is there. 6 is there. I'll write 6. 6 is less than or equal to. Here 12 is there, that we will write 12. Less than or equal to we need to write because this is closed interval. Because this is closed interval. I hope you are understanding. Right? Right. Now we will move to this third bit. Third bit, you see, second bit, third bit seems to be little similar, but variation is there. How to write this interval in set builder form? X says that x is a real number. You look here, open interval is there. Open interval means strictly less than. Okay. Here closed interval is there. Closed interval means less than or equal to. You please observe the difference between this and this, then you will get the clarity, right? So I hope you understand. These are very easy bits, very easy, right? Oh, now come to this one, last one. We need to write this in set builder form. Okay, we need to write this in set builder form. Okay, x says that x is a real number, and what is the interval given? How we read this? The interval closed minus 23 comma open 5. So closed interval is there for minus 23. So how you will write? Minus 23 less than or equal to 5. For 5 you can observe here open bracket is given for 5. So it is strictly less than 5. I hope you understand this, right? So with this the intervals are written into set builder form. Please see this 8th question. What they are asking in 8th question. What universal set would you propose for each of the following? You quickly recall the definition of universal set. Just go back and check the definition of universal set. A set which consists all sets or all elements under the consideration. A set which consists all the sets or all the elements under consideration is called universal set. Here what they given? The set of right triangles. Right triangles means right angle triangles. For this, what is the universal set you will propose? Very simple. I will propose universal set like this. The set of all triangles. The set of all triangles. I will write the set of all triangles. Here all triangles means all comes. Equilateral triangle, scalene triangle, right angle triangle, all are present in this set. That's why I written set of all triangles. Now this set contains this set or not? Set of right triangles are present in this set or not? This is set of all triangles. All triangles means this set. Equilateral triangle is there in this set? Yes. Scalene triangle is there in this set? Yes. Isosceles triangle is there in this set? Yes. Isosceles right angle triangle is there in this? Yes. This set contains all triangles. My question is, as I am proposing it as a universal set, what I need to think? This contains whatever the things we are discussing. We are discussing here the set of right triangles. Set of right triangles are present in this set or not? Yes. This is the set contains all the triangles. As we are discussing right triangles also present in this set. So this is the universal set we can propose. This is the universal set. Okay. Come to the second bit. What is the second bit? What they are asking in the second bit? The set of isosceles triangles. The set of isosceles triangles. That is the given set. For this also set of all triangles. The set of all triangles is the universal set. All triangles means in this everyone is there. In this isosceles triangle is there, equilateral triangle is there, scalene triangle is there. So this set what I proposed as a universal set, the set contains this set or not? Yes, obviously, because I written set of all triangles. So this is the universal set for this set. Please check the definition of universal set once. Okay. Please see this 9th question. Given the sets A, they given some sets A, B, C. Like that, 3 sets they given. What they are asking, which of the following may be considered as universal set for all the 3 sets ABC? Which of the following considered as universal set? Which of the following considered as universal set for all 3 sets ABC? Universal set means what? The set which contains all sets under consideration. You observe, this is universal set or not. I am checking. This is universal. When this will be universal set? If it contains all the sets under consideration. If this contains all the sets or all the elements under consideration. You look here, in this first set 1, 3, 5 is there. Yes, 1, 3, 5 are present in this. Second set 2, 4, 6 are there. 2, 4, 6 present in this. In third set 0, 2, 4, 6. You will observe here, in this third set 8 is there. 8 is not in this set. So this is not the universal set. This first bit is not the universal set. Universal set is a set which contains all the sets or all the elements under consideration. Universal set means it is a set which contains all the elements or all the sets under consideration. If I take this as a universal set, you see 8 is present in this, but 8 is not in this set. So this is not a universal set. Now, obviously, empty set is not a universal set because here so many elements are there. So this is not the universal set. Now come to this one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 is there. 0. You see first 1, 3, 5. 1, 3, 5 are there. 1, 3, 5. Yes. 2, 4, 6. 2, 4, 6. Yes. Now 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Very good. This is the set which contains all the sets under consideration. See, what is universal set? A set which consists all the sets or all the elements under consideration. Here, under consideration means these are the things we are considering. Whatever the universal set I am proposing, that must contains all these elements or all these sets. Okay. So, this is the universal set. I will propose that this is universal set. This is universal set. Okay. And what about this one? It is a universal set or not? You can see here 0 is there in this set, but 0 is not in this. 0 is not in this. So I cannot propose this as a universal set. So here this third bit is there. Now that is the universal set. I hope you understand what is universal set. With this, third exercise theory is completed. I hope you understand this. Thank you. Hello everyone. I am Balaji Rao. Welcome to BR Max class. Till now, we learned 3 exercises in sets chapter. This video is about theory part related to 4th exercise and 4th exercise complete solutions. In this 4th exercise theory, we will learn operations on sets. We will learn how to calculate union of sets, how to calculate A union B, how to identify A union B in Venn diagram, and properties of union of sets. In the same way, how to calculate intersection of sets, difference of sets, all those things we are going to learn in this class. Without much delay, let's begin the class. In this class, we will learn about operations on sets. First operation is union of 2 sets. First, we will learn how union of 2 sets is defined. The union of 2 sets A comma B. Union of 2 sets A comma B is denoted by A union B. Look here, how we read this as? We read it as A union B. And how it is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. That means A union B contains all the elements which present in either A or in B or in both A and B. We'll try to understand this with an example. You observe here, I consider 2 sets A, B. Now we need to calculate A union B. How A union B is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. You observe one is there in A, so we will write here. If the element present in A or present in B, then it will be in A union B. 2 is there in A, so it comes in A union B. 3 is there
in A, so it comes in A union B. You observe 4. 4 is there in both A and B. Elements which are present either in A or in B are in both A and B. So even though 4 is there in both the sets, it comes in A union B. See, 5. 5 is present in B, so it present either in A or in B. Next, 6. So in this way, we will calculate A union B. Now we will learn very important note related to union of sets. We will try to understand what is A union B in Venn diagram. Which zone is known as A union B in this Venn diagram? You observe this first circle is set A, second circle is set B. Where is the zone which is A union B? If you observe in this diagram, total 4 parts are there. This is first part, this is second part, and this is third part, and other than these circles outside is the fourth part. Please try to understand. First part, second part, third part, fourth part. What is the fourth part? Other than these circles, what is there in this rectangle box other than this area? That is the fourth part. What is A union B? A union B is A union B contains all the elements which are either in A or in B or in both A and B. So the part 1, 2, 3. 1, 2, 3 will be A union B. You try to understand this zone 1 and this zone 2 and this zone, this full zone. So this full is A union B. The part 1, part 2, part 3. This full zone is what? This is A union B. So the shaded part is the region of A union B. Now second important point related to union of sets. How we represent union of sets in set builder form. How we represent union of two sets in set builder form. X is the element present in A union B such that we write it as X belongs to A or X belongs to B. A union B in set builder form we can write like this: X belongs to A or X belongs to B. Third point, A union A. When we calculate A union A, what you will get? Can you guess what we will get? A union A. A union A is A only. Fourth important point, what you will say about A union B and B union A? Are they equal or they are not equal? What you say about A union B and B union A? Is A union B is same as B union A? What is B union A? B union A is the set which contains the elements which are present in B or in A or in both A and B. So here we can easily understand that in sets A union B is same as B union A. When we union with universal set, when we do union with universal set, A union universal set, which set we will get? We know that universal set is the set which contains all the sets or elements under consideration. So as universal set is the bigger set, when we do the union, bigger set will be the answer. So A union universal set is universal set. A union null set. Null set is empty set which consists no element. In these two sets, which set is the bigger set? A is the bigger set. So when we do the union, we will get bigger set. So A union empty set is A. In sets, associative law holds good with respect to union. A union B union C is same as A union B union C. You need to remember these points which will be useful while solving the problems. A union B union C is same as A union B union C. This is known as associative law with respect to union of sets. Last point, if A is subset of B, if A is subset of B, that means all the elements present in A are present in B, then what is A union B? Here you need to observe one thing. In A and B, which set is the bigger set? A is subset of B means all the elements present in A are present in B. Here we can easily understand that B is the bigger set. So when we do their union, we will get the bigger set. So A union B is B. So this is all about union of two sets. Next, we will learn intersection of two sets. Next, 14th synopsis is intersection of two sets. What is intersection of two sets? intersection of two sets A comma B is denoted by A intersection B, like this. How we read it as A intersection B. Intersection of two sets A comma B is denoted by A intersection B and is defined as all the elements which are present in both A and B. It is not like union of sets. What is about union of sets? All the elements which are present in A or in B or in both A and B. But here in intersection of sets, we will consider the elements which are present in both A and B. We can understand this with an example easily. Here you observe two sets are there, A and B. A intersection B. What is A intersection B? How it is defined? All the elements which are present in both A and B. You observe the elements which is present in both A as well as in B also. One is there in A, one is not in B. 2 is there in A, but it is not in B. 3 is there in A, but it is not in B. You observe 4 is there in A and 4 is present in B also. So what are the elements which are common in both A and B that comes in A intersection of B? Is there any other element which is common in both? No. 4 is the only element which is present in both A and B. So A intersection B is the set 4, singleton set 4 you will get. Now we will try to understand what is intersection of sets more clearly by using Venn diagram. You observe here, I consider two sets A and B, and this box we treat it as universal set. If you observe this box, total 4 parts are there in this. This first part, and this is the second part, and this is the third part. Other than these circles, whatever the remaining part is there, that is the fourth part. Now in this diagram, which zone is known as intersection of two sets? What is intersection of two sets? All the elements which are present in both A and B. You identify the elements which are present in both A and B. You see here, this is the zone, this zone present in A and this zone present in B also. Please try to understand. This is the zone which is present in A and which is present in B. That means second part is the intersection of two sets in this Venn diagram. Now second important point, how we write A intersection B in set builder form. X is an element which is present in A intersection B such that X belongs to A and X belongs to B. In union, what we written? A union B is written as X belongs to A or X belongs to B. When we calculate A intersection A, what we will get? When we calculate A intersection A, we will get A only. You can observe that when we calculated A union A, at that time also we got A. When we do A intersection A, then also we will get A. Okay. Next, fourth point. What you can say about A intersection B and B intersection A? Is A intersection B is same as B intersection A? What you will say about A intersection B and B intersection A? A intersection B means all the elements which are present in both A and B. B intersection A means all the elements which are present in both A and B. We can easily understand that those two are equal. A intersection B is same as B intersection A. A intersection null set. Here you try to remember this. When we do union of two sets, we will get the bigger set. When we do intersection of two sets, we will get the smaller set. Here A is a set and phi is the empty set. We know that empty set is subset of every set. In these two sets, which set is smaller? So intersection of these two is empty set. A intersection empty set is empty set. A intersection universal set. Universal set is the set which consists all the sets or elements under consideration. In these two sets, which one is the smaller set? Obviously, the set A is the smaller set compared to universal set. When we do the intersection, we will get the smaller set only. Okay, so A intersection universal set is A only. What about associative law with respect to intersection? With respect to intersection, associative law holds good. That is, A intersection B intersection C is same as A intersection B intersection C. associative law holds good with respect to intersection. We know that associative law holds good with respect to union also. Last point in intersection of sets. A is subset of B. Then what you will say about A intersection B? If A is subset of B, then which set is the smaller set? If A is subset of B, A is the smaller set. When we do the intersection, we will get the smaller set only. You remember, when we do their union, in case if we write about union, A union B, we will get the bigger set. If A is subset of B, B is the bigger set. When we do their union, we will get bigger set. When we do their intersection, we will get the smaller set. This is just a trick to remember these formulas. I hope you understand about intersection of two sets. Now, 15th synopsis is disjoint sets. Two sets A comma B are said to be disjoint if A intersection B is null set. That means if no element is common in both the sets, then we say that those two sets are disjoint. We'll try to understand this with an example. I'll consider a set A like this, 2, 4, 6, 8. And the set B is like this, 1, 3, 5. Are these two sets are disjoint? When we say two sets are disjoint, when we calculate their intersection, if their intersection is null set, then we say that the sets are disjoint. Calculate A intersection B. How we will calculate A intersection B? The elements which are common in both A and B. You identify any common element present in both A and B. There is no element common in both A and B. Here A intersection B is a null set. So what we say, therefore the sets A comma B are disjoint. Therefore the sets A comma B are disjoint. The difference of two sets A comma B is denoted by like this, A minus B, like this, or A by B. What it is? It is a notation of difference of two sets. Generally, we use this notation. Difference of two sets A comma B is denoted by A minus B. And A minus B is defined as all the elements present in A but not in B. What is A minus B? A minus B is defined as all the elements which are present in A but not in B. We will try to understand this with an example. You observe here, I consider two sets A and B. And what is A minus B? A minus B means all the elements which are present in A but not in B. You observe here, this is the element present in A but it is not present in B. Now you come to the second B. B is element present in A. B is in set B? No. So we'll write like this. Now what about C? C is element present in A. It is present in B also. But what is A minus B? All the elements present in A but not in B. Okay. So here D is present in A. D is present in B also. So A and B are the only elements which are present in A but not in B. I hope you understand how we calculate A minus B. Now we will try to understand this more clearly with Venn diagram. Okay, you observe here, I consider the sets A and B. A minus B. I need to identify in this Venn diagram where is the region A minus B. What is A minus B? A minus B means the elements present in A but not in B. You observe this is the zone which elements present in A but not in B. Please try to understand. So you observe here this shaded region. What is this shaded region? This shaded region is A but not B. This shaded region is A but not B. So what is A minus B? All the elements present in A but not in B. Okay. Now second point, how we write A minus B in set builder form. A minus B is a set which contains an element X such that X present in A and X does not belongs to set B. X is in set A but not in B. So the set A minus B in set builder form we will write like this. Now third point in this difference of two sets, A minus B and B minus A. What you will say about these two sets? A minus B is same as B minus A. A minus B means elements present in A but not in B. B minus A means elements present in B but not in A. You observe this shaded part is A minus B. Similarly, if you observe this part, please observe here this part. This part is B minus A. Are these two are equal? No, they are different. A minus B is not equal to B minus A. You try to understand. In previous class, we learned A union B is same as B union A. A intersection B is same as B intersection A. Whereas it comes to difference between two sets, A minus B is not equal to B minus A. Now fourth point. A minus B intersection B minus A. Where is the zone B minus A? What is this shaded part? This shaded part is B minus A. This shaded part is B minus A. When it comes to their intersection, what are the elements which are common in both A minus B and B minus A? You can observe the sets A minus B and B minus A both are disjoint. There is no element common in both these A minus B and B minus A. So A minus B intersection B minus A is null set. Now fifth point. You can observe here A minus B and A. If we consider A minus B, this is A minus B. Is A minus B is subset of A? All the elements present in A minus B are present in A. We can easily understand this. You observe this is set A. This is A minus B. All the elements present in A minus B are present in A or not? Yes. So A minus B is subset of A. Similarly, what you say about B minus A? What you will say about B minus A and set B? B minus A, all the elements present in B minus A are present in B? Yes, of course. So B minus A is subset of B. Now sixth point in this difference of sets. What is A minus null set? A minus null set means all the elements present in A but not in null set. All the elements present in A minus null set is A. It can be understood very easily. Seventh point. A minus A. What is A minus A? All the elements present in A but not in A. Is it possible? All the elements present in A but not in A. What is difference between A and A? A minus A is the null set. So A minus A is null set. Symmetric difference of two sets. How the symmetric difference of two sets is defined? The symmetric difference of two sets A comma B is denoted by A delta B. You please observe here, the symmetric difference of two sets A comma B is denoted like this, A delta B. In some books, they'll denote the symmetric difference between two sets like this also. And how the symmetric difference of two sets is defined? It is defined as all the elements which are present in A are in B but not in both. Try to understand this carefully. All the elements which are present in A are present in B but not in both. We'll try to understand this by using Venn diagram. You observe here, I consider two sets A and B. What is this shaded part? You can observe here, this full, both the circles is nothing but A union B. What is this full part? This full part is A union B. But you observe the second part, that is intersection of both the sets. This is A intersection B. Please observe this area. A intersection B. From A union B, if we remove A intersection B, then we will get this shaded part. Please try to understand. A delta B is nothing but A union B. From A union B, if you remove A intersection B, all the elements present in A union B but not A intersection B. That means all the elements present in A are in B but not in both. Try to understand. Whatever the shaded part is there here, this part plus this part, this is symmetric difference between two sets. Here, symmetric difference between two sets is defined like this also. See, A minus B, we know that just now we learned this shaded region is A minus B, this shaded region is B minus A. When we do their union, then also we are getting symmetric difference of two sets. So in this Venn diagram, the shaded part is the symmetric difference between two sets, right? Now we'll try to understand this more clearly with an example. See, here two sets are there. Set A is 1, 2, 3, 4, 5. Set B is 1, 3, 5, 7, 9. A delta B is defined as A minus B union B minus A. Okay. A minus B, all the elements present in A but not in B. 2 is present in A but not in B. 4 is present in A but not in B. So what you will get this A minus B? A minus B is the set 2, 4 union What about B minus A? All the elements present in B but not in A. You see here 7 is present in B but not in A. 9 is present in B but not in A. So here you will get 7 comma 9. So when you do their union, what you will get? You will get 2, 4, 7, 9. Exercise number 1.4 solutions. You observe this first question. What they are asking. Find the union of each of the following pair of sets. They given, you observe the first bit, they given two sets X, Y. They are asking union of these two sets. Like that, we need to calculate union of given pair of sets. Actually, in fifth question they given like this. Find the intersection of each pair of sets of question number 1 above. So what I'll do here, this first question, fifth question, I'll try to do at a time. That means for this first bit, I'll calculate X union Y as well as X intersection Y. Okay, let's see the first bit. Now, what is the first bit? You see, they given like this. The set X is like this and the set Y is like this. What they are asking us to calculate? They are asking us to calculate union of these two sets. We know that union of these two sets is denoted by X union Y. Okay, that equal to, what is X? 1, 3, 5 union. What is Y? The set Y is 1, 2, 3. Now, how the union of sets is defined? We learned this in the synopsis now. How the union of sets defined? The elements which are present in X, it comes to X union Y. The elements which are present in X, which comes to X union Y. The elements which are present in Y comes to X union Y. The elements which are present in both also comes in X union Y. What we learned? A union B means all the elements present in A are present in B are present in both. So here, if the element present in X, you look here, this is the element present in X. It comes in X union Y or not? Yes, it comes in X union Y. Now look here, 3 is the element present in X. Definitely it comes to X union Y. Even though it is present in both, it comes to X union Y. X union Y means all the elements present in X will be in X union Y. All the elements present in Y will be in X union Y. All the elements which are present in both also will be in X union Y. I hope you understand. So whatever element is there in X, that definitely comes to X union Y. You observe here, I'll try to write one order wise so that it looks good. Here 2 is there in Y. That 2 comes to X union Y? Yes. So 2. Next, 3 is there in X. It comes to X union Y? Yes. So 3. Next, 5. You observe here 5. 5 is there in X. So 5 comes here. So what you got here? You got 1, 2, 3, 5. So X union Y is what? X union Y is 1, 2, 3, 5. I hope you understand. The basic idea of X union Y means if the element present in X, it will present in X union Y. If the element present in Y, it present in X union Y. If the element present in both, then also it will be in X union Y. As I said, first question, fifth question we are doing at a time. I'll calculate X intersection Y also. X intersection Y. You write the elements of X 1, 3, 5 intersection. What are the elements of Y? 1, 2, 3. Now you observe the elements which are common in both. You look here. 1 is the element which is common in both, and you can observe that 3 is the element which is common in both. So what is X intersection Y? The elements which are present in both only present in X intersection Y. So here 1 is present in X, 1 is present in Y also. 3 is present in X, 3 is present in Y also. So the common elements will come in X intersection Y. So what is X intersection Y? X intersection Y is 1, 3. I hope you understand this. Right? So for the first bit, we calculated X union Y as well as X intersection Y. Now we'll move to second bit. You observe here, the set is given like this. Set A is like this, AEIOU, and set B is given like this, ABC. What they are asking in the question? They are asking us to calculate A union B as well as A intersection B. First I'll write set A, AEIOU. Union. What is set B? Set B is A, B, C. Okay. How to calculate A union B? If the element present in A, definitely it will present in A union B. So what I'll write here? I'll write A. I just want to write a particular order. You see here after A, B is there. B is present in set B. So B will be there in A union B. B comes here. Next C. C is there in set B. That's why C comes to A union B. Next D is not there. So next E, yes. Next I, yes. O, yes. U. So you can observe whatever the element you take in A union B. This is A union B now. Whatever element you take in this set, please try to understand. Whatever element you take in this set, that will be either in A or in B or in both. So that is the definition of A union B. Union of sets means the elements. A union B means what? The elements which are present in A are present in B or present in both. I hope you can understand this easily. Okay, in fifth question they are asking intersection of sets now. So I'll calculate A intersection B. So what is set A? Set A is AEIOU. Okay. Intersection. What is set B? Set B is ABC. Okay. We need to calculate intersection of these two sets. Intersection means common elements. You look here, A is present in both the sets and any other element is common in both? No. So A is the only element which is common in both. So obviously A intersection B is what? It is singleton set A. I hope you understand how to calculate A union B and A intersection B. Now we'll move to next question. You observe this third bit, what they are asking. You see here, sets are not in roster method. Roster method means what? All the elements are listed like this. You see, this set is in which method? This is in roster method. All the elements are listed and separated by commas within the brackets. This is roster method. When it comes to this problem, the set is given in set builder form. This set is in set builder form. This set is also in set builder form. So how to calculate A union B, A intersection B? Easiest thing is, I'll write this set in roster form. I'll write this set in roster form, and this set also I'll write in roster form so that we can easily calculate. Okay, solution for this third bit. Set A. What is set A? I just want to write this set in roster form. What they are saying? X is a natural number. You know what are natural numbers? 1, 2, 3, 4, 5, 6. These are all the natural numbers. It is a natural number and multiple of 3. X is a natural number and multiple of 3. It's very simple. They are asking to write 3 table. 3 is a natural number. It's a multiple of 3. 6, 9, 12, 15, like that. This is infinite set. X is a natural number and multiple of 3. So set A is infinite set here. Note this point. Set A is infinite set. Okay. What about set B? Okay. Set B. What is set B? X says that X is a natural number less than 6. What are the natural numbers which are less than 6? What are the natural numbers which are less than 6? 1, 2, 3, 4, 5. These are the natural numbers, right? These are the natural numbers which are less than 6. Correct? These are the natural numbers less than 6. Now you observe, I written set A in roster form and set B also in roster form. Now I can easily calculate A union B as well as A intersection B. How to calculate A union B? If the element present in A, then definitely it present in A union B. If the element present in B, then definitely it present in A union B. If the element present in both, then also it present in A union B. So best thing is, first I'll write all the elements of set B. 1, 2, 3, 4, 5. These elements will be there in set A union B or not? Yes. Because these are the elements present in set B, these elements definitely present in A union B. After this, whatever numbers are there, you observe set A. 3 already written. Okay, 6. 6 not yet listed. I'll write 6. Why I am writing 6 here? Because 6 is present in A. Next, after 6, next what we'll write? 9. Why I written 9 here? Because 9 is present in A. If 9 is present in A, definitely it will present in A union B. Next what? After 9, 12. After that what? 15. After that what? 18. Like that it continues. So here A union B is a infinite set. I hope you understand this without any confusion. Right? Very simple thing is, you observe the definition of A union B. What is the definition of A union B? All the elements present in A are present in B are present in both. Simple thing. In this set, whatever the element is there, that will be in either set A or set B or both. Okay. So as per the fifth question, we need to calculate A intersection B also. No? So I'll calculate A intersection B. A intersection B means the elements which are common in both. Look here, 3 is present in A, 3 is present in B also, right? Any other element common in both the sets? Any other element common in both the sets? I don't think so. So 3 is the only element which is common in both. So I can write like this. A intersection B is like this. Singleton set 3. I hope you understand how to calculate A union B and A intersection B. Actually, these are very easy problems. Only the thing is you need to identify how we are calculating A union B, how we are calculating A intersection B. Okay, now you observe this fourth bit. What they are asking, X says that X is a natural number and 1 less than X less than or equal to 6. What to do in this problem? We need to calculate A union B as well as A intersection B. The only problem we have is this is in set builder form. If I write this set in roster method means all the elements are listed separated by commas like that, then I can easily calculate A union B, A intersection B. So what I'll do, I'll write given sets in roster form. Okay, how to write? X says that X is a natural number. You know what are natural numbers? 1, 2, 3, 4 and so on. These are all the natural numbers. And see this one, in intervals we learn about these things. This notation is there now. In intervals we learn. So in between 1 and 6, what natural numbers are there? In between 1 and 6, what natural numbers are there? Just I'll write on in between 1 and 6. Here I'll mark 0, 1, 2, 3, 4, 5, 6. If I extend further, here I'll get 7 also. Okay. You observe here as they given symbol like this, in between 1 and 6, what natural numbers are there? You just identify 1 and 6. 2 is a natural number which is in between 1 and 6. 3 is a natural number. 4 is a natural number. 5 is a natural number. These are the natural numbers in between 1 and 6 because they are saying X is a natural number. It must be a natural number and it must be in between 1 and 6. In last exercise we learned about intervals. Na? When they given less than or equal to, that means at the time the 6 is also included, right? So here 6 is also included. I hope you are understanding. Here 6 is also included. Got the point? So what are the natural number in between 1 and 6 means 2, 3, 4, 5. As they given less than or equal to, we'll include 6 also. So what is set A here? Set A is 2, 3, 4, 5, 6. You observe here I not taken 1. In case here less than or equal to symbol is there. In case here less than or equal to symbol is there. Then at the time we need to write 1 also. But as per the question here strictly less than is there now. So we won't consider 1 even though it is a natural number. I hope you understand clearly how to write set A. They given set A in set builder form. I written this set in roster form. Okay. Now set B. What is set B? How it is? X says that X is a natural number. Okay. X is a natural number and X lies in between 6 and 10. Okay. Same. We'll take the number line. In between 6 and 10 they are saying 5, 6, 7, 8, 9, 10 something like this. X is a natural number and this notation tells you that X is in between 6 and 10. You identify the natural numbers which are in between 6 and 10. In between 6 and 10 what natural numbers are there? 7, 8, 9. These are the natural numbers which are in between 6 and 10. Okay. You can observe here they're not given strictly, they given strictly less than. They're not given less than or equal to. If they give like this 6 also we need to include. If they give like this 10 also we need to include. But as per the question in intervals we learned that 6 and 10 are not included. So what is set B here? Set B is 7, 8, 9. I hope you are understanding. Right. Now the point is set A, set B are there. Now we need to calculate A union B. How to calculate A union B? If the element present in A, that definitely present in A union B. If the element present in B, that definitely present in A union B. So I'll write first set A. 2, 3, 4, 5, 6. Okay. And then I'll write this set 7, 8, 9. 7, 8, 9. You observe once is there any element repeatedly written or not? No. 2, 3, 4, 5, 6, 7, 8, 9. So that's it. I hope you are understanding. The best thing is A union B means if I take any element in this set that will be either in set A or in set B or in both. Suppose if I take 6. 6 is there in this set. Definitely it will be. Suppose if I write 10 in this. If I write 10 in this. 10 is present in A union B means 10 must be in either A or in B or in both. You observe if I write 10 here, 10 is not there in this, 10 is not there in this also. So we cannot write like that. I hope you got the point. Now I need to calculate A intersection B. How to calculate A intersection B? Intersection means the elements which are common in both. You please observe, is there any element common in both? There is no element common in both. Can understand, there is no element common in both. So intersection of these two sets is what? It's a null set. No element is common. So we'll write like this. A intersection B is null set. So in this question, they are asking to calculate union of sets as well as intersection of sets. Both we calculated. I hope you understand this bit. Now we'll move to last bit. You look here, set A is given like this 1, 2, 3. Set B is given like this. Here this phi itself indicates it's a empty set. Empty set in roster form we'll write like this with brackets. Brackets we'll write like this with brackets with no element in it. Okay, what we need to calculate? We need to calculate A union B as well as A intersection B. Okay, A union B, set 1, 2, 3. Union B means null set. Okay, right. If the element present in A, that definitely present in A union B. If the element present in B, that definitely present in A union B. So what you will get here? Here you will get like this 1, 2, 3. You please don't write like this. Don't write like this. This is not an element. This is a set actually. Okay. So actually A union B means it will be like this. I hope you understand. A union B. A intersection B. A intersection B means what? The elements which are common in both 1, 2, 3 intersection null set. Yes, what elements are common in both? In this set there is no element. How we will find the common elements? So here the point is there is no element common in both. So what you will get here? Here you will get null set. A intersection B is null set. So A union B is this and A intersection B is like this. In first question they are asking us to calculate A union B as well as A intersection B. So both are done. So in fifth question they are asking A intersection B na. So fifth question also completed here only. So first question, fifth question complete. Now we'll move to second question. Okay, you see the second question, they given like this. Set A equal to A comma B. Set A contains two elements. Okay, set B equal to A, B, C. What is this question? Is A is subset of B? This is the first question and they are asking what is A union B. Okay, let me do this. Is A is subset of B? When we say A is subset of B, all the elements present in set A are present in set B. Then we say that A is subset of B. Now you look here, all the elements present in A are present in B. You look, first set A is there. A is present in B. Yes. B is there in set A. B is present in B. Yes. So what we will write? Yes, yes, A is subset of B. Okay, and what further they are asking? What is A union B? Okay, what is A union B? A union B means what is set A comma B. Okay, union, what is set B? Set B is A comma B comma C. How to calculate A union B? Very simple. If the element present in A, definitely it present in A union B. So I'll write all the elements of set A first. Okay. Now I'll write all the elements of set B. A already listed here. Okay. Now B is there. B is also already listed. Now C. Okay, C. The point here, if I take any element in this set, that will be either in A or in B or in both. So this is A union B. Here I need to discuss one very important point. Look here, when A is subset of B, here A is subset of B na? When A is subset of B, when I calculate A union B, I got set B only. I got set B only. So here I can write A union B as B because here I got, this is the answer. Na? This is nothing but set B. So here, what important point I am trying to say, when A is subset of B, A union B is B only. A union B is B only. At the same time, you can check that when A is subset of B, A intersection B is A. A intersection B is A. For example, here in this case only you see A is subset of B. Na? When A is subset of B, A union B, we got it as B. I will calculate A intersection B. If I calculate A intersection B, I will get A. So here A intersection B is, first I will write set A intersection, next set B. Set B is what? A, B, C. Set B is A, B, C. Now you identify what are the elements common in both. A is present, B is present. Both are present. Okay. So intersection means we will get common elements, right? A comma B. What is this A comma B? What is this? This is set A. I hope you are understanding. When A is subset of B, listen please. When A is subset of B, A union B is what? When A is subset of B, A union B is B. A intersection B is A, right? You need to remember this point. When A is subset of B, A union B is B, A intersection B is A. You observe here a Venn diagram is there. In these two sets are there, set A as well as set B. You observe this is set A. Set A is smaller set, and you observe this set B. Set B is bigger set. This itself indicates that A is subset of B. A is subset of B. What is A union B? Look here in the question only. Third question you observe carefully. In the question only they given that A is subset of B. When A is subset of B, what is A union B? That is the question. See, when A is subset of B, all the elements present in A are present in B. So when we do the union, obviously bigger set you will get. Just think little bit. When A is subset of B, A union B means what? A union B means all the elements present in A are all the elements present in B or all the elements present in both. So when I calculate A union B, I will get bigger set here when A is subset of B. I hope you understand this point. So A union B is B. In case if they ask what is A intersection B, when A is subset of B, when we do A intersection B, we will get smaller set. Here they are asking only A union B. I am telling you what is A intersection B also. A intersection B means what? The elements which are present in both. You see here, this part is present in A, this part is present in B also. I hope you are getting the point. This part is present in A, this part is present in B also. This is the set which is common in both. That's why when A is subset of B, A intersection B is A. Or else in simple words you try to remember like this. When A is subset of B, here B is bigger set, B is bigger set, A is smaller set. Correct? You just remember like that. When A is subset of B, B is the bigger set, A is the smaller set. Obvious it is. For example, you see here, in this case, A is subset of B or not? Yes, A is subset of B. When A is subset of B, you look here, B is the bigger set, A is the smaller set. Correct? So, okay, when A is subset of B, B is the bigger set, A is the smaller set. When you do their union, you will get bigger set. When you do their intersection, then you will get smaller set. Right? So, all these things works when A is subset of B. So, you learn two important points. When A is subset of B, A union B is B, A intersection B is A. I hope you understand this. Now, see this fourth question. Fourth question is very easy question, but so many bits are there. I don't want to do all the bits. Listen, set A is given like this, 1, 2, 3, 4. Set B is given like this, 3, 4, 5, 6. Set C is given as 5, 6, 7, 8. Set D, 4 sets are given. Okay, find A union B, A union C, B union C, B union D, like that. Okay, I want you to try this A union B because we did so many problems. I want you to try A union C. Now I'll do this B union C. Third bit I'll do. Okay, third bit B union C. Okay, what is set B? Set B, you observe here, what is set B? 3, 4, 5, 6. Okay, set B is 3, 4, 5, 6. Okay. Union, what is look here, B union C. Now what is set C? 5, 6, 7, 8. 5, 6, 7, 8. How to calculate B union C? In case if you confuse, best thing is write first set B. What is there here in set B? You write that set first. 3, 4, 5, 6. Okay. Next, you start writing this set. 5 already listed, no need to list again. 6 already listed, no need to list again. Next, 7, 8. That's it. B union C is over. This is B union C. With little bit of practice, you can enjoy these problems like anything. These are very easy actually. I want to do B union D also. This is the third bit. Third bit is over. Now fourth bit. What is the fourth bit? The fourth bit is B union D. Okay. Set B. What is set B? Set B is 3, 4, 5, 6. Okay. Union. What is set D? Set D is 7, 8, 9, 10. Okay. What you want to calculate? You want to calculate B union D. Right. B union D. Very simple. First write set B. 3, 4, 5, 6. Now B union D. D is 7, 8, 9, 10. Na? Okay. First element what here? 7. 7 is already listed here? No. You write 7. 8 is already listed? No. 9 is already listed? No. 10 is already listed? No. That's it. So B union D is this. This is the answer for B union D. I hope you are understanding. Right. Now you see here 3 bits are there. A union B union C, A union B union D, B union C union D. I'll try to do any 1 or 2 bits. Okay. Fifth bit I'll do. What is the fifth bit? A union B union C. Fifth bit is A union B union C. Okay. What is set A? Observe the question. What is set A? Set A is 1, 2, 3, 4. Okay. Union. What is set B? Set B is 3, 4, 5, 6. Okay. Union C. Look here. A union B union C. First I written A. Next I written B. Now I am writing C. What is set C? Set C is 5, 6, 7, 8. Okay, how to calculate A union B union C? A union B union C means the elements A union B union C contains, if the element present in A, it comes to A union B union C. If the element present in B, it comes to A union B union C. If the element present in C, it comes to A union B union C. If common elements are there, those also comes to A union B union C. I believe that you are understanding what I am trying to say. Right. Now, simple thing is, first, what elements, these are the elements in set A. This definitely will be there in A union B union C. You just write 1, 2, 3, 4. Okay. Now, you observe these are the elements in set B. These elements definitely will be in A union B union C. But the point is, here 3 is there. 3 is already listed. No need to write it again. Here 4 is there. 4 is already listed. No need to write it again. 5, 6. Okay, over. Now come to this. All the elements, these are the elements present in C. Definitely it will be in A union B union C. Now first we need to write 5. But 5 is already listed. No need to write it again. Here 6 is there. 6 is already listed here. So no need to write it again. So what we'll write? 7, 8. So what is A union B union C? Answer is 1, 2, 3, 4, 5, 6, 7, 8. I hope you are understanding. Okay, let me do one more bit here. That is the 7th bit. What is the 7th bit? Okay, 7th bit. What is 7th bit? B union C union D. Correct? B union C union D. Okay, let me take these sets so that we can easily write what is B union C union D. Okay, B union C union D. Right. Okay, see first what is set B? Observe what is set B. 3, 4, 5, 6. 3, 4, 5, 6. Okay, union. What is set C? Set C is 5, 6, 7, 8. Okay, 5, 6, 7, 8. Okay, union set D. What is set D? 7, 8, 9, 10. Okay, clear. Right. Now, what they are asking to calculate? B union C union D. I written B union C union D. How to write? If the element present in B, definitely it present in B union C union D. So write all the elements of set B. 3, 4, 5, 6, comma. If the element present in C, definitely it present in B union C union D, right? So 5 is already listed, 6 is already listed. So what you will get here? 7, 8. Now, if the element present in D, definitely it present in B union C union D. Here 7, 8 already listed here. So what you will get? You will get 9, 10. I hope you understand this solution. I just ask you to please do the homework problems in this, right? So that you will get more clarity. In this 7 bits are there. I given 3 bits homework. You just try your own. These are very easy problems. So till now 5 problems completed. Now we will move to 6th problem. Observe this question number 6. They given set A, set B, set C, set D. Then find the following. So you observe A intersection B, B intersection C, A intersection C, B intersection D. Like that these things are given. So what I will do first, you observe these 4 bits. In these 4 bits, I'll try to do any 2 bits. Okay. So because there are 2 sets intersection. So what I'll do, in last problem, you know how to calculate A intersection B. You please do this first bit. Now we'll do this second bit. What is second bit? B intersection C. Okay. What is set B? Set B is 7, 9, 11, 13 intersection. Here C is there, na? Set C. B intersection C we are calculating, right? Set C. What is set C? 11, 13, 15. Okay. B intersection. Intersection means common elements. 13 is common in both and 11 is also common in both. Next, any other element is common in both the sets? No. So what is B intersection C? B intersection C is 11, 13 because these are the elements which are common in both. Now you observe this fourth bit. You try this 4th bit. I'll do this 5th bit. Okay, 5th bit. Model wise we are doing B intersection D. Okay. What is set B? Set B is 7, 9, 11, 13 intersection set D. What is set D? 15, 17. Okay. You observe that. Is there any element common in both? Here 15 is there. 15 is not in first set. 17 is not in first set. So there is no element common in both the sets. In that case, we will write that their intersection is null set because there is no element in common. So we completed these 4 bits.
I request you to please try this second bit and fourth bit. Sorry, I request you to try this first bit and fourth bit. Okay. Now this third bit, A intersection C intersection D. Okay. Third bit, A intersection C intersection D. Okay. First you write set A. What is set A? 3, 3, 5, 7, 9, 11. Okay. Intersection. Set C. 7, 9, 11, 13. Intersection. What is C? 11, 13, 15. Okay. Intersection. Set D. What is set D? 15, 17. Now you identify the elements which are common in all three sets. For example, 15 you take. 15 is, you look here, 11 is there. 11 is present in these two sets only, but 11 is not in this set. Is there any element which is common in all three sets? You please identify. Is there any element which is common in all three? We can easily identify that there is no element which is common in all three sets. For example, if you can do this problem in another method also, you can do intersection of these two. If you do intersection of these two, what you will get? You will get 11. You will get 11, right? After that, you do intersection with this set, then also there is no common element. Or else no need of doing all those things. You identify, is there any element which is common in all three sets? There is no element which is common in all three sets. So their intersection is null set. I hope you understand this. Before going to do further, first we will take these four sets. See this fourth bit, A intersection B union C. We will calculate this. How to calculate A intersection B union C? Here, whatever is there in brackets, we will calculate that first. Okay. So here this equal to first set A. What is set A? Set A is 3, 5, 7, 9, 11. Okay. Intersection. You look here, B union C. By this time, you are in a position to write B union C directly. B union C. B union C means the elements which are present in B as well as present in C are present in both. So I'll write B union C directly. Okay. How to write B union C? Here first write all the elements of B. 7, 9, 11, 13. Now you write all the elements of C. 11. 11 is already listed. 13. 13 already listed. 15. 15 is not listed. So this is B union C. I hope you understand. By this time you are in a position to write B union C directly. This is B union C. What happened? I written A intersection. Whatever is there in brackets that you calculate. B union C. This is B union C. Now intersection. Intersection means what? Common elements. Is there any element which is common in both? You observe 9 is the element which is common in both. 7 is the element which is common in both. And 11 is the element which is common in both. Any other elements? Right. So what are the elements which are common in both? 7, 9, 11. So this is A intersection B union C. Okay. Next, sixth bit is over. You observe this seventh bit. You can do this very easily. Right? I want you to try this seventh bit your own. Now you see this eighth bit. We will do this eighth bit. What is this eighth bit? A intersection B union D. Okay. This problem also similar to last problem. What I will calculate? First I will calculate B union D. Before that you write what is A. What is A? The set A is 3, 5, 7, 9, 11. Intersection B union D. What is B union D? You just try to write B union D directly. This is B, this is D. First write all the elements of B. 7, 9, 11, 13. Now you write all the elements of D. 15. 15 is already listed here? No. You write 15. Next 17. 17 already listed here? No. So you write 17. You know by this time because from first problem onwards we are learning in examples also we learn how to calculate A union B, A intersection D, A intersection C, all those things. Right? This is a simple thing only. Actual point is what? I calculated B union C, I written here. Now what to do? We need to do intersection of these two sets. Intersection means the elements which are common in both. Yes, identify the elements which are common in both. 11 is the element which is common in both. Next, 9 is the element which is common in both.
7 is the element which is common in both. Next, any other element is common? No. So what you will get here? Here the answer is 7, 9, 11. I hope you are understanding. 8th bit is completed. Now you come to 9th bit. You see 9th bit, this is the 9th bit. Okay, 9th bit. 9th bit, we need to calculate A intersection B intersection B union C. What I'll do, whatever is there in brackets, that I'll calculate first. You can see here the sets A, B, C, D are written here, A, B, C, D. Okay, so first what I'll do, I'll calculate A intersection B. Okay, A intersection B. Calculate A intersection B. You observe here itself, A intersection B, the elements which are common in both A intersection B. 7, 9, 11. 7, 9, 11. These are the elements which are common in both. Correct? So I'll write directly here. What is A intersection B? A intersection B is 7, 9, 11. I hope you understand. Right. Now intersection B union C. Look here, B union C. This is set B. This is set C. B union C. Okay, B union C. Here what is there? 11, 13. 11. B union C. Na? B union C means here what elements are there in set B? 7, 9, 11, 13. All the elements of set B comes in B union C. When it comes to C, 11 is already listed here. 13 is also already listed here. So what you will get here? 15. Okay, so what we do? We do intersection of these two things. Yes, intersection of these two things. 7, 9, 7, 9, 11, 7, 9, 11. So what you will get here? This is 7, 9, 11. That's it. 7, 9, 11. I hope you are understanding. Now you see 10th bit of this problem. We'll calculate this one. What I'll do first, what is there in brackets? I'll calculate that first. A union D. Next I'll calculate B union C. Later I'll do intersection for these two sets. A union D, you can write directly. First you write all the elements of set A. Okay, write all the elements of set A. 3, 5, 7, 9, 11. Okay, now you write all the elements of set D. 15, 17. 15, 17 listed here? No. So you write those 15, 17. Okay, intersection B union C. How to calculate B union C? First you list all the elements of B. 7, 9, 11, 13. B union C, na? You observe where is C? 11, 13, 15. 11, 13 already listed. So what you need to write? You need to write 15. Okay. Now B union C. B union C, we got it. Now we need to do intersection of these two sets. Identify the elements which are common in both. First 7. 7 is common in both. 9 is common in both. 11 is common in both. Next 15 is common in both. Right? Other than this, any other common elements? No. So what elements present in both? That comes in intersection 7, 9, 11, 15. With this question number 6 is completed. I hope you will do whatever the homework problems given in this easily. Okay, now we'll move to question number 7. Okay, this is a little tricky one, but actually it is easy only. You observe set A, they given in set builder form. Set B is also there in set builder form. Set C is also there in set builder form. Set D, it is also there in set builder form. We need to calculate these things. Okay, first thing what I'll do to make the things are simpler, I'll try to write these sets in roster form. Roster form means all the elements are listed separated by commas within the brackets. What is set A? X says that X is a natural number. What are the natural numbers? 1, 2, 3, 4, 5, like that. These are all natural numbers. Okay, set A I written. Set B. What is set B? Please observe set B. X is a even natural number. What are even natural numbers? 2, 4, 6, 8, like that. These are all even natural numbers. These are all infinite sets. Okay, set C. What is set C? Set C is X says that X is a odd natural number. What are odd natural numbers? 1, 3, 5, 7, 9, 11, like that. These are all odd natural numbers. Set D. What is set D? x as that x is a prime number. What are prime numbers? 2, 3, 5, 7, like that. This is also infinite set you will get. Okay, so here all 4 sets I written in roster form. Okay, first bit. What is the first bit they are asking in this question? They are asking to calculate A intersection B. Okay, while calculating A intersection B, what are the elements which are common in both? You observe. What are the elements which are common in both? Look here, 2 is common in both, 4 is common in both. In this set 6 is there, 6 is common in both. In this set 8 is there because it is a set of all natural numbers now. This set is set of all natural numbers now. In this 8 is there. So you can easily identify that A intersection B is set of all even numbers. 2, 4, 6, 8. 2, 4, 6, 8 and so on. Right? This is nothing but set B. A intersection B is B. Here I want to tell you one point here. We can do this problem in another way. If you observe this set A and B, observe these two sets please. Observe these two sets. Set B is a subset of A. All the elements present in set B are present in A. Correct? Here I'll write here. B is subset of A. When B is subset of A, in in previous problems also we discussed. If B is subset of A is bigger set, B is smaller set. Okay, when we do B intersection A is same as A intersection B. B intersection A is same as A intersection B. When B is subset of A, B is smaller set. When we do intersection of these two sets, you will get smaller set only. That is B you will get. I hope you understand. That is what happened here. So, no need of doing all this procedure. When you realize that this B is subset of A intersection B is B only. Try to do this second bit. What is second bit? In second bit, they are asking A intersection C. You observe the sets A and C. Is A is subset of C or C is subset of A? All the elements present in C are present in A. I hope you are understanding. In this case, clearly we can say that C is subset of A. When C is subset of A is the bigger set, C is the smaller set. Okay. So when we do their intersection, like A intersection C, when we do intersection, smaller set we will get. What is smaller set? C. When we do their union, you will get bigger set, right? So A intersection C is what directly you can say as C is subset of A intersection C is C only. In case if you have any doubts, you can check here. A intersection C, you identify the common elements. Okay. Common element 1, 1, 3, 3, 5, 5. Whatever the elements present in this set, they all present in set A because set A is natural numbers. Here 7 is there. Here 7 is there. 7 will present in this, right? So obviously the set C only will come. No need of all these things. Directly we can say when A is subset of C, when C is subset of A intersection C is C only. I hope you got the point, right? Now we'll move to third bit. What is third bit? Third bit is A intersection D. We need to calculate A intersection D. Can you say anything about this A intersection D? Is A is subset of D or something like that? A intersection D. This is set A. Okay. This is set D. Okay. Now clearly we can say that D is subset of A. For this, D is subset of A. Clearly D is subset of A. Here each prime number is a natural number. D is subset of A. Is that clear or not clear? D is subset of A. When D is subset of A, when we do their intersection, A intersection D, smaller set will come. Smaller set is what? D. So A intersection C is D. I hope you are understanding. Next, fourth bit. Fourth bit is what? Fourth bit is B intersection C. Here B intersection C, you observe these two. This is B, this is C. If B is set of all even natural numbers, C is set of all odd natural numbers. Can you find any element common? Can you find any element common in both? No, because these are all even natural numbers, these are all odd natural numbers. You won't find any element which is common in both. So B intersection C is null set.
I hope you are understanding. Just little bit. Try to think little bit. These are easy bits only. Okay. Fifth bit. What is fifth bit? Fifth bit is B intersection D. Okay. B intersection D. You observe the set B and set D. Is there any element common in both? D is set of all prime numbers. D is set of all prime numbers. We know that in prime numbers 2 is the only even prime number. Remaining all prime numbers are odd numbers only. Okay. So here you see B intersection D, here 2. 2 is the element which is common in both the sets. There is no other element common in both the sets. Here these are all even numbers. Here these are all odd numbers. 2 is the only element which is even as well as prime. So when we do B intersection D, what is the common element in both? 2 is the common element in both. Okay. Now we'll go to sixth bit. What is the sixth bit? Sixth bit is C intersection D. Okay. You observe set C and set D. C intersection D. You observe C intersection D. Is there any element common in C and D? Is there any element common in C and D? Okay. 3 is the element which is common in 3 is the element which is common in both. 5 is the element which is common in both. 7 is the element which is common in both. 11 is the element which is common in both. Because D is set of all prime numbers. In this 9 won't come. Right? Next 11 only will be there. So odd prime numbers. C intersection D is nothing but, I can write like this. X says that X is odd prime number. Odd prime number. We can write like this. Right? I hope you understand this question number 7. Now we'll move to question number 8. You observe what they are asking in this question. Which of the following pairs of sets are disjoint? Disjoint sets. We learn in the theory, when we say two sets are disjoint, suppose A comma B are two sets. When we say these two sets are disjoint, when their intersection is null set. When their intersection is null set, then we say that the sets A comma B are disjoint. When the sets A comma B, when we say the sets A comma B are disjoint, when A intersection B is null set, then we say that the sets are disjoint. Okay, so here we'll start the solution. To identify these two sets are disjoint or not, if both the sets are in roster form, it is easy to decide. Okay, so what I'll do, I'll try to write both the sets in roster form. First set, you observe this is already in roster form. Roster form means all the elements are listed separated by commas. 1, 2, 3, 4. Okay, intersection. Because to say whether they are disjoint or not, I need to calculate intersection of given sets. Intersection of given sets is empty set, then we say that they are disjoint. Otherwise, we will say that they are not disjoint. Okay, now I'll write this second set. Actually, this set is given in set builder form. We'll write this set into roster form. What x? X is a natural number and x is in between 4 and 6. We know that in earlier problems also we used this notation. X is in between 4 and 6 means as a less than or equal to is given 4, 5, 6. 4, 5, 6. Right? Actually, in between 4 and 6, 5 is the only natural number. As they given less than or equal to here, we'll include 4 and 6. I hope you understand how to write this set in roster form. Okay, we already done these problems in earlier problems, right? Now you just calculate their intersection. Is there any element common? You see here 4 is the element which is common in both. Any other element? No. So here 4 is the element which is common in both. When we do their intersection, you will get set like this. This is not a empty set. Please observe this. This is not empty. When their intersection is empty set, then only we say that given pair of sets are disjoint. So here what I'll write, given pairs of sets are not disjoint. They are not disjoint. When we say they are disjoint, when we calculate their intersection, if we got empty set, then we say that they are disjoint. Here we got non-empty, that means they are not disjoint. Okay, now we will move to second bit. What is the second bit? Look here. A, E, I, O, U, and both the sets are in roster form only. So calculating this is very easy. A, E, I, O, U is the first set.
intersection. Next, what is the second set? C, D, E, F. Okay, you do the intersection of these two sets. What you will get? Intersection, any element is common in both, you check it. E is the element which is common in both. Next, A, I, O, U, right. This is the element which is common in both. This is the element which is common in both. So when we do their intersection, I got like this. This is not a empty set. This is not a empty set which contains one element. So their intersection is non-empty. So what I can say? I can say that given pair of sets are not disjoint. I hope you got this point. Now we'll move to third weight. Okay, what is this third weight? Let's see this third weight. Third weight, x is even integer, x is odd integer. Okay, third weight, x is even integer. What are even integers? 2, 4, 6. You observe here, even integer set is there, na? That set intersection, odd integer is there, na? This one, odd integer, intersection, odd integer. When we do the intersection of these two, this contains all even numbers, this contains all odd numbers. Definitely there will be no common element in both. It can be understood because first set contains even integers, second set contains odd integers. When we do their intersection, you will get null set only. As you got their intersection is null set, what we can say? We can say that given pair of sets are disjoint. Given pair of sets are disjoint. Given pair of sets are disjoint. I hope you understand this eighth question, right? In case if you felt difficulty anywhere, you just this is a recorded video now. You can go back and you can check what clearly explained and what point you missed that causes you not understanding this point. Still any doubt is there, in comment section you can mention. Please observe this question number 9. Set A, set B, set C, set D. Like that 4 sets are there. Okay, so we need to calculate A minus B, A minus C, A minus D, B minus A, like that. In theory part, we learn how to calculate difference of set. Okay, however, you see the first bit. What we need to calculate? We need to calculate A minus B. Okay, first I'll write set A. What is set A? 3, 6, 9, 12, 15, 18, 21. Minus second set. Second set is what? 4, 8, 12, 16, 20. Here the point is A minus B means all the elements present in A but not in B. Try to understand. A minus B means all the elements present in A but not in B. To do this, we have a small trick. First, you identify the elements which are common in both. So, identify the elements which are common in both. Actually, 12 is the element which is common in both. Next, is there any element common in both? 12 is the only element which is common in both? Yes. So, what you will get here, we identified that 12 is the element which is common in both. You observe, other than 12, whatever the elements present in this set, other than 12, whatever the elements present in this set, they are in set A but not in B. Whereas, when it comes to 12 is A as well as in B. But as per the definition, A minus B means only A. The elements which are present only in A. But this is not only in A. This is present in B also. So we need to eliminate this 12. So what you will get? 3, 6, 9, 15, 18, 21. So this is A minus B. I hope you understand this, right? Now, similarly, A minus C, A minus D, B minus A, I'll calculate A minus D. You see here, I'll calculate third bit. Third bit is A minus D. Look here, third bit, I'll calculate A minus D. Okay, first I'll write set A. Write set A. What is set A? 3, 6, 9, 12, 15, 18, 21 minus set D. What is set D? Set D is 5, 10, 15, 20. Okay, A minus D. Here, first identify the elements which are common in both. Is there any element common in both? 15 is common in both. Next, there is no other element common in both.
So you write the other than 15, all the elements of first set you need to write. All the elements of first set, that is 3, 6, 9, 12, 18, 21. I hope you are understanding this bit. Now I'll calculate this fifth bit. What is fifth bit? Fifth bit is C minus A. First I'll write set C. What is set C? Here you try to understand, we are writing all the elements of first set only. A minus B means only A but not B. A minus D means only A but not D. C minus A means only C but not A. Okay, we'll write all the elements of C which are not in A. Okay, so here C minus A. What is C? C is like this: 2, 4, 6, 8, 10, 12, 14, 16. Okay, minus what is set A? Set A is 3, 6, 9, 12, 15, 18, 21. Okay, now you identify the elements which are common in both. 6 is the element which is common in both. Next 12 is the element which is common in both. Next 14, 16. You observe, is there any other element common in both? Oh, now other than these common elements, in first set what elements are there? That is C minus A. That elements belongs to only C but not in A. I hope you are understanding. So what is C minus A? C minus A is 2, 4, 8, 10, 14, 16. In this way, you can calculate all these bits very easily. Basic idea is you need to identify the pattern, in what pattern we are doing. A minus B means what? All the elements present in A only but not in B. So best method is to calculate A minus B. You write set A as well as set B. Identify the common elements. Now other than common elements, in first set what elements are remaining, those you write. I hope you can do other problems very easily in this. Now we'll move to 10th problem. You see, this is also similar to last problem only. Okay, 10th problem. What they are asking in the first bit? They are asking to calculate x minus y. Okay, write set x A, B, C, D. Okay, minus y. What is y? F, B, D, Z. Okay, so when we do their subtraction, the difference of two sets, how to calculate? First identify the common elements. B is present in both, D is present in both. Next, is there any element common in both? Now x minus y means the elements present in x only but not in y. So other than common elements, in first set what elements are remaining, that elements you need to write A, C. I hope you understand. So x minus y is A comma C. Now second bit. What is the second bit? Second bit is y minus x. Okay, write y. What is y? F, B, D, Z. Minus what is set x? Set x is A, B, C, D. Now you identify the common elements in both. B is the element which is common in both. D is the element which is common in both. So yeah, y minus x means you need to write all the elements of y which are not in x. So other than these common elements, what elements present in first set, that you write F comma G. I hope you are understanding. Now see the third bit. Third bit is very simple actually. What they are asking? They are asking x intersection y. Okay, what is x intersection y? X is A, B, C, D intersection. What is y? Y is F, B, D, Z. So here intersection of these two sets means the elements which are common in both. B is the element which is common in both. D is the element which is common in both. So intersection means what we will write? The intersection of sets means how you will write? The elements which are common in both. So what are the elements which are common in both? B, D. These are the elements which are common in both. This is very easy problem, right? I hope you understand this. Now you see this 11th question. What is 11th question? In 11th question, what they are asking, R is set of all real numbers. Okay, we know real numbers. Real numbers are in interval form. If I write minus infinity to plus infinity, these are the real numbers. Or else we can say like this also. Real numbers means
union of rational plus irrational. Union of rational plus irrational. Irrational numbers is denoted like this also, r minus q. The numbers which are not rational are called irrational numbers. Na? So what I want to say in this point, real numbers is nothing but union of rational and irrational numbers. R minus q is also known as set of irrational numbers. From all real numbers, if you remove rational numbers, whatever remaining are there, they are all irrational. So R minus q is set of all irrational. Try to understand. R is set of all real numbers. Q is set of all rational numbers. Then what is R minus Q? Very simple. Here the simple point is R is there here. R contains, what is R? Union of rational and irrational. R real numbers definition can be given like this. Real numbers means union of rational and irrational numbers. In this real numbers, rational numbers will be there. Irrational numbers are also will be there. From the real numbers, if you remove rational numbers, whatever remaining are there, they are all irrational. It can be understood very easily. R minus Q itself indicates set of all irrational numbers. Set of all irrational numbers. The simple, this is the notation actually. R minus Q, if Q is the set of rational numbers, R minus Q is set of all irrational numbers. Irrational numbers means you know na, root 2, root 5, root 11, such type of things are set of all irrational numbers. The numbers which are not rational are called irrational numbers. We will move to next question. This is very easy question. State whether each of the following statements is true or false. Justify your answer. Okay, you observe this first bit. What they are asking in the first bit, these two sets are given, they are disjoint. They are saying that 2, 3, 4, 5, 3, 6 are disjoint. These sets are disjoint. We need to decide whether it is true or false. When intersection of two sets is null set, when intersection of two sets is null set, then we say that given two sets are disjoint. Otherwise we say that they are not disjoint. Okay. First bit, I'll take intersection of these two sets, 2, 3, 4, 5, intersection 3, 6. Okay, do the intersection of these two sets. Intersection of these two sets, you can observe 3 is the element which is common in both. When we do intersection of these two sets, you are getting 3. Is it a null set? No. This is a singleton set. It contains one element. As intersection of these two sets is not a null set, so what we can say, given this is false. They are asking just true or false. No? They are just asking to write true or false. So they are saying they are disjoint, but actually they are not disjoint. Given statement is false. Now come to the second bit. What they are asking, again they are saying that they are disjoint sets. I'll check. A, E, I, O, U, intersection A, B, C, D. I'll do their intersection. A is the element common in both. Next, any other element common is there? No. So when we do their intersection, what you are getting? You are getting singleton set A. Is it is a empty set? No, it is not a empty set. So what they are saying in the question they are saying they are disjoint sets. They are asking us to decide true or false. Actually they are not disjoint because their intersection is not empty. So what we say here, this given statement is false. They are saying disjoint, but actually they are disjoint. They are not disjoint. Okay, third bit. What they are asking in the third bit? Two sets are given. They are asking they are disjoint sets or not. To decide that, you just calculate their intersection. 2, 6, 10, 14. Intersection 3, 7, 11, 15. You observe, is there any element common in both? 2 is not in this, 6 is not in this, 10 is not in this, 14 is also not in this. So when we do intersection of these two sets, there is no element in common. So what I can say, there is no element in common means what I can say that this is disjoint set. Intersection of these two sets is null set. If intersection of two sets is null set, we can say that they are disjoint sets. They are disjoint sets. That also that is same thing mentioned in question. So this statement is true. Similarly, you do this fourth bit. You observe here
2, 6, 10, 3, 7, 11. When we do their intersection, we will get empty set only. So obviously these sets are disjoint sets. So we can easily say that this statement is true. I want you to try that problem. With this, exercise number 1.4 is completed. I hope you understand this full exercise. This is a little lengthy exercise. Just once or twice practice is needed. What you will do while practicing these problems, if you felt any particular problem difficult, you keep something like P. P means practice is needed. When we do second time, you stress on the problem which causes you difficulty in that problem. And if you felt any difficulty, you always comment in comment section. I'll respond to your doubt.
Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 5th class in Ncert chapter. Till now we completed 4 exercises in Ncert chapter. This 5th exercise is easy, but you need to have good grip on complement of a set definition. So in the first 10 minutes I clearly explained what is complement of a set and what are the properties of complement of a set. Even though if you understand the definition of complement of a set, in third problem you may confuse little bit. I just want you to listen carefully when third question is going on. In case if you felt any difficulty in that, you just come back and you try to understand. As these videos are recorded videos, you can go back and you can check what is the explanation for that. Still, in case if you felt difficulty, you please comment below so that in live classes I'll discuss this problem again. Without much delay, let's begin the class. Complement of a set. What is the definition of complement of a set? Complement of a set A is denoted by A dash or A power C, A bar. Generally, complement of set A is denoted by A dash. And how it is defined as all the elements present in universal set U but not in A. All the elements present in universal set but not in A. Try to understand. A dash is all the elements present in universal set but not in A. We will try to understand what is A dash by using Venn diagram. You observe this Venn diagram. This is set A. Which zone is known as A dash? You observe this lines part is there na, like this. This lines part is there na. This part is nothing but A dash. You try to understand all the elements present in universal set but not in A. So A dash is all the elements present in universal set but not in A. So A dash is U minus A. Now we'll try to understand few important points related to complement of a set. You see this A dash means not A. A dash whole dash. A dash whole dash is nothing but A. It can be understood easily. A dash whole dash equal to A. Complement of universal set. Complement of universal set is defined as empty set. Complement of empty set. Complement of empty set is defined as universal set. Now see the 5th point. A union A dash. When we do A union A dash, what you will get? You observe here. This is set A and this part is A dash. When we do their union, what you are getting? You are getting universal set. You can understand this easily. This is set A. This circle is set A. And this horizontal, this lines part is there na? That is A dash. If we do their union, we will get this total box. This total box is nothing but universal set. So A union A dash is universal set. A intersection A dash. You observe that A and A dash both are disjoint. There is no element common in A and A dash. So A intersection A dash is null set. Now De Morgan's law. A union B whole complement. A union B whole complement is A complement intersection B complement. Similarly, A intersection B whole complement can be written as A complement union B complement. These are known as De Morgan's law. I'll try to prove this De Morgan's law by using Venn diagram. You observe here, this rectangular box is the universal set and this is set A and this is set B. If you observe this Venn diagram, in this total 4 parts are there. You observe only A is part 1, intersection of A and B is part 2, only B is part 3. Other than these circles, whatever the remaining place is there, that is fourth part. Please try to understand what is fourth part. Other than these circles, this whole thing is fourth part. Now you see, I will try to prove this first result. A union B whole dash. What is meant by A union B whole dash? Here you try to understand A dash means not A. So A union B whole dash means which part you will get. You try to understand A union B whole dash. A union B whole dash means not A union B. Not A union B means which part will come? Which part will come, you please tell? Fourth part is not A union B. Okay. Now A dash. What is A dash? A dash means not A. Other than A, what parts are present in this? 3 and 4. So what is A dash? A dash is 3 and 4. B dash. What is B dash? B dash means not B. Not B. That means 1, 4. You try to understand this. 1, 4. Here, what is A dash intersection B dash? A dash intersection B dash is the common part present in A dash and B dash. What is the common part present in A dash as well as B dash? That is fourth part. So you can easily understand here A union B whole dash is nothing but A dash intersection B dash. Similarly, we can observe that A intersection B whole dash is nothing but A dash union B dash. And last point, what is A dash? A dash is nothing but not A. In general words, you can remember it. A dash is nothing but not A.
This is exercise number 1.5. In this exercise number 1.5, most of the problems based on complement of a set. Before starting this exercise, it is important that you must good in the definition of a complement of a set and you know how to calculate complement of a set. Let's see the solution of first question. Okay, the question is like this. They given universal set, set A, set B, set. They are asking us to calculate A dash, B dash, like this bits are given. What is the formula to calculate A dash? The formula for A dash is U minus A. Universal set minus A. B dash formula is U minus B. So first what I'll do, I'll write universal set. See, this is the universal set, right? Minus, I'll write set A. How to write U minus A? Very simple. In difference of sets, we learn in the same way. U minus A means first you identify the common elements in both. 1 is common in both. 2 is common in both. 3 is common in both. 4 is also common in both. Other than common elements, what elements present in first set, that is the answer. Other than common elements, what elements present in first set? Here, other than common elements, what elements present? 5, 6, 7, 8, 9. I hope you understand. What is this? This is A dash. We calculated A dash. Similarly, in second bit, what they are asking? They are asking B dash. What is the formula for B dash? The formula for B dash is U minus B. First I written universal set minus set B. How to write U minus B? You just identify the common elements. 2 is common in both, 4 is common in both, 6 is common in both, 8 is common in both. Other than common elements, what elements are remaining in first set? That is U minus B. So what are remaining? 1, 3, 5, 7, 9. So that is B dash, right? Now they are asking to write A union C whole dash. B dash formula is U minus B. C dash formula is U minus C. In the same way, A union C whole dash formula is what? U minus A union C. Okay. So before calculating U minus A union C, I need to calculate A union C first. So I'll calculate A union C. A union C, we learned in third exercise how to calculate union of sets. Okay, very simple. First you write set A. What is set A? 1, 2, 3, 4. Now you write set B also. But before that you check that any already listed elements are there or not. For example, before writing 3 already listed here. So no need to write it again. So write 4. Before writing 4 is listed here or not? Yes, it is listed. So no need to write. Next 5. 5 is not listed, 6 is not listed. So here you take any element in A union C. If you take any element from A union C, it means that that element is present in A or present in C or present in both. So A union C whole dash is what? A union C whole dash is U minus A union C. Universal set given in the question only. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just now we calculated A union C. 1, 2, 3, 4, 5. Right? So difference of these two sets. Writing difference of two sets is very easy. First, you identify the common elements. 1 is common in both, 2 is common in both, 3 is common in both, 4 is common in both, 5 is common in both, 6 is common in both. Other than common elements, what elements are remaining in first set? That is the answer. What is the answer? 7, 8, 9. Okay. Now come to this A union B whole dash. A union B whole dash means universal set minus A union B. Okay. Before calculating this, first I'll calculate A union B. So that's why I written set A union set B. Okay, that equal to, now how to write A union B? First you write 1, 2, 3, 4. Now you write 2. Before writing 2, you check here it is already listed. Now you write 4. Before that you check it is already listed. No need to list it again. 6, 8. So A union B is 1, 2, 3, 4, 6, 8. Actually what we need to calculate? We need to calculate A union B whole dash. A union B whole dash is universal set minus A union B. So first I written here universal set minus A union B. What we got? A union B is just now calculated now. 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8. Now difference of these two sets. You just identify the common elements. What are the common elements? 1 is common in both, 2 is common in both, 3 is common in both, 4 is common in both, 6 is common in both, 8 is common in both. Okay, that equal to what you will get here? 5, 7, 9. A union B whole complement is 5, 7, 9. Okay, now you see the fifth bit. A dash whole dash. What is A dash whole dash? Actually we have a formula for A dash whole dash. Best method is use that formula. A dash whole dash is A. What is set A? In the question you observe what is set A? Set A is given as 1, 2, 3, 4. So A dash whole dash is A. That is nothing but 1, 2, 3, 4. You can write like this. Okay. Now B minus C whole dash. B minus C whole dash means universal set minus B minus C. Just observe A dash is U minus A. B dash is U minus B. Like that. B minus C whole dash is U minus B minus C. To calculate this, first I need to calculate B minus C. Okay. What is set B? In the question, set B is given as 2, 4, 6, 8. Okay, minus set C. In the question, set C is given as 3, 4, 5, 6. Okay, B minus C. You identify the elements which are common in both. 4 is common in both. 6 is common in both. Other than common elements, what elements are remaining in first set? That is the answer. So B minus C is what? B minus C is 2, 8. Now B minus C whole dash. What is the formula? U minus B minus C. Now universal set. What is the universal set? Universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9 minus B minus C. What is B minus C? B minus C is 2, 8. Right? You write 2, 8. Now you identify the elements which are common in both. 2 is common in both. 8 is common in both. Right? So what you will write here, this is equal to, other than common elements, what elements are present in that set? First set, that is the answer. So what you will get here, the answer is 1, 3, 4, 5, 6, 7, 9. Right? So this is B minus C whole dash. I hope you understand the solution of first bit. Actually it is very easy. Now let's move to second question. You observe here what they given. Universal set is given. Find the complements of the following sets. Right? This is similar to last problem. So I'll try to explain quickly this. They given set A. They are asking to write its complement. Okay. A dash. What is A dash formula? U minus A. A dash formula is U minus A. First I written the universal set. Right? Minus set A. What is set A? Set A is AB. This is difference of set. Now how to calculate? First identify the common elements. A, B, C are common in both. Other than common elements, what elements are remaining in first set? That is the answer. What elements are common in first set? D, E, F, G, H. So A dash is D, E, F, G, H. So A complement is D, E, F, G, H. I hope you understand. Similarly, B dash. What is the formula for B dash? The formula for B dash is U minus B. The formula for C dash is U minus C. Very simple, right? So B dash, U minus B. I written universal set and then I written set B. U minus B, difference of sets. Very simple. First, identify the common elements. D, E, F, G. These elements are common in both. Other than common elements, what elements are remaining in first set? That is the answer. A, B, C, H. This is B dash. Now, a third bit, they given it as a set C. Okay, I need to write its complement. C dash. C dash means U minus C. C dash means U minus C. So, first I'll write the universal set, right? Universal set minus C. Now, you identify the common elements. A, C, E, G are the common elements in both the sets. Other than common elements, what elements are remaining in first set? That is the answer. B, D, F, H. I hope you got this point, right? Now, D dash. What is set D they given in the question? In the question, set D is given as F, G, H, A. Okay, D dash means U minus D. First I written universal set and the set D given in the question like this. F, G, H, A. That is what I written. Identify the common elements. Other than common elements, what elements are remaining in first set? That is the answer. B, C, D, E. I hope you understand the second bit. This is very easy. You observe this third question. Many students feel difficult to understand this. Actually, if you know the definition of a complement of set, if you have grip on what they are exactly trying to say in complement of a set, this is easy only. You observe this question. Taking set of natural numbers as universal set. Here they are taking what is universal set? Set of all natural numbers. You look here, I written. What is universal set? Set of all natural numbers. I written natural numbers here 1, 2, 3, 4, 5, 6 like that. Write down the complements of the following sets. Okay. They given first set like this. X says that X is a even natural number. Look here. X says that X is a even natural number. To write its complement, I named this set as set A. Okay, I written this set as, named it as A. Okay, this set is in set builder form, right? Given set is in set builder form. I just want to make this easier, so I'll write this in roster form. Roster form means all the elements are listed and separated by commas within the bracket. X is even natural number. Na? What are even natural numbers? 2, 4, 6, 8, 10 and so on. These are all what? These are all even natural numbers. Actually what they are asking to calculate, write down the complements of the following set. Complement means A dash. What is A dash? A dash formula is universal set minus A. Okay. What is universal set? Set of all natural numbers is the universal set. Na? So you write universal set 1, 2, 3, 4, 5, 6 and so on minus set A. What is set A? Just now we got here. What is set A? 2, 4, 6, 8, 10. Set of all even natural numbers. Now you look here, we got difference of sets. How to calculate difference of sets? First you identify the common elements. 2 is common in both, 4 is common in both, 6 is common in both. Actually here 8 is also present, 10 is also present in this set. Now you observe other than common elements, what elements remaining in the first set? 1, 3, 5, 7. These elements are remaining in first set. That means these are all odd numbers. Please try to understand. These are all odd numbers. See here, X is even natural number. What is its complement? Its complement is U minus A. That means all the elements present in universal set but not in A. What are such elements which are present in universal set but not in A? A contains even numbers. A dash contains odd natural numbers. Very simple. So if I write this answer, what I'll get? Set of all odd natural numbers 1, 3, 5, 7, 9, 11 like this. Set of all odd natural numbers. Other than even numbers, what elements are remaining in first set? That you need to write. So this is A dash. You can write this in another method also. Here A dash is there. Na? You can write like this. X says that X is a natural number and X is odd, or else X is odd natural number. For A dash you can write like this. X says that X is odd natural number. Like that also you can write. However, I felt that every student can understand if I do this problem in roster method. So I written given set in roster method so that you will get answer like this. I hope you understand. You observe this set is in set builder form. To understand the things are easier, I just want to write set B in roster form. Odd natural numbers. What are odd natural numbers? 1, 3, 5, 7, 9, 11, like that. These are all odd natural numbers. This is set B. Actually, what I need to calculate? I need to calculate B dash. What is B dash? B dash is universal set minus B. What is universal set? Universal set is set of natural numbers. So 1, 2, 3, 4, 5, 6, 7, like that. Set of all natural numbers minus set B. What is set B? Set of all odd natural numbers. I can explain this in set builder form also, but I want you to understand this easily. So I am doing this problem in roster method. Now difference of these two sets. Difference of these two sets means first you identify the common elements. 1 is common in both, 3 is common in both, 5 is common in both, 7 is common in both, 9 is also common in both, 11 is also common in both. So you identify what elements present in first set other than this second set, other than these elements. Other than common elements, what elements are present in first set? You observe 2, 4, 6, 8, 10. Even numbers. Even numbers are present in first set. So here what I can write this as B dash as 2, 4, 6, 8, 10, like that. The same thing you can write, you can stop this problem here. But you can write like this also. B dash equal to x as that x is even natural number. Even natural number, right? That is complement of given set B. I hope you understand. In third bit, they given like this. X says that x is a positive multiple of 3. Okay. X says that x is a positive multiple of 3. I'll try to do this problem also in roster method. Positive multiple of 3. What are positive multiples of 3? 3, 6, 9, 12. Actually, they are asking us to write a 3 table. 15, 18, like that, right? I am writing these sets in roster form so that you can understand complement very easily. I can write its answer directly also in set builder form. What is C dash? C dash is universal set minus C. What is universal set? In the question they are saying that set of all natural numbers is the universal set. 7, 8, like this. These are all set of all natural numbers minus what is set C? Set C is 3, 6, multiple of 3, 12, 15, and so on, like this. Now you observe the elements which are common in both 3, 6, 9, 3, 6, 9, 12. That means here what elements are remaining first set, you observe they are not multiple of 3. Please observe that point. That means I can write here 1, 2, 4, 5, 7, 8, 10, like that. But you observe other than common elements, what elements are remaining in first set means they are not multiple of 3. So this answer I'll write here C dash equal to, you can observe answer will be like this. 1, 2, 4, 5, 7, 8, 10, 11, not 12, 13, like that you will get. Instead of writing like this, best idea is write this in set builder form. X says that x is a natural number, no doubt in that, and x is not a multiple of 3. X is not a multiple. X is not a multiple of 3. I hope you understand. You observe set D. Set D is given like this. X says that x is a prime number. Okay. You know what are prime numbers. You write this set in a roster form. 2, 3, 5, 7, 11, 13. Like that, it's an infinite set. Okay. This is set of all prime numbers. Actually, what they are asking to calculate? They are asking us to calculate complement of D. That means D dash. What is D dash formula? U minus D. What is universal set? Universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that, set of all natural numbers is the universal set. Minus, what is set D? Set D is there here. This is set D. Set of all prime numbers. Okay, you see here universal set minus D. You identify the common elements. See here 2 is common in both, 3 is common in both, 5 is common in both, 7 is in common in both, right? 11 is common in both, 13 is also common in both. Here what are the elements remaining in first set? 1, 4, 6, 8, 9. You observe other than 1, what about other elements? 4, 6, 8, 9, 10. These are all the composite numbers. Please try to understand. 4 is a composite number, 6 is a composite number, 8 is a composite number, 9 is a composite number. D dash is also known as not D. X is a prime number means X is not a prime number. Not a prime number means what? Which is not prime, which is called composite number. So here what I need to write here, actually I'll just write in roster form. You observe 1 is present, next 4, 6, 8, 9, next 10, 12, 14, something you will get like this. This is D dash, but it is better to write the answer in set builder form. D dash is X such that X is a natural number, or else I do one thing. X, okay, I'll write it. X is a natural number, comma, X equal to 1 and X is a composite number. X is a composite. X is a composite number. I hope you understand this. So if set D is given like this, its complement is like this. X says that X is a natural number, X equal to 1 and X is a composite number. This is the complement of given set. I hope you understand this fourth. Now from this fifth bit onwards, I'll try to write all answers directly in set builder form only. You observe here what is they given. They given X says that X is a natural number which is divisible by 3 and 5. I need to write its complement, right? First I named this set as D. Okay. D dash is what? D dash is universal set minus D. Okay. Here natural number, X is a natural number divisible by 3 and 5. D dash is also known as not D. Not D. That means X is a natural number and not divisible by 3 and 5. Simple way to answer. X is a natural number and not divisible by 3 and 5. See here, same thing I written. X is a natural number and X is not divisible by 3 and 5. Over. Simple thing it is, right? Now come to E. This set complement we need to calculate. I named this set as E. I named this set as E. Okay. Now E dash formula is U minus E. Basic idea is what? E dash is also known as not E. Not E. Here E is what? X is a perfect square. What is E dash? Not a perfect square. Simple. Look here. X is not a perfect square. And we know that all the elements must be in universal set. What is universal set in this question? Set of all natural numbers. That's why I specified X must be natural number and X is not E. Not E means X is not a perfect square. I hope you understand this. You see next bit what they given here. They are in the question they are saying that X is a perfect cube. I named this set as F. I need to calculate its complement. That means F dash I need to calculate. F dash means U minus F. F dash is also known as not F. Okay. Here F is what? X is a perfect cube. F dash means what? Not a perfect cube. Very simple. As all the elements must present in universal set, in the beginning I will specify that X is a natural number and X is not a perfect cube. Very simple. A dash means not A. B dash means not B. Keep this point in your mind. Okay. Next set G is given like this. X says that X plus 5 equal to 8. I can do this problem in two methods. What is G dash? G dash means not G, correct? Not G. Here X plus 5 equal to 8 is there. Directly I can write X plus 5 not equal to 8. Because G dash is nothing but U minus G na. U minus G. All the elements must present in universal set. That's why I written X is a natural number and X plus 5 not equal to 8. This problem is over. Or else you can simplify this set. Here this is the set G na. X says that you take 5 to this side. 8 minus 5 is 3. X says that X equal to 3. Given set can be written like this. Given set can be written like this. What is its complement? X says that X is a natural number and X not equal to 3. For this problem you can write answer in two ways. This is the one method. Okay. You can write like this and you can stop it. Or else first you write set G like this and you write G dash like this. I hope you understand. Now Come to this ninth bit. They given this one. I named this set as H. Okay. I need to write its complement H dash. Here what is there? 2x plus 5 equal to 9. H dash means not H. That means 2x plus 5 not equal to 9. But the point is H dash means universal set minus H. Universal set is natural number here. Whatever will present in H dash, they must be natural number. That's why I specified here X as that X is a natural number and 2x plus 5 not equal to 9. Okay. Now come to the 10th bit. X says that X greater than or equal to 7. Okay. I taken this set as I. Now I need to write its complement. Greater than or equal to 9 complement means not greater than or equal to 7. Greater than or equal to complement means not greater than or equal to. Not greater than or equal to means strictly less than. Not you cannot write less than or equal to because here equality is there. Whenever they given greater than or equal to, while saying not, we'll say less than, strictly less than. Look here, X says that X is a natural number and this is greater than or equal to. Now I'll say that X is less than 7. Not greater than or equal to 7 means X is less than 7. You can write like this also. X says that X is a natural number and X is not greater than or equal to 7. That means X is less than 7 only. Okay. Now you see this ninth bit. They given like this. X says that X is a natural number and 2x plus 1 is greater than 10. Here its complement, here greater than is given, not greater than 10 means less than or equal to. Try to understand. When they given greater than, while writing its complement, you will write less than or equal. When they given greater than or equal to, while writing its complement, you will write less than. Okay. This is the set J they given. I need to write its complement, right? X says that X is a natural number and 2x plus 1 is less than or equal to 10 because they given greater than 10. You see this fourth question. They given universal set, they given set A, they given set B. They are asking that verify this bit and this bit. First, let's see first one. Now, I need to verify this by using given sets. They are not asking proof. They are asking to verify this by using given sets. What I'll do, first I'll calculate LHS. Next, I'll calculate RHS. If LHS is same as RHS, then I can say that this first bit is verified. Okay, so I'll do the first bit. In this first bit, to calculate LHS, you observe here what is there. A union B whole dash is there. Formula is universal set minus A union B. A union B whole dash formula is universal set minus A union B. So first I'll calculate A union B. So I'll calculate A union B. A union B. What is set A? Set A is 2, 4, 6, 8. Union. What is set B? Set B is 2, 3, 5, 7. Now I need to calculate its union. Very simple. First you write full set A. 2, 4, 6, 8. I written set A. Okay. Now you write set B also. But make sure that no repeated elements. You write 2, but 2 is already listed. No need to write. Now you write 3. Okay. Next you write 5. Okay. 5. Next 7. So A union B is 2, 4, 6, 8, 3, 5, 7. Now, actually, I want to calculate A union B whole dash. Okay. A union B whole dash formula is what? The formula is universal set minus A union B. Correct? Okay. What is universal set? After reading the question, we can easily say that universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see the question universal set is given minus A union B. What is A union B? Look here. A union B we got like this 2, 4, 6, 8, 2, 4, 6, 8, 3, 5, 7. Okay. So here difference of sets is there. So you just identify the common elements. 2 is the element which is common in both. 3 is the element common in both. 4 is the element common in both. 6 is the element common in both. 8 is the element common in both. 7 is the element common in both. 5 is the element which is common in both. After identifying common elements, what elements are remaining in first set, that we will write. Right? You already know this by this time. We did so many problems like this. So what you will get? 1, 9. So A union B whole dash is 1, 9. So here I'll take this as 1. Okay, I'll take this as 1. A union B whole dash A union B complement is set 1 comma 9. Now I'll calculate this RHS. What is RHS? A dash intersection B dash. For that, first I need to calculate A dash. Okay. A dash. What is A dash? A dash is universal set minus A. What is universal set? In the question they given that universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9 minus what is set A? Set A is 2, 4, 6, 8. Set A is given as 2, 4, 6, 8. Now this is difference of sets now. First you identify the common elements. 2, 4, 6, 8 are the common elements. Other than common elements, what elements are remaining in first set? That is the answer, right? So what you will get here, the answer is 1, 3, 5, 7, 9. So A dash is 1, 3, 5, 7, 9. To calculate RHS, now I'll calculate B dash. B dash means U minus, okay. So B dash, what is B dash? Universal set minus B. What is universal set? 1, 2, 3, 4, 5, 6, 7, 8, 9 minus what is set B? In the question, set B is given as 2, 3, 5, 7. Okay, 2, 3, 5, 7. Now, this is difference of sets. You identify the common elements 2, 3, 5, 7. In first set, what elements are remaining other than common elements? That is the answer. What elements are remaining? 1, 4, 6, 8, 9. Okay, now I know what is A dash and what is B dash. Actually, I need to verify A dash intersection B dash. So, I'll calculate this RHS. A dash intersection B dash. You know how to calculate intersection of two sets. A dash intersection B dash. What is A dash? Look here. A dash is this one. Okay. You take this one A dash. Okay. A dash intersection B dash. What is B dash? You can look here. This is B dash. Okay. A dash intersection B dash. You observe what are the elements common in both. Is there any element common in both? 1. 1 is common in both. Next 3, 9. 9 is common in both. Next 3, 5, 7, 3, 5, 7. There is no other element common in both. Intersection means what? Intersection means the elements which are common in both we will write. So what are common in both here? 1, 9 are the elements common in both. So what is this? A dash intersection B dash. I will take it as 2. You observe 1. What is 1? A union B whole dash is set 1, 9. A dash intersection B dash is also set 1, 9. So from 1 and 2, what I can conclude? From 1 and 2, what you can conclude? I can conclude that what is 1? You observe what is 1? A union B whole dash. A union B whole dash equal to what is 2? A dash intersection B dash. Hence, we verified first bit. A union B whole dash equal to A dash intersection B dash. Now, second bit. What is second bit? A intersection B whole dash equal to A dash in union B dash. Okay, I need to verify the second bit. Right, this is the second bit. Same procedure. First, I'll calculate LHS, A intersection B whole dash. Next, I'll calculate RHS. Later, I'll check that both are equal or not. For calculating A intersection B whole dash, you know this formula. A intersection B whole dash formula is what? Universal set minus A intersection B. First, I'll calculate A intersection B. Okay, A intersection B. What is set A given in the question? In the question, set A is given as 2, 4, 6, 8. Intersection. What is set B given in the question? Set B is given as 2, 3, 5, 7. Okay. Now, this is intersection. You identify the common elements. 2 is the common. Next, here 4, 6, 8 is there. Here 3, 5, 7 is there. So the only common element is 2. You know how to calculate intersection of sets. Intersection means common elements we will write. Okay. Now I need to calculate this A intersection B whole dash. So what is A intersection B whole dash formula? Universal set minus A intersection B. What is universal set? In the question, they given universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9 minus A intersection B, we got it as 2. Now, you observe the common elements in both the sets. 2 is the element common in both the sets. So what elements are remaining in first set? 1, 3, 4, 5, 6, 7, 8, 9. So A intersection B whole dash I calculated. What is A intersection B whole dash? 1, 3, 4, 5, 6, 7, 8, 9. Now what I'll do, I'll calculate this RHS. A dash, I already calculated A dash in this bit, right? A dash, B dash, both are needed. Okay, I'll copy those things, A dash as well as B dash, A dash, B dash. Okay, I'll calculate A dash as well as B dash. Okay, now what I need here, A dash union B dash I need. Okay, A dash union B dash. A dash union B dash. Okay, what is A dash? 1, 3, 5, 7, 9. Union, what is B dash? B dash is 1, 4, 6, 8, 9. Union means you know how to write union of two sets. First write the first set full. 1, 3, 5, 7, 9. Okay. Next continuation. You write 1. Next this full set you write 1. 1 already written. Next 4. You write 4, 4. Next 6. 6 is there here. Okay. 6. Next 8. Okay. Next 9. 9 already written here. So no need to write it again. Oh, okay. No. 9. 9 already written here. No need to write it again. So actually in this there is no proper order. Just to check first and second. I do one thing. I'll write in a order wise. First 1. Next 2 is there, no. 3, next 4 is there, yes. 5 is there, next 6 is there, 7 is there, 8, 9. Just written an order wise so that we can easily verify. A dash union B dash. I'll take it as second one. You observe first one, A intersection B whole dash. What you got? 1, 3, 4, 5, 6, 7, 8, 9. 1, 3, 4, 5, 6, 7, 8, 9. You can observe 1 and 2. Both are same. So from 1 and 2, what I can conclude? From 1 and 2. What is the first one? A intersection B whole dash. A intersection B whole dash equal to A dash union B dash. I hope you understand. Hence, we verified both the bits in fourth question.
You observe question number 5. Draw appropriate Venn diagram for each of the following. You observe this first one. What is this first one? A union B whole dash. Okay. We know that A dash means not A. B dash means not B. Like that we can say. Here A union B whole dash means not A union B. A union B whole dash means not A union B. You observe this. Here I consider two sets AB in the form of circles. This is set A, this is set B. In this Venn diagram, you show me where is A union B. You can see this part. This part is there now. What is this part? This part is A union B. We learned this in the theory part when we are learning definition of union of sets, right? What is this? This is A union B. Here, what is there? A union B whole dash is there. A union B whole dash means not A union B. So, not A union B. In this diagram, this part is A union B. Na? Other than A union B, what part is there? You can observe this part. This part is not A union B. So, I'll shade that part, that not A union B part is there. Na? You look here, this slight green color one is there. Na? What is this? This is not A union B. It is very easy to say that which one is not A union B, right? So, what is this green color part? This green color part is not A union B. I hope you understand this. So, what I'll do here, I'll draw one small box in that whatever the color is there, that color is nothing but A union B whole dash. It's very simple. A dash means not A. B dash means not B. C dash means not C. A union B whole dash means not A union B. So here this part is there. Na? This part is not A union B. Now we will try to understand this second bit. Actually we know this formula. In properties of complement of a set we learned this. A union B whole dash is same as A dash intersection B dash. So the diagram what you will get for this and the diagram what you will get for this both will be same. However, I'll try to explain this in a different way, right? Okay, see this A dash intersection B dash. A dash means what? A dash means not A. First what I'll do, I'll mark not A. You observe Here Venn diagram is there na. I'll mark which one is not A. A dash, whatever I am marking now, that is A dash. A dash means what? A dash means not A. Other than A, full part, you can observe, other than A, full part I am marking here. Other than A, full part I marked here, right? What is this? This, whatever the colored part is there, that is A dash. Okay, now I'll mark this B dash. B dash. What is B dash means? B dash means not B. You observe B dash. B dash means not B. See, other than this, remaining all part I'll mark. Please observe. Whatever I am marking now, what is that? What is that? That is B dash, not B, right? Okay, I'll try to mark with a different color. I think you can see this, right, with a different color. I'm marking, what I'm marking? I'm marking not B. Please observe, not B, right? So here, what I marked here, that is not B. Please observe carefully, please, right? So A dash is marked, B dash is also marked. Here A dash intersection B dash is there. That means the common part. What is the common part which is present in A dash as well as B dash? Please observe common part. Here in A dash, what part is there? In A dash, you can observe that this is A dash, right? This is A dash. In B dash, what is B dash? This other than B part, If you observe the common part, that means A dash intersection B dash. You know what is A dash, you know what is B dash. Then you will realize that whatever this space is there, this space is A dash intersection B dash. I hope you understand this. In case if you didn't understand, nothing to worry. Here, just delete this one. We know that A union B whole dash, this is same as A union B whole dash is same as A dash intersection B dash. So same diagram. Just what you drawn for A union B whole dash, same diagram you draw and you write here A union B whole dash is same as, we know that A dash intersection B dash. This is enough. Actually, what diagram you will get for this A union B whole dash, same diagram you will get for A dash intersection B dash. I hope you understand this. Now, see the third bit. What is the third bit? A intersection B whole dash. A intersection B whole dash. A intersection B. You observe this diagram. You know what is this part. This part is A intersection B. This we learn in intersection of sets definition. When intersection of sets definition is going on, at that time we learn that this is A intersection B. Here what is there? A intersection B whole dash. A intersection B whole dash means not A intersection B. Not A intersection B means which part? Look here. Here I am shading that part. Please observe. What I am marking now, that is not A intersection B. Other than A intersection B, whatever the part is there, whatever the part I am marking now, what is that? That is not A intersection B. A intersection B whole dash means what? A intersection B whole dash means not A intersection B. It can be understood easily. Look here. A intersection B whole dash means not A intersection B. Whatever the color part I shaded here, that part is what? That is not A intersection B. So here I'll draw like this. I'll take one small circle here, small square here, and I'll shade. What is this part? This part is nothing but A intersection B whole dash. We know in properties of a complement of a set, we know that A intersection B whole dash is same as A dash union B dash. Okay, you observe here A intersection B whole dash is same as A dash union B dash. So no need of separate diagram for this A dash union B dash. Simply we can draw the same diagram what you drawn here, right? So I'll copy this and I'll paste here. Okay, so what is this? We know that A intersection B whole dash is same as A dash union B dash. With this fifth question is completed. What they are asking in the fifth question? Draw the appropriate Venn diagram for each of the following. I hope you understand this. Okay. Now we'll move to next question, sixth question. This is little tricky question. Many students will confuse, but actually it is very easy. You observe what is U? U is set of all triangles in a plane. All triangles means equilateral triangle, scalene triangle, isosceles triangle, right angled isosceles triangle. All triangles in a plane is the universal set. Okay. What is A? A is set of all triangles with at least one angle different from 60 degrees. What I'll do first, I'll write what is set A. Okay. What is set A? What is set A? E is the set of all triangles. Is set of all triangles with at least one angle different from 60 degrees. At least one angle different from 60 degrees. Okay, this is set A. At least one angle different from 60 degrees. What they are asking, what is A dash? A dash means complement of this set. They are asking what is complement of this set. A dash means what? Not A. Suppose if I'll try to explain this set contains what type of triangles. Suppose if I take a triangle with 45 degrees, 45 degrees, 90 degrees. Is this triangle present in set A? A triangle with interior angles 45 degrees plus 45 degrees plus 90 degrees. It is there in set A? Yes or no? Yes. Because what they are saying, at least one angle is different from 60 degrees. Here all are different from 60 degrees. At least one angle is different from 60 degrees. For example, if I take a triangle like this with interior angle 60 degrees, 30 degrees, 90 degrees. Is this triangle lies in set A or not? At least one angle different from 60 degrees. You can observe here these two angles are different from 60 degrees. So A complement means what? A complement means not A. A complement means not A. What is the triangle which is not in set A? What is the triangle which is not in set A? If all angles of it, all interior angles of it triangle is like this. What happened in this? In this, all the interior angles of a triangle are 60 degrees. This is not in set A because set A contains a triangle in which at least one angle different from 60 degrees. But here all are same. Nothing, at least one angle different from 60 degrees they are saying. All are 60 degrees. So here what I can say here, set of all equilateral triangles. Set of all equilateral triangles is the complement of this set. Other than equilateral triangle, you take any triangle. Other than equilateral triangle, you take any triangle which contains at least one angle different from 60 degrees. Only equilateral triangle which contains all angles 60 degrees. So complement of set, this given set is set of all equilateral triangles. In this, all angles are equal to 60 degrees. That means whatever the triangle present in this set that is not in set A. A dash means not A, na? Right? I hope you understand. Just try to think it little bit. Okay. Now we'll move to 7th question. You observe what they are asking in the 7th question. Find the blanks to make each of the following a true statement. Okay. Right. See, to do this problem, while learning complement of a set, we learn some properties. In that properties, you need to know that empty set complement is universal set and universal set complement is empty set. We learn these formulas. You must know these formulas to do these problems. Okay. When it comes to first bit, what they are asking? A union A dash. What is A union A dash? Here, I'll try to explain this with the help of Venn diagram. Okay. A union A dash. I'll draw set A. You suppose that this is set A. Okay. Where is set A? You observe this is A. This is A. Correct. Where is A dash? A dash means this part. A dash means this part, not A. Correct. A union A dash means what? A union A means this first part. A dash means this second part. Second part means this full. When we do A union A dash, what you will get? 1 plus 2. 1 plus 2 means what? This full you will get. Correct. This is A union A dash. I hope you are understanding. A union A dash is what? A union A dash is the universal set. I hope you got the point. Right. Now we'll move to second bit. What is second bit? Pi dash intersection set A. You know that empty set complement is universal set. This is the formula, right? Universal set intersection A. Where is the universal set? This is the universal set, right? Where is A? A is here. You can observe that the set A is a subset of universal set. When A is subset of universal set, you know that A union universal set is universal set. A intersection universal set is a smaller set you will get. So when you do intersection, then you will get A only because all the elements present in A are present in universal set. I hope you understand this. So empty set complement intersection A is A. Very good. Now come to the third bit. What is the third bit? Third bit is A intersection A dash. Here this is set A, correct? This is set A. Where is A dash? This is A dash. Is there any common element in A and A dash? A is different, A dash is different. There is no element common in A and A dash. We can easily say that A intersection A dash is a null set. Now, last bit in this exercise. You observe here, universal set complement intersection A. We know this formula. Universal set complement is what? Universal set complement is empty set. Empty set intersection A. You observe while doing empty set is subset of A. Empty set is subset of A. Here, when we do the union of these two sets, you will get A. When you do the intersection of these two sets, we will get phi. So here, what is the answer for this? Answer is phi, right? I hope you understand this exercise. In this class, we will learn the properties between the sets, relation between the sets. This class is very, very important. We use these results very frequently in the coming classes. First, you try to understand this diagram. You observe in this, total two sets are there. This is set A, set B. And this rectangular box is considered as universal set. You observe here part 1. What is part 1? What about set A? What is set A? Set A is this part 1 plus part 2. Please try to understand. This is set A. What is set A? Part 1 plus part 2. What is set B? Set B is part 2 plus part 3. Okay. What is part 1? Part 1 means A but not B. Try to understand here. This part 1 is what? A but not B, which is written as A minus B. A minus B means all the elements present in A but not in B. Simply I can write it as only A. Okay. Now second part. Second part is what? Second part is A intersection B. What it is this A intersection B? The elements present in both A and B. Just to understand, I am writing like this. A intersection B means the elements present in both A and B. What is the third part? Third part is only B. Correct or not? B but not A. So third part is nothing but B minus A. B minus A is what? B minus A is only B. Okay. Now fourth part. You observe other than this 1, 2, 3. In this box, other than this 1, 2, 3 parts, this remaining part is known as fourth part. That fourth part is what? It is nothing but not A union B. Please try to understand. This 1 plus 2 plus 3 is what? See here, I'll write 1 plus 2 plus 3. All the parts together is nothing but A union B. Not A union B means in this box, other than 1, 2, 3, what part is there? That part is fourth part. So what is fourth part? Fourth part is not A union B. To understand the coming properties, you need to know these things first. Okay. So we'll start our properties. First property. You see this A minus B. A minus B means only A. A minus B can be written as A intersection B dash. A intersection B dash means what? A but not B. B dash means not B. A dash means not A. Try to understand. A and not B. A and not B is nothing but this part 1 only. Please try to understand what I am trying to say. A minus B can be written as A intersection B dash. Similarly, what you say about B minus A? B minus A means all the elements present in B but not in A. All the elements present in B but not in A. This can be written as B intersection A dash. What it means? B but not A. So this simply we can say it as it is nothing but only B. You observe this A minus B union B. A minus B means this part 1. Try to understand. A minus B means part 1. Union. What is set B? Here in this diagram, what is set B? Set B is part 2 plus part 3. Okay. When we do the union, what you will get? A minus B is part 1. Union. Union we are doing. Set B is 2, 3. When we do their union, what you will get? You will get 1 plus 2 plus 3. Correct or not? When we do their union, 1 plus 2 plus 3. What is 1 plus 2 plus 3? 1 plus 2 plus 3 is A union B. Please try to understand. A minus B union B is nothing but A union B. Fourth property. A minus B intersection B. A minus B. A minus B means this part 1. Okay. Part 1. Set B means 2 plus 3. Okay. A minus B is part 1. Set B is 2 plus 3. What is the common present in A minus B and B? Here you try to understand this. A minus B means part 1. Set B means part 2, part 3. Is there, this is first set, this is second set. Is there any part common in both? No. So these sets are disjoint. So when we do their intersection, what you will get? You will get empty set. So A minus B union set B is A union B. A minus B intersection B is empty set. You observe this. A minus B union B minus A. A minus B means which part? A minus B means part 1 plus B minus A. B minus A means part 3. A minus B union B minus A. Part 1 plus part 3, which can be written as A union B. A union B means what? 1 plus 2 plus 3 minus second part. What is second part? Second part is A intersection B. Please try to understand. A minus B union B minus A. A minus B is part 1 in this diagram. B minus A is part 3 in this diagram. A union B means 1 plus 2 plus 3 minus second part is nothing but A intersection B. If I remove this, I'll get same thing. So A union B is what? A union B is 1 plus 2 plus 3 minus A intersection B is second part. If both will get cancelled, part 1 plus part 3 only you will get. So what you came to know that A minus B union B minus A is nothing but A union B minus A intersection B. This is nothing but the symmetric difference between two sets, that is A delta B. See this n of A minus B. What is n of A minus B? Number of elements present in A minus B. See this n of A minus B. Number of elements present in this A minus B. A minus B means only A. So which can be written like this. Number of elements present in set A minus number of elements present in A intersection B. Please try to understand. N of A. Okay. You see here. N of A minus B. A minus B means which part here actually? This is the first part, right? N of A. N of A means number of elements present in first part plus second part minus N of A intersection B. N of A intersection B is second part. If both will get cancelled, you can see both is same. So N of A minus B can be written as N of A minus N of A intersection B. See this seventh property. N of A union B. We know that N of A union B is nothing but N of A plus N of B minus N of A intersection B. So many people, they don't know why we are using this formula. I just want to do why these two are equal or not. See, A union B. A union B means what? A union B is nothing but part 1 plus part 2 plus part 3. Correct? Okay. A. Number of elements present in set A. Which area is set A here? 1 plus 2. Okay. N of B. Number of elements present in set B. That means 2 plus 3. This is not exact proof. Just I am trying to explain this result by using Venn diagram. Minus N of A intersection B. A intersection B means second part. So if you plus 2 minus 2 will get cancelled. You observe this left hand side part is 1 plus 2 plus 3 and right hand side part also 1 plus 2 plus 3. So we can understand that N of A union B is nothing but N of A plus N of B minus N of A intersection B. You observe here, if A comma B are disjoint, when we say two sets are disjoint, if their intersection is null set, then we say that they are disjoint. So if you want to show this in Venn diagram, disjoint set means there is no common element in set A and set B. The sets will be like this. They won't be intersect, because if the sets are disjoint, their intersection is null set. There is no element common in A and B. See, if A comma B are disjoint, the sets will be like this. If A and B are disjoint, then what is the formula for N of A union B? We can write the formula like this. N of A plus N of B. Actually, N of A union B formula, N of A plus N of B minus N of A intersection B. As the sets are disjoint, A intersection B is null set. A intersection B is null set means 0 elements present in that set. So minus 0 I need to write. Instead of that, simply I'll write, if A comma B are disjoint, then N of A union B is N of A plus N of B. You observe this 19th synopsis, we learned the relation between the sets. By using Venn diagram, we can easily understand all these things. If you observe all these things, I consider for two sets A, B. Now, in 20th synopsis, we will learn the relation between the sets when three sets are given. 20th synopsis, if A comma B comma C are any three sets, then the relation between these sets. Please see this result, A minus B intersection C. See here intersection is there. A minus B intersection C is same as A minus B union. Please observe here union is there. A minus B union A minus C. This is the result you need to remember. I'll try to explain this result by using this Venn diagram. You see here what is A. You observe this diagram. This is A, okay, and this is B. This is set C. What is A? Which part is A here? The A part is 1, 4, 5, 7. That is A. It can be understood easily. What is A? 1, 4, 5, 7. This part is set A. Okay. What is B intersection C? B intersection C. This is set B. This is C. What is B intersection C? B intersection C is 7, 6. Correct? So, A minus B intersection means what? A minus B intersection C. What it mean? All the elements present in A but not in B intersection C. Correct? You observe this. 7 is there in A, 7 is there in B intersection C also. So we won't consider. What we will consider? We will consider the elements present in A only but not in B intersection C. So what you will get here? This is the zone 1, 4, 1, 4, 5. So here you observe 1, 4, 5. What is this part 1, 4, 5? 1, 4, 5 is A but not B intersection C. A minus B intersection C is the region 1, 4, 5. Now you observe here A minus B. Where is A minus B? A minus B means the elements present in A but not in B. Elements present in A but not in B. You observe here 1, 5. You observe 1, 5. 1, 5 present in A, they are not present in B. So A minus B zone is what here? A minus B is 1, 5. Okay. What about A minus C? A minus C means all the elements present in A but not in C. You observe here, this is C. What is A minus C? A minus C is 1, 4. Correct? Okay. Now you do the union of these two things. So what about union of these things? 1, okay. And all the things will come. We won't write 1 again. 1, 4, 5. You can observe here. This zone is 1, 4, 5 in this diagram and this zone is also 1, 4, 5. So from this we can easily understand that A minus B intersection C is same as A minus B union A minus C. You observe the second result A minus B union C. Here intersection is there, here union is there. A minus B union C is A minus B intersection. Here union is there, na? It changes to intersection. A minus B intersection A minus. So you need to remember these results. We use these results while solving the problems. A intersection B delta C is A intersection B delta. Delta means here symmetric difference between the sets. A intersection N of A union B union C. What is the formula for N of A union B union C? That is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. I will try to check this result by using this Venn diagram. So what is N of A union B union C? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right? Other than this 8. So up to 7. Okay. N of A. N of A. What is A here? A is 1 plus 4 plus 5 plus 7. Okay. N of B. What is B here? B. B is 4 plus 2 plus, you observe here, 4 plus 2 plus 7 plus 6 plus N of C. What is C? This is C. What is C here? 5 plus 7 plus 6 plus 3 minus of A intersection B. You see what is A intersection B? This zone 4, 7. What is that? That is A intersection B. 4 plus 7 minus B intersection C. B intersection C is what? 7 plus 6 minus C intersection A. C. This is set C. This is A. C intersection A is 5 plus 7. You can understand this easily from Venn diagram. Plus A intersection B intersection C. See this 7 is there now. That is the zone of A intersection B intersection C. Okay. Now you see here minus 4, here plus 4, here minus 7, here plus 7 will get cancelled. Here minus 7, here plus 7 will get cancelled. Here minus 6, here plus 6 will get cancelled. When we multiply with minus, here minus 5 plus 5 will get cancelled. Minus 7 plus 7 will get cancelled. What is remaining here? So you observe here left hand side part is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 Right hand side part is also 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So I am trying to explain this result with the help of Venn diagram. Number of elements in A delta B. How many elements will present in symmetric difference between two sets? So I'll try to prove this result. We know that A delta B. What is the formula for A delta B? A delta B can be written as A minus B union B minus A, correct? As these two sets are equal, number of elements in A delta B is same as number of elements in A minus B union B minus A. Okay. You observe A minus B, B minus A. A minus B means 1, 5. B minus A means 2, 6. They are disjoint. There is no common region for A minus B and B minus A. We already discussed earlier. A minus B and B minus A are disjoint. We know this formula. Just recently we learned N of A union B formula is N of A plus N of B if A and B are disjoint. So here what it can be written as? It can be written as N of A minus B plus N of B minus A. Okay, we can write like this. N of A minus B is nothing but N of A minus N of A intersection B plus N of B minus A is what? N of B minus N of A intersection B. Okay, so if we simplify this further, what you will get? N of A delta B, symmetric difference between sets, equal to N of A plus N of B. Here minus N of A intersection B minus N of A intersection B, that is 2 into N of A intersection B. So how many elements present in A delta B means you need to remember this formula. We use this result, number of elements present in A dash union B dash. Recently we learned that A intersection B whole dash, right? A intersection B whole dash means not A intersection B, not A intersection B. What is the formula for this? It is N of universal set minus N of A intersection B. It can be understood easily. So N of A dash union B dash formula, N of U minus N of A intersection B. So with this the synopsis part is completed. In next class onwards, we will start doing objective problems. Exercise number 1.6. Actually, this is very easy exercise. Complete exercise runs on one formula only. You can see in this exercise, total 8 problems are there. So first, let's see what is that formula. In theory part, we learned that N of A union B equal to N of A plus N of B minus N of A intersection B. Here, N of A means number of elements in set A. N of B means number of elements in set B. N of A intersection B means number of elements in A intersection B. N of A union B means number of elements in A union B. This complete exercise runs on this formula only. So we are going to use this formula very frequently. In theory part, I explained clearly why N of A union B is N of A plus N of B minus N of A intersection B. Okay, let's see the solution for the first question. You observe what is the given data. X and Y are two sets. Okay, N of X they given. That means number of elements in set X given. Number of elements in set Y also given. Number of elements in X union Y also given. They are asking number of elements in X intersection Y. Actually, this problem is very easy. You can observe the sets X comma Y are there. So, we know this formula N of X union Y. What is the formula N of X union Y? N of X plus N of Y minus N of X intersection Y. This is the formula. You observe in this formula total 4 things are there. 1, 2, 3, 4. In these 4 things, if you know any 3 things, we can find the 4th one. Here total 4 terms are there. In these 4 terms, if you know any 3 terms, you can find the 4th term very easily. You observe here 1, 2, 3 terms already given. To calculating 4th term is very easy. Now substitute these values in this equation. N of X union Y is what? 38. So N of X union Y is 38 equal to N of X. What is N of X? N of X is given as 17. Plus N of Y. N of Y is given as 23 minus N of X intersection Y. That is what we need to calculate. Okay, so I kept N of X intersection Y as it. Okay, now simplify this further. 38 equal to, look here, 23 plus 17. This is
23, 30, 40. 40 minus n of x intersection y. Okay. Now you take this minus n of x intersection y to the left side, then what you will get? This is plus n of x intersection y equal to 40 minus 38. 40 minus 38 is what? 40 minus 38 is 2. So n of x intersection y equal to 2. That's it. We got the answer for this problem. They are asking us to find n of x intersection y. We got that n of x intersection y equal to 2. I hope you understand this solution. Actually, this is very easy problem because all the data already given in the question. Now we'll move to second question. You observe here also, if x and y are two sets such that x union y has 18 elements, x has 8 elements, y has 15 elements, how many elements does x intersection y have? This problem is also similar to last problem, but the data given in a little different way. X union y has 18 elements they given. It means what I can write? I can write that n of x union y. N of x union y equal to 18. N of x union y equal to 18. And x has 8 elements. N of x has 8 elements, that means n of x is 8, and y has 15 elements, that means n of y equal to 15. And what they are asking, how many elements does x intersection y have? That means we need to calculate n of x intersection y. This is what we need to calculate. Okay, we know the formula n of x union y. What is n of x union y formula? That is n of x plus n of y minus n of x intersection y. N of x union y is what? N of x union. You observe here total 4 terms are there. They already given 3 terms here. So calculating the 4th term is very easy. Substitute these values in the formula. N of x union y is given as 18. Okay. You write 18 equal to n of x. N of x is 8. Okay. So 8 plus n of y. N of y is 15 plus 15 minus n of x intersection y we need to calculate. Okay. 8 plus 15. Look here. 8 plus 15 is 23. 23 minus n of x intersection y. So we got like this. So you take n of x intersection y to the left hand side. What you will get? N of x intersection y equal to 23 minus 18. So what you will get? N of x intersection y. 23 minus 18 is 5. So n of x intersection y is 5. I hope you understand this. Observe this third question. What they are asking. In a group of 400 people. In a group, 400 people are there. 250 can speak Hindi in that group. 200 can speak English in that group. How many people can speak both Hindi and English? This is the question. Here, we need to write some data first. It is compulsory. So, I'll write like this. Let number of people who speak Hindi. You observe here, I am taking that number of people who speak Hindi equal to n of h. So n of h means what in this question? Number of people who speak Hindi. In the question only they given that 250 can speak Hindi. That means they given that n of h equal to 250. Okay. And one more thing is there. 200 can speak English. So I'll write number of people who can speak English. You observe here, I written number of people who can speak English as n of e. I am considering, this is also let. I am considering these two steps, right? Let number of people who speak English equal to n of e. So from now onwards, n of e means number of people who speak English. They given that 200 speak English. That means n of e, they given it as 200. Okay. Further, if we observe the question, how many people can speak both Hindi and English? Hindi and English. That means what they are asking to calculate? They are asking us to calculate n of h intersection e, because they are asking number of people who can speak both Hindi and English. If they are asked number of people who can speak Hindi or English, in that case we will calculate n of h union e. But in this case,
Hindi and English, when and is there, intersection comes. This is what we need to calculate. And one more thing, you observe all these are from the group of 400 people. So here you need to understand that n of H union E equal to 400. N of H union E is 400. This is the important point. In a group of 400 people, in this group only 250 speak Hindi, 200 speak English. That means the number of people who speak Hindi or English, Hindi or English, 400 people. That means you need to understand that n of H union E is 400. Now you can see here 1, 2, 3. Three things we already know. We need to find the fourth one. As we discussed earlier, if we total 4 elements are there in that formula n of H union E, in that if we know any 3, calculating fourth one is very easy. So I'll write that formula n of H union E. What is the formula for n of H union E? That is n of H plus n of E minus n of H intersection E. Okay. N of H union E, you can observe it is 400. So n of H union E is 400 equal to n of H. What is n of H? That is 250. Okay, n of H is 250 plus n of E is 200 minus n of H intersection E is the one we need to calculate. Okay, this is 400 equal to 250 plus 200, that is 450. 450 minus n of H intersection E. Now you take this H intersection E to the left hand side part. So this minus n of H intersection E will become plus n of H intersection E. That equal to 450 minus 400. That equal to 50. So n of H intersection E is 50. So they are asking what n of H intersection E. So number of people who can speak both Hindi and English equal to 50. I hope you understand this solution. Now we'll move to next problem. You observe this question. If S and T are two sets such that S has 21 elements. Here clearly they are saying that S has 21 elements. So I can write this directly. N of S equal to 21. Okay. And T has 32 elements. That means n of T equal to 32. Next, S intersection T has 11 elements. S intersection T, n of S intersection T equal to 11 elements. And how many elements does S union T have? They are asking n of S union T is what? So we need to calculate n of S union T. Okay. So we know this formula, n of S union T formula. What is the formula for n of S union T? N of S plus n of T minus n of S intersection T. You can observe in this total 4 terms are there. If we know any 3 terms, we can calculate fourth one easily. You see 1, 2, 3. We know 3 terms. So substitute these formulas. N of S union T is the one we need to calculate. N of S union T we need to calculate. N of S is 21. Okay. N of S is 21. N of T is given as 32. N of S intersection T is given as 11. Okay. 21 plus 32. So what you will get here? 53. Right? 53 minus 11. 53 minus 11 is what? This is 42. So n of S union T has 42 elements. So S union T has 42 elements. What they are asking in the question, how many elements does S union T have? S union T have 42 elements. I hope you understand solution for this problem. Now we'll move to next problem. You see fifth question. X and Y are two sets. X and Y are two sets such that X has 40 elements. Here the questions are very simple. X has 40 elements. That means n of X is given as 40. Okay. And if you observe the question, X union Y has 60 elements. Okay. N of X union Y equal to 60. Okay. And X intersection Y has 10 elements. N of X intersection Y equal to 10 elements. Okay. What they are asking, how many elements does Y have? That means they are asking us to calculate n of Y.
n of y equal to what? They are asking us to calculate n of y. See, first I'll write the formula. What formula? N of x union y. What is the n of x union y formula? N of x plus n of y minus n of x intersection y. In this formula, if we know any three things, look here, 1, 2, 3. Calculating fourth one is very easy. Substitute all these values in this formula. N of x union y is what they given it as 60 equal to n of x, they given it as 40, n of y they given it, we need to calculate. So we'll write n of y only. N of x intersection y, n of x intersection y is given as 10. Okay, you look here, 40 minus 10 is 30. So what I'll write here, 60 equal to 30 plus n of y. As I need to calculate n of y, I'll take this 30 to the left hand side part. So what I'll get, 60 minus 30 equal to n of y. 60 minus 30 is 30. 30 equal to n of y. So what they are asking, how many elements does y have? How many elements does y have? We got n of y is 30. So number of elements in set y equal to 30. I hope you understand this. You observe the sixth question, what they are asking. In a group of 70 people, are there. 37 like coffee, 52 like tea, and each person likes at least one of two drinks. How many people like both coffee and tea? Before going to start this solution, we need to write two steps. Number of people who speaks coffee. Before going to start this solution, I need to write two steps. Number of people who like coffee. Number of people who like tea. Okay, so first let me write those steps. You observe what I written. Number of people who like coffee, I taken it as n of c. In this problem, n of c indicates number of people who like coffee. You observe the question, they given that 37 like coffee. That means n of c is 37. Okay, now number of people who like tea, I taken it as n of t. See here, 52 like tea. So I'll write 52. Okay, and this is important. At least one of two drinks. Each person likes at least one of two drinks. Each person likes at least one of two drinks means at least one of two drinks. That means they like coffee, or they like tea, or they like both. That means here important thing you need to understand, they given C union T. Each person likes at least one of two drinks means n of C union T. Each person in a group. In that group total how many persons are there? 70 persons are there. So n of C union T is 70. This is the data you need to understand after reading the question. Now what they are asking, how many people like both coffee and tea? So n of C intersection T equal to how many people like both coffee and tea. This is the question, right? You also observe here total three things they given. They are asking the fourth one. So I'll write the formula. N of C union T formula. What is the formula? N of C plus N of T minus N of C intersection T. N of C union T is 70 equal to N of C is 37 plus N of T is 52 minus N of C intersection T is the one we need to calculate. Okay, 37 plus 52, 89. Okay, 70 equal to 89 minus N of C intersection T. Now you take this minus N of C intersection T to the left side. Then what you will get? You will get that N of C intersection T equal to 89 minus 70. 89 minus 70 is 19. So number of people who like both tea and coffee equal to 19. I hope you understand this solution. Now we'll move to next question. You observe in a group 65 people are there. Okay, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? Okay, how many like tennis? So first let me write important step. What is that? Let number of people who like cricket, let number of people who like tennis. Number of people who like cricket is N of C. Number of people who speak tennis is N of T. That is what I considered.
In this problem, N of C means number of people who like cricket. N of T means number of people who like tennis. Okay. They given that in the question 40 like cricket. That means they given that N of C is 40. Okay. And they given 10 like both cricket and tennis. Okay. That means they given that N of C intersection T equal to 10. Okay. What is the question? How many like tennis only but not cricket? Okay. How many like tennis only but not cricket? How many like tennis? How many like tennis? So here you observe how many like tennis. First I will calculate. Next I will calculate how many like tennis only but not cricket. So first I want to calculate how many like tennis. Okay. So here number of people who like tennis is the question mark. This is what we need to calculate. Number of people who like tennis. This is what we need to calculate. Here if you observe the question 1, 2. Only 2 terms are given. Actually in N of C union T formula total 4 terms are there. If they give 3 terms then we can calculate the things easily. So here I'll try to explain this with the help of Venn diagram, and moreover here you need to know one thing. Here in the beginning they given in a group of 65 people. In a group of 65 people. In this 65 people only 40 like cricket, 10 like both, 10 some of them like tennis, something like that. So here you need to understand that N of C union T, N of C union T equal to 65. This is what you need to understand. In a group of 65 people, 40 like tennis, some people like 40 like cricket, some people like tennis, 10 like both cricket and tennis, something like that they given. This is the one you need to understand. They given that N of C union T. In this group only they are discussing. That's why N of C union T is 65. Okay. So now you can observe here. Now 3 things are there. 1, 2, 3. Now 3 things are there. We need to calculate the 4th one. So I'll just go with N of C union T formula only. N of C union T formula is what? N of C plus N of T minus N of C intersection T. Okay. N of C union T is what? N of C union T given as 65. N of C is given as 40. N of T is we need to calculate, minus N of C intersection T is given as 10. Okay. Now look here. 40 minus 10, that is 30. Okay. 65 equal to 30 plus N of T. Now you take this 30 to the left hand side part. What you will get? 65 minus 30 equal to N of T. 65 minus 30 is what? This is 35. So number of people who like tennis is 35. Now I'll try to draw a Venn diagram here so that you can understand it easily. If you observe the question, how many like tennis? I got that number of people who like tennis is 35. Now what is the question? How many like tennis only but not cricket? How many like tennis only but not cricket? You look here, these are the people, this circle. In this circle who are the people are there? They like tennis. They like tennis. So in this zone, whoever the people are there, they like both tennis and cricket. Okay. Now look here, in this zone, whoever the people are there in this zone, they like tennis only but not cricket. Try to understand. Here whatever the red color zone is there, these people like tennis only but not cricket. That is what they are asking. How many people like tennis only but not cricket? This is what we need to calculate. Here from the given data only we know that N of C intersection T is 10. We got that this number. This is 10. They given in the question. They given it, right? And just now we calculated N of T is 35. That means this full circle is 35. They given that this full circle is 35. Okay. So to get only this part, how I know this full circle is 35. From 35, if I remove this 10, I'll get T only but not cricket. I hope you are understanding. So I'll write that step. Number of people who like tennis only equal to N of T minus N of T intersection C. I hope you understand. To get the number of people who like tennis only but not cricket, to get this number, as I know this N of T as 35, from 35 if I remove this 10, I'll get the answer 35. My N of T is what? N of T is 35. 35 minus n of t intersection c is 10. 35 minus 10 is 25. So n of t only is 25. I hope you understand this problem. In a committee, 50 people speak French, 20 speak Spanish, 10 speak both Spanish and French. How many speak at least one of these two languages? First, I'll write some data from the given question. Okay, you observe first I considered let number of people who speak in French. The number of people who speak French I taken as n of f. In this problem, n of f means number of people who speak French. You observe the question, they given that 50 people speak French. So I'll write n of f is 50. Now, number of people who speak Spanish. 20 speak Spanish. So n of s is 20. Okay, now look here. 10 speak both Spanish and French. So n of Spanish and French, S intersection F. S intersection F equal to what? 10 speak both. They given that 10 speak both Spanish and French. Okay. What they are asking to calculate? They are asking us to calculate how many speak at least one of these two languages. How many speak at least one of these two languages? Whenever they say at least one of two, that means they are asking us to calculate n of S union F. This is what they are asking. S union F means at least one of S and F. Okay, right. So here I need to calculate n of S union F. That equal to, what is the formula? N of S plus n of F minus n of S intersection F. N of S union F is what? This is what we need to calculate. N of S is what? N of S is 20. N of F is what? N of F is 50. Minus N of S intersection F is 10. So 50 plus 20, 70. 70 minus 10 is 60. N of S union F equal to 60. So the number of people who speak at least one of these two languages is 60. I hope you understand this exercise. In next class, we will do all the solutions of miscellaneous exercise. Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now, we completed 6 exercises in set chapter. Now, we are going to start miscellaneous exercise. Compared to exercise problems, compared to first 6 exercise problems, miscellaneous exercise problems are little difficult. Especially first 10 problems, you may feel difficulty. So, what my suggestion is, first you make sure you are good in first 6 exercises or not. Once you are good in first 6 exercises, then you are ready to learn miscellaneous exercise problem. In case if you are not good in third exercise or fourth exercise of sets chapter, then definitely you will feel very confusion part in miscellaneous exercise problem. So what I am trying to say, before starting miscellaneous exercise, please make sure that you are good in all the definitions and all the formulas and you practiced all exercise problems thoroughly. Once you are perfect in all exercise problems, then it means that you are ready to do miscellaneous exercise problem. I tried my best to simplify complicated things in easy way. Without much delay, let's begin the class. Miscellaneous exercise on chapter 1. In this miscellaneous exercise, total 16 problems are there. These are little difficult problems compared to exercise problems. In sets chapter, total 6 exercises will end. Up to exercise number 1.6 will end. If you are good in first 6 exercises, then you can do this miscellaneous exercise problems very easily. Okay. However, let's see the solution for first question. You observe what is the first question. Decide among the following sets. They given some sets here. A, B, C, D. Among the following sets, which sets are subsets of one and another? If you know the definition of subset, then you can do this problem very easily. What is the definition of subset? When we say two sets are subset to each other, when we say A is subset of B, if all the elements present in set A are present in set B, then set A is called subset of B. For example,
If I take A equal to 1, 2, and if I take B equal to 1, 2, 3, 4, 5. Now you observe all the elements present in set A are present in set B. You see 1, 2 are present in A, 1, 2 are present in B also. All the elements present in set A are present in set B. So in this example, A is subset of B. At the same time, is B is subset of A? When we say B is subset of A, all the elements present in B are present in A, then we call B is subset of A. But actually, in this set B, 3 is there. 3 is not in set A. So, in this example, B is not a subset of A. In this example, A is a subset of B, but B is not a subset of A. Okay, if you observe here sets, first set is given in set builder form. What I'll do, I'll write this set in roster form. Roster form means what? All the elements are listed and separated by commas within the brackets. If I write this set in roster form, I can easily compare this set is subset to each other or not. Okay, so what I'll do here, first I'll write set A in roster form. What is set A? They given like that. Like this. Set A is X as that X is a real number and satisfying this equation. Satisfying this equation. Okay. So what I'll do here, what is the equation they given? X square minus 8x plus 12 equal to 0 they given. I'll split the middle term. Split the middle term. Minus 8x is there. Na? That can be written as minus 2x minus 6x plus 12 equal to 0. Now, in these first two terms, you take x common, then what you will get? You will get x into x minus 2 minus, in these two terms, you take minus 6 common. Minus 6 common, then what you will get? You will get x minus 2 equal to 0. Now, in this term, x minus 2 is there. In this term also, x minus 2 is there. You take x minus 2 common, then what you will get? X minus 2 into x minus 6 equal to 0. Okay. Now, what I can write here? I can write that x equal to 2 or x equal to 6, right? Product of two terms is 0 means either x minus 2 equal to 0 or x minus 6 equal to 0. That means x equal to 2 or x equal to 6. So, these are the real numbers satisfying this equation. So, what is set A? Set A in roster form. Set A is 2, 6. Now, I'll write other given sets also. What is set B? Set B is 2, 4, 6. What is set C? Set C is 2, 4, 6, 8 and so on. Set D is given as singleton set 6. These are the 4 sets they given in the question. Now, what you need to check? Which sets are subsets of one and another? I need to check. How I'll check? First, I'll take set A. I'll check that A is subset of B or not. I'll check that A is subset of C or not. I'll check that A is subset of D or not. Later, same procedure I'll follow for set B also. First, let's take set A and you check that A is subset of B or not. I'm taking set A and I'm checking that A is subset of B or not. You check, is A is subset of B? All the elements present in A are present in B? Yes. In this set A, 2, 6 are there. In this set B also 2, 6 are there. So here clearly A is subset of B. Okay, this is the one point. Now you observe set A and set C. A is subset of C. All the elements present in A are present in C. You observe here 2, 6 present in set A, 2, 6 present in set C also. So what I can write here? I can write that A is subset of C. Okay. Now, is A is subset of D? Is A is subset of D? All the elements present in A are present in D. Actually, 2 is present in set A, but 2 is not in set D. So, A is not a subset of D. I am not writing here A is not a subset of D because they are asking which set is subset to one another, like that they asked. Okay. With set A I verified with all the sets. Now I'll take set B. Now I'll check that B is subset of A or not. B is subset of C or not. B is subset of D or not. Okay. Now take set B. Now is B is subset of A? All the elements present in B are present in A. Actually in set B element 4 is there, but 4 is not in set A.
So here clearly B is not a subset of A. Okay. Now you check that is B is subset of C. All the elements present in B are present in C. Yes, 2, 4, 6 are there in set C. So clearly here B is a subset of set C. B is a subset of set C. Okay. Now check that is B is a subset of set D. No. Actually in set B the element 2 is there, but the 2 is not in set D. So here what I can say? I can say that B is not a subset of D. B is not a subset of D. But I don't want to write this not a subset. Which one is subset to one another? That is the question. Okay, I taken set B and I checked with all other sets. Now I'll take set C. Now you check that set C is a subset of A. All the elements present in C are present in A. No, actually 4 is present in C, but 4 is not in A. So C is not subset of A. Now you check that is C is subset of set B. Actually 8 is there in set C, which is not in set B. Here C is not a subset of B. Now you check that set C is a subset of D. No, actually 2 is there in set C, that is not in set D. So C is not a subset of D. Now here interesting factor. Now we will take set D. Okay, set D. Now what I need to check? I need to check D is subset of A or not. D is subset of B or not. D is subset of C or not. Okay, you check here. D is subset of A. Is D is subset of A? All the elements present in set D are present in A. Yes, set D contains 6. 6 is there in set A. So what I can write here? I can write that D is subset of A. Now D is subset of B. Yes, in set D only one element is there, 6. All the elements present in D are present in B. All the elements present in D are present in B. So what I can say here? I can say that D is subset of B. Now is D is subset of C? All the elements present in D are present in C. Yes, the 6 is present in D, 6 is present in C. So here D is subset of C. So what they are asking in the question, which sets are subsets of one another? Here you can see A is subset of B, A is subset of C, B is subset of C, D is subset of A, D is subset of B, D is subset of C. So whatever the given 4 sets are there, in that these sets are subsets of one another. I hope you understand this first problem. Now we'll move to next question. You observe the second question, what they are asking. In each of the following, they given total 6 bits here. In each of the following, determine whether the statement is true or false. You need to decide the statement is true or false. If it is true, then prove it. Okay. If it is false, give an example why it is false. Okay. So first, let me take the first bit in this and we'll try to understand whether the statement is true or false. The point is we need to identify whether this is true or false. If it is true, if this is true, we need to prove it. If it is false, we need to give an example, like counter example. Here, this is little difficult to understand for students. But actually, what they given, they declared one statement here. Whenever X is there in set A and A belongs to set B, then X is also belongs to B. They declared one sentence here. Whenever these two things holds good, if X belongs to A and A belongs to B, then X belongs to B, they are saying. So what I'll do, I'll check this with random example. I'll take set A equal to 1, 2, okay? And set B, I'll consider in such a way that this set A is present in set B. Actually, this problem you can understand in exercise number 1.3, third problem is there. In sets exercise number 1.3, third problem is there. If you understand that problem, this can be understood very easily. Okay. Here I am considering set B in such a way that A is belongs to B. Set B I'll write like this. 1, 2, 3. I written like this. Now you observe this. If I take X in set A belongs to B, right? Then X belongs to B they given. Here you observe I considered set A. And you observe set B, I consider in such a way that this is set A, correct? This is set A. A is in B. This set A is in B. Okay, now I consider a statement by using these 2 points. Now I'll take one element x in A. I'll take one element x in A. Now I'll check that element x is there in B or not. Before that, you need to know how many elements present in set B. You know that all the elements of a set in roster method are listed and separated by commas. In set B, total 2 elements are there. This is one element, this is another element. Total 2 elements are there. Now my question is, in this set 1 is there? In set B, 1 is there? No, 1 is not there. 1 does not belongs to set B. If you know that knowledge, then you can understand this problem. Otherwise, you cannot understand. 2 is there in set B? No, 2 does not belongs to set B. 3 is there in set B? Yes. 3 is present in set B. Here, how many elements are there in set B? 2 elements are there. This is A, okay, set A, okay, and this is element 3. Only these 2 elements present in set B. Now, here you observe, you take one element in set A. Suppose 1 is there in set A. 1 is there in set A. I taken x belongs to A, they are saying now. So, I taken 1 from set A. Now, is this 1 is there in set B? You check here, 1 is there in set B. 1 does not belongs to set B. So what happened here? They declared this statement. But what happening? As per this, if x belongs to A and A belongs to B, then x belongs to B, they are saying. Here I am checking now. 1 belongs to B and this A is belongs to B, but 1 is not in set B. 1 is not in set B. Observe, in set B, 2 elements are there, this and this. 1 is not there in set B. So clearly we can say that this statement is false. I hope you understand. If you have good knowledge of subset and what elements present in the set, you exercise number 1.3 third problem you practice. If you are good in that problem, then you can understand these problems. In case if you confuse, please go back and try to observe from the beginning onwards what I am saying in this solution. Definitely you will get the solution. You can understand it. Okay. Now we will move to second bit. You observe this second bit. What they given? A is subset of B. B belongs to C. Then A belongs to C. They given one statement here. 3 sets are there. A, B, C, 3 sets are there. Okay. I'll take like this example, counter example. I am trying to check with the example. A is 1, 2. Okay. B is what? A is subset of B they given. I'll take like this. B as 1, 2, 3. Okay. A is subset of B. I consider B in such a way that all the elements present in A are present in B. Okay. And they are saying that B belongs to C. I'll consider set C in such a way that set B is there in this. What I'll write here for set B, like this is set B. You observe here, in set C, how many elements are there? In set C, 2 elements are there. One is the element 4. Another one is set B. B belongs to C. Please try to understand. B belongs to C. The same set C you can write like this. C is 4, comma. What is this set? This set is nothing but B. I can write like this. You can observe here. B belongs to set C. B belongs to set C. A is subset of B and B belongs to C. I considered 3 sets satisfying these 2 conditions. Now I need to check that is A belongs to C or not. A belongs to C or not. This A is there in C. Clearly the set A is not in C. When we say A is in set C, suppose set C is like this. Suppose I am saying, suppose set C is like this. 4, comma, B, comma, 1, comma, 2. If it is like this, then we say that A is in set C. But you see here, I got C like this. I taken one example like this. They are saying this is true for any 3 sets ABC. They are saying that this is true for any 3 sets ABC. To say it is false, one example is enough. Here I can create an example with satisfying this condition. I can create an example with satisfying this condition. But that is not, statement means what? This statement means what? It is true for any 3 sets. To say this statement is false, it is enough to give one example. You are saying one statement, man. To contradict it, I can give one example, right? You may give so many examples that your statement is true. but I can contradict you by giving one counter example. This example, because of this example, your statement is false. Try to understand. Here they passed one statement here. This statement may be true for some examples, but this is not true for all the sets ABC. That is what I am trying to say. Here, if I take ABC sets like this, with satisfying these two conditions, you check that is A is there in set C? A is there in set C? No, A is not in set C. So what is this? This is false. I hope you understand. You observe this third bit. A is subset of B, B is subset of C, then A is subset of C. Actually, this statement is true. This statement is true. When I am saying this statement is true, you cannot give an example such that this is false. So, in the question only they are saying that when the statement is true, you need to prove it. Okay, here I need to prove it. For that, first what I'll do, I'll take A is subset of B, A is subset of B, and B is subset of C. Now what I need to prove? I need to prove that A is subset of C. How to prove A is subset of C? If all the elements present in set A are present in set C, then I can say that A is subset of C. What I'll do to prove this, I'll take randomly one element X in set A. I don't know what is X, but I'll suppose that X is there in set A. In the process, by using these two things, in the process, I'll prove that X is there in set C also. It indicates that all the elements present in set A are present in set C. So I can say that A is subset of C. Okay, so here what I'll do, I need to prove A is subset of C na? So what I'll do, let X in set A. You consider X in set A. From this, I can say that X belongs to B also. How can you say like that? Because I have this one. A is subset of B. A is subset of B means what? All the elements present in set A are present in set B. If I take X in set A as A is subset of B, definitely the element X present in B. Okay. Now you got X is in B. As I know B is subset of C, I can easily say that X belongs to C. Since why? B is subset of C. B is subset of C means what? All the elements present in B are present in C. Okay. So here X is there in B means X definitely belongs to C. So what happened here? If I take X in set A, definitely X belongs to set C. So what is the conclusion here? Therefore, if X belongs to A implies, therefore what I proved, X belongs to A implies X belongs to C. So from this we can say that all the elements present in A are present in C. Therefore, I can say that A is subset of C. Now, this is true or false? Yes, this statement is true. I'll write here, this statement is true. And to understand this more clearly, I can give an example, but I cannot give this problem in example method, as I need to prove like this only. A is subset of B, they are saying na. I'll take set A is like this, 1, 2. A is subset of B, they given. Look here, A is subset of B, they given. I'll construct B in such a way that A is subset of B. And you see here, B is subset of C, they given. I'll take C in such a way that B is subset of C. All the elements present in B are present in C. Now you look here, A is subset of B. All the elements present in A are present in B. And you look here, B is subset of C. All the elements present in B are present in C. Now you look that A is subset of C or not. Obviously. But with this example, I cannot say that this is true. When it is true, you need to prove it. When it is false, then give the counter example. I hope you understand. You observe this fourth bit. When A is not a subset of B and B is not a subset of C, when these two things are happening, then they are saying that A is not a subset of C. They declared one sentence here. When these two are happening, then this is happening. So they declared here. When I need to give one example if it is false. If it is false, one example is enough, right? If it is true, I need to prove it. Okay, I'll take an example to say this is false. Okay, I'll take set A like this, 1, 2. Okay, you observe here, A is not a subset of B. I'll take set B like this. Set B is 3, 4. You can observe here, A is not a subset of B. Okay,
and they given that B is not a subset of C. Okay, B is not a subset of C. Okay, I'll take C like this. C is a 1, 2 and 3. I'll take like this. You can observe, is B is subset of C or not a subset of C? B is not a subset of C. All the elements present in B are present in C. You can see here 4 is present in B but 4 is not in C. So I considered 3 sets ABC in such a way that A is not a subset of B and B is not a subset of C. I hope you are understanding. A is not a subset of B and B is not a subset of C. Now in this they are saying that A is not a subset of C. But you see here A is subset of C. All the elements present in A are present in C. I hope you are understanding. What it concludes, what they given one statement, I given one example that this is not true. That means this is false. In the question only they are saying that if it is false, give one example. In this example, you can observe that A is not a subset of B. Okay, and B is not a subset of C. Then they given A is subset of C, but in this example A is subset of C. In this example, that's why the given statement is false. Now we'll move to fifth bit. You observe this fifth bit. X belongs to A and A is not a subset of B, then X belongs to B. They given like this. Okay, so I need to prove that this statement is I need to check that this statement is true or false. I'll go with some counter example. I'll take set A as 1, 2. Randomly I am picking these things. A is not a subset of B, they given. I'll take set B is like this 3, 4. I'll take like this. You observe I taken two sets in such a way that it satisfies these conditions. Here X belongs to A means one element is there. A is not a subset of B. Main thing is this one. A is not a subset of B. You can observe A is not a subset of B. If X is there in A and these two conditions holds good, then X belongs to B, they are saying. You take one element from set A. Suppose I'll take 1. 1 is there in set A. And you can see here A is not a subset of B. That means this condition holds good. Now is 1 is there in B? You check it. Check it. 1 is there. 1 is there in B as A is not a subset of B. Since A is not a subset of B, 1 is there in set B. 1 is not there in set B. What happened here? X does not belongs to B we got. As per this, if I try to take an example, I found one example such that 1 does not belongs to B. Right? This is false. I am saying once again, you can create an example which satisfying this condition. You can create one example, but this is the statement. They are saying that this is true for any sets ABC which satisfying this condition. No. See, very simple thing, man. If a student, here I'll tell you one example, please have patience and try to understand. For a student, there are 4 subjects are there: maths, physics, chemistry, biology. If student got 100 marks in maths, can you decide that he passed all other exams because in maths 100 he got? No. Suppose in physics he got 90. Can we declare that he passed all the exams? Can you declare that he passed all the exams? No, you cannot declare. Suppose in chemistry he got 80. Can you declare that he passed all the exams? We cannot declare without knowing biology marks. I hope you are understanding. He may absent for the biology exam even though he scored well. Maybe he may get 10 marks here. What I am trying to say, when it is true, without checking all the subjects, you cannot decide whether the statement is true or not. But at the same time, in maths, that fellow got 0. In maths, if that person got 0, that means we can declare that he failed in that particular exam because he need to pass all the subjects to complete the course. I hope I given some clear explanation here. What I am trying to say, when it is false, one small counter example is enough. When it is true, you cannot prove it with an example. Okay? So right. So this statement is false. Now we'll move to 6th bit. You observe this 6th bit. A is subset of B. X does not belongs to B. Then X does not belongs to A. Actually, this statement is true. When it is true, proving this is little complicated. I cannot give an example. I need to prove this. Okay. To prove this, what I'll do first, let A is subset of B and X does not belongs to B. I am considering these two things. A is subset of B and X does not belongs to B. Now I need to prove that X does not belongs to B also. How to prove this? Okay, how to prove this? Actually, this is a clear statement. How I can explain this to you? Here to explain this, I am giving an example. I am not proving this. This is an example to explain this. A is subset of B, they are saying. Na? So I'll take an example like this. Set A is 1, 2. Set B is 1, 2, 3. You can observe here A is subset of B. All the elements present in A are present in set. If one element does not belongs to B, it does not belongs to A, 100% guarantee. You take one element which is not in set B. Suppose 4. 4 is not in set B. 100% 4 is not in set A also. 100%. This is a clear statement. This is a clear statement. When these two things are happening, then we can say that clearly X does not belongs to B. That much only I can say. To make you understand this, I can give one example here. Proof means this is the proof. I hope you are understanding. This is the proof. This is a clear statement. To understand it is clear or not, you take one example and you check it. You take one element which is not in B. You take 5. 5 is not in set B. Now you observe that 5 is not in set A also. Hence the given statement is true. This second question is little difficult to understand, but I tried to give my best explanation. In case if you didn't understand any particular bit, you go there and try to listen that again and again. Definitely I tried to give a complete explanation for that. Still, in case if you have any doubt, you please give comment in chat section so that I'll answer to your question. You observe this third question. A, B, C, B, 3 sets such that A union B equal to A union C and A intersection B equal to A intersection C. Then show that B equal to C. A, B, C, B 3 sets such that A union B equal to A union C, A intersection B equal to A intersection C. Then show that B equal to C. Here we need to prove that B equal to C by using these two conditions. Okay, here B equal to C means two sets are equal. When we say two sets are equal, suppose the set B is a subset of C and the set C is subset of B. In this case, both the cases holds good. Then only we say that the sets B and C are equal. I hope you understand. So here to prove the sets, these two sets are equal, B equal to C. First, I need to prove that B is subset of C. Next, I need to prove that C is subset of B. Okay, so let's start the solution. Before starting the solution, first you write the given data. What they given? They given that A union B equal to A union C and they given, you try to understand, that means both must holds good, then only this works. A intersection B equal to A intersection C. We need to prove that B equal to C. Okay, I said now to prove this, I'll do this in two cases. First, I'll prove that B is subset of C. When B is subset of C and C is also subset of B, then I can say that these two sets are equal. How to prove that B is subset of C? Very simple. I'll take one random element X in set B. I'll take an element X in set B. By using these two datas, I'll prove that X is there in set C also. So if all the elements present in set B are present in set C, then I can say that B is subset of C. So what is the procedure to prove that B is a subset of C? I'll take X belongs to B. Okay, so we started like this. Let X belongs to set B. Okay, if X belongs to set B, can you say that X belongs to A union B? If X belongs to B, then definitely X belongs to A union B. This we learn in operations on sets. While learning the definition of union of sets, we learn this. If X belongs to B, then definitely X belongs to A union B. Okay, okay. X belongs to A union B. If X belongs to B, then X belongs to A union B. Okay. And we know that they given here A union B is same as A union C. So what I can write here, X belongs to A union C, I can write, since they given that A union B is same as A A union C. Okay. X belongs to A union C. X belongs to A union C means what? X is in set A or X is in set C. Here two chances are there. X is there in set A or X is there in set C, or X may present in both also. Basic thing is X belongs to A or X belongs to C. When X belongs to A intersection C, X may be in set A, X may be in set C. Listen carefully. If X is in set C, this problem is over. I am trying to prove B is subset of C now. If X belongs to B, when I got that X belongs to C, I can say that B is subset of C. If X belongs to C, directly I can say that B is subset of C, because for X belongs to B, X belongs to C. For X belongs to B implies X belongs to C. Then I can say that B is subset of C. Okay. So here only the problem comes when X belongs to A. Okay. Suppose when X is in A, when X belongs to set A, what happens? Here, as I started with X belongs to B, if X is there in set A, then what I can say? I can say that X belongs to A intersection B. Since we started with X belongs to B. Now I am saying that when X belongs to A, X belongs to B. That means when X is there in set A as well as there in set B, then definitely I can say that X belongs to A intersection B. Okay. X belongs to A intersection B. X belongs to A intersection B. You can look here in the given data, they given that A intersection B is same as A intersection C. X belongs to A intersection B is same as A intersection C. So in place of A intersection B, I can write A intersection C. When X belongs to A intersection C, then what I can say? I can say that X belongs to A, and intersection means X will be there in A as well as in C also. X belongs to C. Because it is intersection, A intersection C means X is there in A intersection C. It means that X must present in A, X must present in C also. I hope you are understanding. So I started with X belongs to B, I ended with X belongs to C. So what is the conclusion I will give here? Therefore, X belongs to B implies X belongs to C. From this, what I can conclude? I can conclude that B is subset of C. I hope you understand this. I proved that. Similarly, if I can prove that C is subset of B, then this problem will be over. Actual thing is what? I am trying to prove that the set B equal to C. I am trying to prove that B equal to C. How to prove? First, I will prove that B is subset of C. Next, I will prove that C is subset of B. Now this one is over. Now I need to prove that C is subset of B. Okay. I need to prove that the set C is a subset of B. How to prove this? Very simple. First, I'll take one element in set C. X belongs to C, I'll take. In the process, I'll simplify and I'll get that X belongs to B. If I can prove this, then I can say that C is subset of B. Okay. Start with the X belongs to B. Let X belongs to C. Start with X belongs to C. I take an X in set C. If X belongs to C, then definitely X belongs to A union C. Clear? If X belongs to C, then definitely X belongs to A union C. This is clear from operations on sets. If you know how to calculate union of sets, then you can easily understand, right? Okay, X belongs to A union C. And A union C is same as A union B. That is the given data. X belongs to, look here, A union C is same as A union B. In place of A union C, I can write A union B. Okay. In place of A union C, I can write A union B, since A union C is same as A union B. Okay. Right. So now X belongs to A union B means what? X belongs to A or X belongs to B. Correct? A union B means X may be in set A or X may be in set B. Here you observe, if X is in set B, this problem is over, because I started with X belongs to C and X belongs to B. Then I can easily say that C is subset of B. Only the problem arises when X belongs to A. Okay. Look here. When X belongs to A. When X belongs to A. when x belongs to A, as I started with x belongs to C, I can easily write that x belongs to A intersection C. X belongs to A as well as x belongs to C. X belongs to A intersection C. So what I can say here, x belongs to A intersection C, and you see A intersection C is same as what they given in the data. A intersection C is same as A intersection B. Look here, A intersection C is same as A intersection B. In place of A intersection C, what I can write? I can write A intersection B, because they given A intersection C is same as A intersection B. Okay, when x is there in A intersection B, x is there in A as well as x is there in B also. From this I can easily say that x belongs to B. Now you observe, I started with x belongs to C, I got that x belongs to B. So I'll write here, therefore, if x belongs to C implies x belongs to B, then what is the conclusion? Then the conclusion is C is subset of B. Here we proved that B is subset of C, you take it as 1. And here we proved that C is subset of B, you take it as 2. From 1 and 2, from 1 and 2, from 1 and 2. What we can say, when B is subset of B and C is subset of B, then I can say that the sets B and C are equal. So here this condition holds good only when this full, look here, this result holds good when A union B equal to A union C as well as A intersection B equal to A intersection C. When both are holds good, then only B equal to C. I hope you understand this third question. Please observe this question number 4. Show that following 4 conditions are equivalent. Here 4 things are given, they are all equivalent. That means when A is subset of B, A minus B equal to empty set. When A is subset of B, A union B equal to B. When A is subset of B, A intersection B equal to A. Actually all these are if and only if condition. When A minus B equal to pi, then A is subset of B. When A minus B equal to pi, A union B equal to B. When A minus B is phi, A intersection B equal to A. Like that, all these are if and only if conditions. Here I don't want to confuse you by saying that x belongs to A implies x belongs to B and x belongs to A but x not belongs to B, like that. I just want to do it as simple as possible. I'll explain this with the help of Venn diagram. Okay. So here A, B, 2 sets are there. So I'll take 2 sets A and B. Okay. This is one set. Okay. And I need one more smaller set. Here the basic point is these are all formulas. I'll say simply like this. When A is subset of B, then A minus B is null set. When A is subset of B, A union B is B. When A is subset of B, A intersection B is A. Main thing of this question is you want to learn this point. When A is subset of B, all these things holds good. When all these things holds good, A is subset of B. Here you observe I taken 2 sets. Here smaller set is set A, bigger set is set B. Because they are saying that A is subset of B. What it means? Whatever the area present in A, whatever the elements present in A, that present in set B also, because B is the bigger set, all the elements of set A are present in set B. This diagram itself indicates that here this set A is subset of B. Okay, so I taken A is subset of B. Now you observe second bit. Here what happened here, first bit is A is subset of B. Okay, when A is subset of B, what I got here? You look here, A minus B. A minus B means what? All the elements present in A but not in B. A minus B means what? All the elements present in A but not in B. You observe when A is a subset of B, is there any element present in set A which is not in B? Is there any element present in set A which is not in B? When A is subset of A, all the elements of set A are present in set B. I hope you are understanding. Then actually what is A minus B? All the elements present in A but not in B. Okay. So is there any element in set A which is not in B? No. All the elements of set A are in B as A is subset of B. From this we can say that A minus B equal to null set. I hope you understand this. And when A is subset of B, A union B is B only.
It is simple. When we do the union of two sets, look here, A is subset of B. A union B means what? A union B means all the elements present in A are present in B are present in both. Okay. Here all the elements which are present in A are present in B, right? So here what I am trying to say, if X is there in A, then definitely X is there in B. When we do union, look here, I just want to say this point. When A is subset of B, A union B is B. When we do the union, you will get bigger set. When you do the intersection, you will get smaller set. When A is subset of B, B is the bigger set, A is the smaller set. So here this is very, very important. When A is subset of B, what you can say? A union B equal to B. How to prove this? With the help of Venn diagram, I'll write here clearly. Second point, I'll write like this. When A is subset of B, this implies clearly, I'll write from Venn diagram, clearly from Venn diagram, what I can say that A union B is B. This is very simple, right? In the same way, when A is subset of B, A intersection B is what? Look here, please. See here, when A is subset of B, then what is A intersection B? When A is subset of B, look here, A intersection B means the elements which are present in A as well as in both. As A is subset of B, all the elements present in A are present in B also. When we do intersection, this is the zone which is present in A as well as present in B. So A intersection B is A. It's a simple thing, right? So here I just try to prove this with the help of Venn diagram. Every time not necessary taking that X belongs to taking like this, X belongs to A implies X belongs to B, A is subset of, not necessary. Basic idea of this is very simple. Whenever you know A union B equal to B, we can directly say that A is subset of B. Whenever you know A intersection B equal to A, you can say that A is subset of B. When you know A is subset of B, you can write that A minus B equal to empty set. When you know A is subset of B, you can write that A union B equal to B, A intersection B equal to A. These are all equivalent conditions. So with that, from the Venn diagram, we can observe it clearly. In exam also you write like this. From the Venn diagram, it can be observed clearly. No need to prove unnecessary complications. No need to do this problem. Don't make it complicated. Keep it simple, right? This is the solution for this problem. Observe this question. Show that if A is subset of B, that means when A is subset of B, we need to prove that C minus B is subset of C minus A. So actually, you need to prove this result. How to prove one set is subset of another set? Actually, what I'll do, I'll take a random element in this set. I'll take X in C minus B. By using this information, I'll prove that X belongs to C minus A. So whenever X belongs to C minus B implies X belongs to C minus A, we will get, at that time I can say that C minus B is subset of C minus A. Okay. First thing, I'll take let X belongs to C minus B. Okay. X belongs to C minus B. What I can say from this, X belongs to C minus B means, A minus B means what? All the elements present in A but not in B, correct? A minus B means what? All the elements present in A but not in B. Here X belongs to C minus B means what? It means that X belongs to C but, or else I'll write and, X belongs to C and X does not belongs to B. Try to understand. Here I taken X belongs to C minus B. From that I got that X belongs to C and X does not belongs to B. Here very, very important point. As we know that A is subset of B, we need to consider this first. What is the given data? I'll write here given. What they given? They given that A is subset of B. Okay. As A is subset of B and X does not belongs to B, then X definitely does not belongs to A. We did this in a miscellaneous exercise only. Second problem, last bit you see. In miscellaneous exercise, second problem, last bit. When A is subset of B and X does not belongs to B,
implies x does not belongs to A also. So here what I can write here, x belongs to C and x does not belongs to A. Since we know this result, since A is subset of B, comma, since A is subset of B and x does not belongs to B implies x does not belongs to A. We know that this result is true. We know this result. We proved in second miscellaneous exercise second question last bit. So here what I got that x belongs to C and x does not belongs to A. From this what I can say? I can say that x belongs to C minus A. C minus A means what? All the elements present in C but not in A. You see here x is the element present in C but not in A. So what I got here, when A is subset of B, then C minus B is subset of C minus A. I hope you understand this. I'll conclude here. Therefore, if x belongs to C minus B implies x belongs to C minus A we got. As you got that x is there in C minus B and x is there in C minus A, what I can conclude here? I can conclude that C minus B is subset of C minus A. I hope you understand this. You observe this sixth question. What they are asking. Assume that when P of A equal to P of B, then show that set A equal to set B. Okay, this is little difficult to explain. So that's why first try to understand what is A, what is P of A. I taken one example here, set A equal to 1, 2. Then what is power set of A? Power set of A is set of all subsets of set A. In this set, how many elements are there? 2 elements are there. Number of subsets of A is what? 2 power number of elements in set A. That is 2 power 2. 4 subsets you will get for set A. Here I written all the subsets of set A. Here you need to understand one point. If 1 belongs to set A, then definitely singleton set 1 belongs to P of A. I hope you understand this. If 1 is there in set A, then definitely singleton set 1 belongs to P of A. Clear or not? Look here. If 2 belongs to A, 2 belongs to set A or not? Yes. If 2 belongs to set A, then singleton set 2 belongs to P of A. Without any doubt, you can observe here. Singleton set 2 belongs to P of A. Okay. So here the point is, first I'll write the given data. What is the given data? Given data is power set of A equal to power set of B. What I want to prove? I want to prove that A is subset of B. When we say two sets are equal, when A is subset of B and B is also subset of A, when these two holds good, then we say that the sets A and B are equal. Okay. First, I'll try to prove that A is subset of B. Okay. I am trying to prove that A is subset of B. Okay. How to prove that A is subset of B? Very simple. You take one element X in set A. You simplify. At the end, in case if you got like this, X belongs to B, it tells you that all the elements present in set A are present in set B. Then we can say that A is subset of B. Okay. So, to prove A is subset of B, first I'll take randomly one element in set A. Let X belongs to set A. If X belongs to set A, then definitely the singleton set X belongs to P of A. I hope you are understanding. You observe here, if 1 is there in set A, singleton set 1 definitely will be there in P of A. Okay, as the given P of A is same as P of B, in place of P of A, I can write P of B. Try to understand. In place of P of A, I can write P of B. Why? Because since in the given question, they given that P of A is same as P of B. Please try to understand here one point very clearly. If singleton set X belongs to P of B, it is 100% clear that X belongs to B. I hope you are understanding. This is the tricky part here. Okay. So what happened here? Therefore, X belongs to A implies X belongs to B. So what I can say? I can say that A is subset of B. You consider it as 1. Similarly, we can prove that B is subset of A. In exam, you can write, similarly we can prove that. But I just want to prove the second one also. B is subset of A. I want to prove that B is subset of A. How to prove B is subset of A? Very simple. I'll take one element x in set B. I'll take one element x in set B and I'll simplify. At the end, if I get that x belongs to A, then I can say that B is subset of A. So to prove B is subset of A, first I need to take one element in set B. Okay, let x belongs to set B. Okay, I taken x belongs to set B. If x belongs to set B, it is 100% clear that singleton set x definitely belongs to P of B. In the question, they given that P of A is same as P of B. So what I can write here, singleton set x definitely belongs to P of A. Why? Since they given that P of B is same as P of A. So in place of P of B, I written P of A. It is very clear that if singleton set x belongs to P of A, then definitely x belongs to A. So what happened here? Therefore, x belongs to B. I started with x belongs to B. At the end, I got that x belongs to A. From this, what I can say? I can say that B is subset of A. You observe, first one is what? First one is A is subset of B. Second one is what? Second one is B is subset of A. So what I can say here? Therefore, from 1 and 2, what you can say from 1 and 2, we can say that A equal to B. I hope you understand. This is little tricky problem. Only the point you need to understand that if 1 is present in set A, then singleton set 1 definitely belongs to P of A. This is the tricky part. If 2 is present in set B, then singleton set 2 definitely belongs to P of B. I hope you understand this solution. Observe this question number 7. What they are asking. Is it true that for any sets A and B, P of A union P of B. Here P of A means power set of A. P of B means power set of B. P of A union P of B equal to P of A union B. Justify your answer. Okay, here I'll try to explain this with example. Let any two sets A comma B. I'll take sets like this. Set A is 1 comma 2 and set B is 1 comma 3. I considered two sets like this, A and B. First, I'll calculate P of A. You know what is P of A? P of A means power set of A. What is the definition of power set of A? Set of all the subsets of A. Now you need to write all the subsets of set A. Empty set is subset of every set. So I written that singleton set 1. You observe that this is subset of A. At the same time, singleton set 2 is also subset of A and this is also subset of A. I written P of A. Now I'll write P of B. What is P of B? Set of all subsets of set B. I'll write P of B. You observe set B. I'll write all subsets of set B. First, empty set is subset of every set. So I'll write empty set. 1 is there in set B. So singleton set 1 will be there in P of B and singleton set 3 will be there in P of B and every set is subset to itself. So the set 1 comma 3 also will be there in P of B. Now I'll write P of A union P of B. Okay, so P of A union P of B. First I'll write all these elements, empty set and singleton set 1, singleton set 2 and the set 1 comma 2. Now you write all the elements of this set, but you check that suppose this element I need to write, but this is already listed, no need to write it again. Now I need to write this element. This element is also already listed, no need to write it again. So this element is not yet listed here. So I'll write that singleton set 3 and singleton set 1 comma 3. Okay, now what I got here? I got P of A union P of B. As we have sets A and B, I can write A union B. So you try to calculate A union B. How to write A union B? First you write all the elements of set A. 1, 2. Now you write all the elements of set B. Now I need to write 1, but 1 is already listed in A union B. So no need to write. Now I need to write 3. 3 is not listed here. So A union B is 1, 2, 3. Now I need to write P of A union B. P of A union B means power set of A union B. The set of all the subsets of A union B. So we know that empty set is subset of every set. First I'll write that and singleton set 1 is there in P of A union B. Singleton set 2 is there in P of A union B. Singleton set 3 is there in P of A union B. And 2 element subsets for set A union B. What I am doing, I am writing all the subsets of this set. Okay, 1 comma 2. Next 1 comma 3. Next 2 comma 3. Next 1 comma 2 comma 3. How many subsets we will get for this set? This set contains 3 elements. Na? Number of subsets is 2 power 3. 2 power 3 means 8. You observe 1, 2, 3, 4, 5, 6, 7, 8. I written all the subsets of A union B. So now I have P of A union B also. Now you observe this 1 and 2. You take this as 1, P of A union P of B, and P of A union B as 2. Are these two sets are equal? You can easily understand that in P of A union B this element is there. That element is not in this set. So from 1 and 2 we can easily say that from 1 and 2 what they are saying, is it true? Is it true that P of A union P of B equal to P of A union B? No, this is not true. This is false. From 1 and 2 we can say that P of A union P of B is not equal to P of A union B. So given statement is not true. I hope you understand this. Now we'll move to next problem. You observe this question. What they are asking in this question, show that for any sets A and B, A intersection B union A minus B equal to A, and A union B minus A equal to A union B. I don't want to confuse you by taking by taking an element X in this set and that X belongs to this set. I don't want to do like that. This problem is very easy if you do this problem with the help of Venn diagram. I'll try to do this problem with the help of Venn diagram. Okay, you can observe here total 2 sets are there. A, B. In the question, A, B, 2 sets are there. So I'll draw those 2 sets. This is set A, okay, and set B. This is set B. Okay, total 2 sets I taken, set A, set B. Okay, this is set A, this is set B. I want to prove this result. For that, you please observe A intersection B. Where is A intersection B in this Venn diagram? You see this zone here, the middle part. This is the zone which is A intersection B. This we learn while learning intersection of sets. Which part is A intersection B? All those things we learn. This part is A intersection B. You observe where is A minus B in this Venn diagram. Where is A minus B? We know that A minus B means all the elements present in A but not in B. Simply we say that A minus B means only A. So here A minus B part I am marking here. Please observe whatever this pink color one is there. What is this? This is only A. All the elements present in A but not in B. Try to understand this please. What I am drawing here, that is A minus B. This is A minus B. Okay. Now union of these two things, A intersection B union A minus B. What is this? Actually I'll name it as 1 and I'll name it as 2. So what is A minus B union A intersection B? Union, this is not intersection. Here we can easily say that. I'll name here this as 1 and this as 2. This shaded part 1 plus shaded part 2 will gives you what? A intersection B union A minus B. Is it clear? What I written here, is it clear? Union means all the elements present in this set, then it present in its union. It can be understood easily. When I do the union of these two things, I'll get 1 plus 2. And you try to understand one more thing here. This is set A na. Set A is nothing but 1 plus 2. From Venn diagram we can understand. So here I'll write from Venn diagram 1 plus 2 is same as set A also. So what I can conclude here? I can conclude that therefore A intersection B union A minus B equal to A. That's it. I hope you understand. I proved this first bit. Now you observe that I'll prove this second one. A union B minus A equal to A union B. Okay, I'll prove this by using Venn diagram. Okay, so I need to prove this one. A union B minus A equal to A union B. First, I'll identify what is A union B. You observe in this diagram which part is A union B. Which part is A union B? You please observe here whatever I am marking this part. This is A union B. We learned this in while learning operations on sets, while learning union of sets definition. I explained clearly over there what is A union B in this Venn diagram. See, whatever this pink color part is there, what is this? This is A union B. This part is A union B. Okay. This full shaded part is A union B. Okay. Here one point is A union B is nothing but, I'll name this part so that we can easily identify. This is first part, this is second part, this is third part. Part 1 plus part 2 plus part 3 will gives you what? It will gives you A union B. Now you observe this left hand side part, A union B minus A. A means what? 1 plus 2. Is it clear? A means 1 plus 2. Please observe. A is nothing but 1 plus 2. Clear? Yes, A is nothing but 1 plus 2. What is B minus A? B minus A is nothing but part 3. Please try to understand. B minus A is nothing but part 3. All the elements present in B but not in A. Union means we'll add all these things. Try to understand. So here what I'll write here, A is equal to 1 plus 2. A is 1 plus 2. Okay. B minus A is what? B minus A is third place. Okay. So what I want here, A union B minus A. A union B minus A. A is what? 1 plus 2 plus union means we need to write like this only. So you observe here, you take this as 1. A union B is 1 plus 2 plus 3. A union B minus A is also 1 plus 2 plus 3. So what I can conclude here? I can conclude that A union B minus A equal to A union B. This is the easy way of proving this problem, question number 8, with the help of Venn diagrams. I don't want to confuse you by saying X belongs to so and so set and X belongs to another set. One set is subset of another set. It is little confusing to many students. So as they are asking to show that, so I shown this with the help of Venn diagram. Ninth problem also I'll follow the same procedure. You see this ninth problem, what they are asking in the ninth problem, show that these two sets are equal. These two sets are equal. I just want to prove this with the help of Venn diagram. I want to prove these things with the help of Venn diagram. Okay. You observe here left hand side part, A union A intersection B. A means here what is set A? Here best thing is I'll give the names. This is 1, this is 2. 1 plus 2. 1 plus 2 is set A. Correct? What is A intersection B? You observe this part is there na? This part is A intersection B. So second part is A intersection B. You please observe here what is set A. Set A is first part plus second part. Okay. What is A intersection B? A intersection B means second part. Right. So when we do union A intersection B is what? Is 1 plus 2. It can be understood easily from the Venn diagram. So here you please observe, you take this as 1 and you take this as 2. You observe set A is 1 plus 2 and A union A intersection B is also 1 plus. So what I can conclude here? I can conclude that A union A intersection B, which is same as A. It can be understood very easily with the help of Venn diagram. I hope you are understanding. Now second bit, A intersection A union B. We need to prove this. A intersection A union B. Okay. First A. What is set A? Here I'll write set A is nothing but 1 plus 2. Correct? Set A is nothing but 1 plus 2. Please try to understand. This whole thing is set A na? This whole thing is set A na? Set A is nothing but this 1 plus 2. Okay. Now you come to left hand side part. A intersection A union B. Okay. So where is A union B? Here intersection. Intersection means common part. Try to understand what is A union B. Here I'll write A union B is nothing but part 1 plus part 2 plus part 3. I hope you are understanding. This part plus this part plus this part. That is A union B. Now A intersection A union B. That means the part which is common in A as well as A union B. What is A? A is 1 plus 2 only. What is A? A is 1 plus
2. I want to do intersection of these two, right? A intersection A union B. In these two sets, in this set part 1, part 2, part 3, set A is 1 plus 2. What is the common part in both? 1 plus 2. 1 plus 2. I hope you are understanding. 1 plus 2 is nothing but set A. So what I can say? I can say that A intersection A union B equal to A. A intersection A union B equal to A. Hence, we proved it. I hope you understand. 8th question, 9th question. Understanding with the help of Venn diagram is very easy. Now, move to 10th question. You observe this 10th question. What they are asking. Show that A intersection B equal to A intersection C need not implies that B equal to C. I'll try to show this with a counter example. So, here I'll take 3 sets ABC like this. I'll take set A like this. A equal to 1, B equal to 1, 2 and set C equal to 1, 2, 3. I taken like this. Okay. Here you observe what is A intersection B. First you write set A and intersection set B 1, 2. You identify the common elements in both. What are the common elements in both? That is 1. So what you will get when you do A intersection B? You will get singleton set 1. Now you calculate A intersection C. A intersection C. What is set A? 1. Intersection. What is set C? 1, 2, 3. What are the common elements you identify? 1 is the common element in both. So A intersection C is what? Singleton set 1. Now you observe here A intersection B, A intersection C both are same in this example. But here it need not implies that B equal to C. You see that the sets B and C are not equal. So what I can say here, therefore A intersection B equal to A intersection C. Therefore A intersection B equal to A intersection C need not imply B equal to C. I hope you understand this. You observe this 11th question. What they are asking, A and B are two sets. They given that A and B are two sets. And if A intersection X equal to B intersection X and both are equal to empty set and A union X equal to B union X for some set X, show that A equal to B. Here some data already given. We proved these things with the help of Venn diagram in question number 8. A intersection A union X equal to A. The set B is nothing but B intersection B union X. These things we can understood very easily with the help of Venn diagram. Okay. Right. So we need to solve this problem. First, I'll write the given data. What is the given data? A intersection X equal to B intersection X equal to null set. A union X equal to B union X. This information they given in the question. Okay. Now I need to prove that. Set A equal to B. So what I'll do here, I'll use this given data. In the hint they given A can be written as A intersection A union X. So I'll write that one. A can be written as A intersection A union X. Okay. This equal to A intersection. You observe here A union X is same as B union X they given. In the question only they given that A union X is same as B union X. In place of A union X, I can write B union X. Correct? Okay. Now, distributive law. From distributive law, this can be written like this. A intersection B union A intersection X. Okay. So, A intersection B union A intersection X. You observe in the question they given that A intersection X is null set. A intersection X is null set. So in place of A intersection X we can write null set. So A intersection B union null set. Here you need to know one point. When A is subset of B, here all the elements present in A are present in B. When A is subset of B, here A is smaller set, B is bigger set. So when we identify A is subset of B, then A union B always gives the bigger set. A intersection B always gives the smaller set. So these things we already discussed in earlier problems also. When A is subset of B, A union B is B, A intersection B is A. Here empty set is subset of A intersection B because empty set is subset of every set, right? When empty set is subset of A intersection B, A intersection B union null set is what? Bigger set you will get. That is nothing but A intersection B. So here what you will get, this is nothing but A intersection B. So I got A equal to A intersection B. I'll take it as equation 1. Now I'll use this data. What they given? B equal to B intersection B union X. This is what they given. Now this equal to B intersection. Here B union X is there. Na? You observe B union X is same as A union X. In the question they given that B union X is same as A union X. So in place of B union X, I'll write A union X. So in place of B union X, you write A union X. Okay. That equal to, this can be written as B intersection A union B intersection X. Okay. B intersection A. B intersection A union. What is B intersection X? In the question only they given that B intersection X is null set. B intersection X is null set. So in place of B intersection X, I can write null set. You can observe here, null set is a subset of B intersection A, and we are doing union of these two sets. So obviously bigger set you will get, that is nothing but B intersection A. We know that in properties of intersection of sets, A intersection B is same as B intersection A. A intersection B is same as B intersection A. So what I got here, B equal to A intersection B. You observe what is the first one? First one is A intersection B equal to A. What is the second one? A intersection B equal to B. From these two things, we can easily say that the sets A and B are equal. Therefore, from 1 and 2, therefore from 1 and 2. What I can say? 1 and 2, I can say that the set A equal to set B. I hope you understand this solution. Please observe this question number 12. What they are asking. Find sets A, B, C such that A intersection B, B intersection C, A intersection C are non-empty sets, and A intersection B intersection C is empty set. Here they are asking us to find three sets ABC such that A intersection B, B intersection C, A intersection C are non-empty set. That means not empty sets. At the same time, when we do intersection of all three sets, we must get empty set. Let's find out some examples. Actually, these are the things I am just finding randomly. You may find some other different sets also. I'll take set A as 0, 1. Okay. And set B as 1, 2. Set C as 2, 0. Okay. Now what I'll do, I'll calculate A intersection B. A intersection B. A intersection B. Okay. You observe what are the common elements in set A as well as set B. One is the element which is common in both. So A intersection B is singleton set 1. In the same way, I'll calculate B intersection C. Okay. B intersection C. First, I'll write set B 1, 2 intersection set C 2, 0. In these two sets, you observe which element is common. 2 is common in both. So, B intersection C is 2. Now, you calculate A intersection C. What is set A? Set A is 0, 1. Intersection. What is set C? Set C is 2, 0. What is A intersection C? What element is common in both? 0 is the element which is common in both. So, what you will get here? 0. You can observe A intersection B is non-empty. B intersection C is also non-empty. A intersection C also non-empty. Now, you calculate A intersection B intersection C. Okay. So, what is set A? Set A is 0, 1. Intersection. What is set B? Set B is 1, 2. Intersection. What is set C? Set C is 2, 0. You identify the elements which are common. You identify the elements which are common in all three sets. If you take 0, 0 is present in two sets only, which is not present in all three sets. We need to find the elements which are common in all the sets. If I take 1, 1 is present in these two sets only.
one is not present in this set. If an element present in all three sets, that element only comes in A intersection B intersection C. You cannot find any element which is present in all three sets. So A intersection B intersection C is a null set. So here this is the example. What they are asking, find sets ABC satisfying these conditions. So here this is one example which satisfies all these conditions. I hope you understand this solution. Now move to 13th question. You observe, in this type of questions, understanding the question is the tricky part. In a survey of 600 students, a survey is done for 600 students in a school. Okay, 150 students were found to be taking tea. 150 students were found they are taking tea. Okay, 225 taking coffee. Okay, 100 were taking both tea and coffee. Find how many of students were taking neither tea nor coffee. That means the survey is done on 600 students. In the 600 students, how many students were taking neither tea nor coffee? Okay, before that, let me write some given data. Later, I'll try to explain clearly. Here, the students who are taking tea are there. So, I'll write number of students who are taking tea. What we are considering? Number of students taking tea. Number of students taking tea as N of T. Here, in the question they given, 150 students were found to be taking tea. So N of T is what? N of T is 150. Here they given T na. So here N of T is 150. That means this part, in this part, total 150 members are there who are taking tea. Further, if we see 225 taking coffee. You observe this, I written that number of students taking coffee. This is also let only. I am taking like this. Number of students who are taking coffee as N of C. From now onwards, in this question, N of C means number of students who are taking coffee. In the question, they given that 225 taking coffee. So I'll write here 225. Okay. Here 100 were taking both tea and coffee. 100 were taking both tea and coffee. That means they given N of T intersection C. N of T intersection C is 100. 100 were taking both tea and coffee. Okay. Find how many students were taking neither tea nor coffee. Here, simple thing, man. Here they given N of T intersection C is 100. Na? See, this is the zone. We know that number of people who are taking both tea and coffee. They given that this zone is 100. Okay. So here I'll write 100 first. Next point. Number of students who are taking tea is 150. That means you observe this full. The number of students who are taking tea is 150. This full is 150. In this full, this part is 100 now. So obviously this part will be 50 because N of T is 150 now. I hope you are understanding. So the number of people who are taking tea only, if that is the question, then answer is 50. The number of students who are taking tea only, if they ask, from this 150, you need to remove 100, you will get 50. Okay. And they given that number of students who are taking coffee is 225. That means this is number of students who are taking coffee. This is given as 225. In this 225, this part is for 100. Then what about this part? This part is 125. 125 plus 100 is 225. So the number of students who are taking coffee only is 125. Here the point is find how many students were taking neither tea nor coffee. Actually, that students present in this zone, please try to understand. In a survey, total 600 students are there. Actually, this N of universal set, that means number of students are taken on 600 students. So, this full is 600 students. Please try to understand. This full is 600 students. Okay. Where are the students who are taking neither tea nor coffee? You observe in this zone, whoever the students are present, they were not taking tea, they were not taking coffee. I need to calculate this number. How to get this number? Very simple. This full is 600. Na? From this 600, if I remove this, then I'll get number of students who are taking neither tea nor coffee. So I'll write number of students number of students taking neither tea nor coffee equal to, here total survey done on 600 students. Na? From 600, if I remove this part, whatever the remaining part is there, in this part the students are there who are neither taking coffee nor tea, right? So 600 minus 50 plus 100 plus 125, okay, that equal to 600 minus, here 50 plus 100 is 150, 150 plus 125, 275, right? So 600 minus 275, 600 minus 275 is 325. So the number of students who are taking neither tea nor coffee equal to 325. I hope you understand this solution. 100 students know Hindi, 50 students know English, 25 know both. Okay, here two languages are there, Hindi, English. Each of the student knows either Hindi or English. This is important point. Each of the students in a group, each of the student knows either Hindi or English. Whoever the members are there in group, each of the student knows either Hindi or English. Okay, in that group, if I take one person, one student, that person knows either Hindi or English. Okay, how many students were there in a group? Okay, you observe here, I taken let number of students who knows Hindi, I taken it as n of h. In this problem, n of h means number of students who knows Hindi. Here in the question, they given that 100 students knows Hindi. So here n of h is 100. Now, and they given that 50 know English. You observe here, I written number of students who knows English. I taken it as n of e. They given that 50 know English. So I'll write here 50. And if you can observe that 25 know both, that means n of h intersection e is 25. H intersection e means the number of people who know Hindi as well as English is 25. This data they given. Now what they are asking, how many students are there in a group? Here, this is the important point. Each of the student knows either Hindi or English in that group. That means how many people are there in group means n of h union e. If I take like this, what is this n of h union e? The number of people who knows Hindi or English. The number of people who knows Hindi or English. Here in a group, each of the student knows either Hindi or English. That means to calculate how many number of people are there, how many number of students are there in a group, if you calculate n of h union e, this is enough, because number of people who knows Hindi or English they are asking. Na? In a group, each student knows either Hindi or English. So finding how many students are there in the group is nothing but first find number of students who knows either Hindi or English. From that we can easily say number of students in that group. Okay, so here n of h union e we need to calculate. We have direct formula for this. N of h plus n of e minus n of h intersection e. Okay, n of h union e we need to calculate. N of h they given in the question as 100 and n of e they given it as 50 plus 50 minus n of h intersection e is 25 minus 25. 100 plus 50, 150. 150 minus 25, 125. So number of students who knows Hindi or English equal to 125. Here from this only we can say number of students in the group is 125. Therefore I'll conclude number of students in the group equal to 125. I hope you understand this solution. You observe this question number 15. In this question, understanding the question is tricky part. You observe what is the given data. In a survey of 60 people, it was found that 25 people read newspaper H. So what I'll do here, I'll write one by one what the given data. 25 read newspaper H they given. I'll write N of H. In this question, N of H means number of people who read newspaper H. They given 25 read newspaper H. So I written that N of H is 25. Okay. And they given 26 read newspaper T. Okay. I'll write that also. N of T is 20. 26 read newspaper T. Okay. After that they given 26 read newspaper I. Okay. N of I is given as 26. 26. Okay. Now if you observe further this one, 9 read both H and I. 9 read both H and I. That means N of H intersection I. N of H intersection I equal to 9. Okay. And 11 read both H and T. 11 read both H and T. N of H intersection T equal to 11. Okay. And 8 read T and I. N of T intersection I equal to 8. Okay. And this is the important in this question. What they given? 3 read all newspapers. 3 read all newspaper. That means N of H intersection T intersection I. They given it as 3. 3 read all 3 newspapers. This is going to play crucial role here. Okay. Now what they are asking, find the number of people who read at least one of the newspaper. At least one of the newspaper. See, by this time, as this is miscellaneous exercise, we are almost all at the end of miscellaneous exercise. After reading the first bit, we can understand that they are asking us to calculate N of H union T union I. Okay, we have formula for N of H union T union I. What is the formula for N of H union T union I? What is the formula? The formula is N of H plus N of T plus N of I minus N of H intersection T minus N of T intersection I minus N of I intersection H plus N of H intersection T intersection H. This first bit is actually very direct problem. So you just write the values. We know what is N of H. N of H is 25. N of T is 26. N of I is also 26. You write those things. 25 plus 26 plus 26 minus N of H intersection T. N of H intersection T is 11. N of T intersection I is 8. N of H intersection I is 9. So what I need to write here, H intersection T is 11 minus T intersection I. T intersection I is 8 minus I intersection H is 9 plus N of H intersection T intersection H. H intersection T intersection I is 3. Okay. Just given data I substituted. So here 25 plus 26 plus 26 is what? This is 77. Okay. 77 plus 3. 77 plus 3. If we add all these things, 77 plus 3 is 80. So you will get 80 here. 80 minus of, you observe, you need to add these 3 things. What you will get? 11 plus 9 is 20. 20 plus 8 is 28. So here minus 28 you will get. So what we want now? 80 minus 28. 80 minus 28 equal to 52. So for the first bit, the answer is 52. I hope you understand this. You observe the second bit, the number of people who read exactly one newspaper. The number of people who read exactly one newspaper. Many students confused to understand this problem. Actually, it is very easy if we do this problem with the help of Venn diagram. First, I'll write the given data from the question. See, this is the given data from the question. In this is very important. In this is very important. H intersection T intersection I is 3. In this zone is there. I hope you can see this. This is the zone in which all 3 newspapers are there. 3 read all newspapers. Right? Okay. Now you observe this zone. What is this part? This part is number of people who read H and T. The number of people who read H and T. That means H and T, you can look here, H and T is given as 11 here, right? This part is 11. So 11 minus 3 is what? 11 minus 3 is 8. So here I'll write this as 8. Now what is this part? This part is T intersection I. You look here, T intersection I is 8. As this is 3, so this will be 5. So I'll write 5 here. Okay. Now you observe what is this part. This is H intersection I. H intersection I is given as 9. As already this is 3, this part is 6. Okay. Now important thing is what they are asking in the question. The number of people who read exactly one newspaper. You see, in this zone, whoever the people are there, they read only H. In this zone, whoever the people are there, they read only H. This you need to calculate. This is number of people who read T only, who read newspaper T only. In this zone, whoever are there, they read only newspaper I, only I. So first I'll calculate this red color part 1, and then if I add all these 3 parts, what I'll get? The number of people who read exactly one newspaper I'll get. I hope you understand the point now. Okay, so first I want to calculate this one, the number of people who read H only. So I'll write here, who read H only. Right, how to calculate that? This N of H is given 25 na? 25 minus 8 plus 3 plus 6. Okay, here I'll write this, 25 minus of 8 plus 3 plus 6. If I calculate this, I'll get number of people who read H only. Okay, this equal to, so 25 minus 8 plus 3 plus 6 is 17. So 25 minus 17 is what? 25 minus 17 is 8. So you observe here this zone I got. The number of people who read H only is 8. Okay. Now this is important. Actually we are looking for this part. This part is there. Na? This part I got it as 8. Very good. Now I want to calculate this part. The number of people who read T only. So here N of T only. Actually here N of T they given as 26 na. From 26 if I subtract these numbers then I'll get this part. Okay. So 26 minus of 8 plus 3 plus 5, that equal to 26 minus here 8 plus 3 is 11, 11 plus 5 is 16. Okay, so 26 minus 16 is 10. So I got this zone as 10. So the number of people who read T only is T. Now number of people who read I only. So here you see here this full they given as 26 in the question. From 26, I'll remove these things. 26 minus of 6 plus 3 plus 5. That equal to 26 minus 6 plus 3 is 9. 9 plus 5 is 14. 26 minus 14 is 12. Okay. So I got this part as 12. I got this part as 12. Okay. So the point is what they are asking in the question. The number of people who read exactly one newspaper. That means whatever the colored part is there here, that we want. So number of people who read exactly one newspaper equal to. Therefore, the number of people who read exactly one newspaper equal to 8 plus 10 plus 12. You observe here 8 plus 10 plus 12. So what you will get here? 12 plus 8 is 20. 20 plus 10 is 30. So the number of people who read exactly one newspaper is 30. I hope you understand this solution. Observe the question. In a survey, it was found that 21 people like product A. The number of people who liked product A is 21. So I'll write that first. N of A means the number of people who liked product A. It is given as 21. So the same thing I written here. N of A is 21. This is set A, this is set B, this is set C. Next, 26 liked product B. That means N of B is what? N of B is 26. Okay. What about N of C? 29 liked product C they given. So N of C is 29. Okay. Here what they are asking, you try to understand. Find how many liked product C only. Where is the product C only part? You observe, see, this is the part here, the people who like product C only. This is the set C. Here I want to calculate this part. After reading the question, I understand that I need to calculate this part, the number of people who like product C only. For this, if you observe here, 8 liked all 3 products they given. 8 liked all 3 products. So first you write in this diagram 8 liked all 3 products. Na? So this is the zone. It can be understood easily. This is the zone. In this zone, whoever are there, they like all 3 products. In the question they given 8 liked all 3 products. This is important one. Actually, to calculate this zone, I need this number as well as this number. What is this? This is number of people who liked product B and C. You observe the question. Where are the people who liked both B and C? You look here, 14 liked product B and C. 14 liked product B and C. So I'll write that N of B intersection C equal to 14. 14 like the product B and C. So this full part is 14. Already here this part is 8. So what is this? This will be 6. 8 plus 6 is 14. So here I got this as 6. Now I need to calculate this one. What is this full part actually? This is the number of people who like product A and C. Where are the people who like product A and C? You look here. 12 people liked product A and C. 12 people liked product A and C. N of A intersection C equal to 12. N of A intersection C. Where is A intersection C? This is A intersection C. This A intersection C is 12. Actually, we have 8 here now, so this will be 4. Okay, so this is 4. 8 plus 4 is 12. Right. Now, the number of people, what they are asking in the question, how many liked product C only? Product C only, I'll write here. Number of people who liked only C is, this full is what? This full is 29. From 29, if I subtract these numbers, then obviously I'll get C only now. So what I'll write here, this is 29 minus of 4 plus 8 plus 6. I hope you understand. 29 minus of 4 plus 6, 10. 10 plus 8, 18. 29 minus 18. 29 minus 18 is 11. So the number of people who like product C only is 11. So no need to write all given data in the question. So what they are asking? They are asking us to calculate number of people who like product C only. In this way, this problem I did with the help of Venn diagram. So with the help of Venn diagram, you can understand the question very easily instead of going with formula method. I hope you understand this solution. With this, all miscellaneous exercise problems are completed. See, compared to exercise problems, miscellaneous exercise problems are little difficult. Practicing once or twice is necessary for miscellaneous exercise problems in sets chapter. After this, you are going to find videos on JEE as well as all state level competitive examinations like KCET, Maharashtra CET and MCET, such type of examination.